Alrighty then. Let me go ahead and share my screen. And then we can get started. All right, so there we go. Can everybody see that okay?
Yeah.
Sweet. I'm gonna keep it small today because my other screen that I have on my desk is not cooperating, okay? But I still got you guys. All right. So what we're seeing today is day 7. We're gonna be talking about in network and security, some synchronization and different things like that. You'll also should be on day 7, somewhere around day 7 in your syllabus and on campus, so we can get started. So today, you'll see that we'll primarily be in domain 1.4, or domain 1, domain 3, and domain 5. Protocols, traffic, again, talking about IPv4, troubleshooting common network issues, and then use appropriate tools to, again, solve the issues that we have going on with that, okay? I have you halfway off my screen on one side, so I can't see the chat. So you might have to, if you need something, just open your mic and yell at me, okay? So you can catch my attention.
Yeah.
All right. So if we're looking at that, explaining application and services, this is what we're getting into. We're going to explain the importance of time synchronization and the role of NTP. Can anybody remember what the port is for NTP, Network Time Protocol? Ticka, 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 ticka.
Network Time Protocol.
Anybody remembers that?
1, 2, 3.
Yep, you got it. 1, 2, 3. A, B, C, easiest 1, 2, 3. Sounds like NTP. See, I'm cracking your eardrums early in the morning. Gotta love it. Next, explain the use of web, file, print, and database services. Now, when we start looking at web, file, print, fax, email or scan the email, we start using what they call server message block, SMB port 445. You'll start seeing that for multimedia to be delivered through a server, where it's kind of like changing it from one medium to the next. And SMB is one of those ports that can be hacked. It's very vulnerable. So you'll see like multifunctional devices, they will be exploited because they'll get into the settings of that and get into all the save, faxes, email, and all that, and they can download that stuff because some people don't dump stuff that's in printer cache. So that's a very valuable thing. Explain the use of email and voice services, and then we talk about redundancy. So as we get into it, this is what we got. If we start with transport layer security, TLS, we're looking at the layer, a protocol, and you'll see this interchangeably, TLS and SSL, TLS, SSL. And pretty much they're putting encryption and keys are happening at this point to make sure that the integrity of your data is good to go. Okay, so it encrypts the data. With that, you have to have a server. What type of server will you have if we're talking about authentication? We want to authenticate somebody. So what type of server are we in? Radius, good job. You'll use a Radius for VPN or a Taco Tuesday. What's the real name for a Taco Tuesday? TACAS, yes. Terminal Access Control access control system. Oh my God, could have they have made that much more difficult to say? Could they have done that? I think they could have. So when we talk about Taco Tuesday, that's what we're talking about. Give me 1 second. This thing's acting wonky. All right, we'll just go with this. So with that, so you have your authentication server. You have the radius that's cool for VPN and somebody who's trying to get into the network from an exterior component, right? Or a client. Taco Tuesday, who's primarily going to use that to administer the network?
Taco Tuesday.
Hitting y'all with the quizzes early in the morning. Body shots. So who uses the Taco Tuesday to administer the network? Yes! Michael got it. You're sysadmin. That'd be you. You're network administrator. You got to make sure that the integrity of the system is good to go using TLS. And with the TLS handshake, this is what we have with the transport layer security. When segments start going out, when a connection is made, the client sends a hello server. Server says, hello, Mr. Client, how are you doing today? Then what happens, the initial key exchange will happen. Client exchanges a key, session key will be established, and then the server at the end of the whole conversation will finish up and say, I'm done. When we start looking at Wireshark, you'll start seeing the connection as it goes back between the client and the server. In Wireshark, you will see it because they don't have a column right in the middle, and it says, well, right toward the second to last column to the right, and it'll say what protocol is being used with TLS SSL. It tells you UDP, TCP, quick, right? TLS, like it'll tell you what protocol is being used as the traffic is traveling. And then when the server is completed, you'll see this one thing that the server will do at the end of the conversation is say fin for finished. That's when the server terminates, right? The conversation. That's like talking to your bank saying, excuse me, I have $50,000 in my account. What happened to it? Oh, here it go. You transferred it. Oh, I didn't know I did that. Yeah, you did. Well, it seemed like I only I transferred 5. Well, you put an extra 0, ma'am. Okay, well, I got it. Okay, anything else I can do for you? No, that's it. Okay, we're finished. That's what happens in the chat. We're finished. We're done. So the server's done talking to you, and it waits for something else to do. All right, for another client to come in. With the network time protocol, this is very important. I cannot stress enough.
Network
this is
time
very
protocol.
important. We learned in 1201 that there is something that ensures that data, when it goes through the buses, right? What ensures that it is synchronized when it's on a motherboard, when that data is moving on a mobile. Strictly on a mobile. What's making sure everything moves? CMOS? Yes, it's the motherboard.
Hey, how are you doing?
Yeah, it's the clock. The atomic clock on the board. It's making sure that data gets in where it fits in. Everything is, it don't stop, can't stop, won't stop. Everything's like this. So what makes you think when it comes down to data, when it leaves the mobile, there has to be the same kind of synchronization for it to cross multiple platforms?
Same here as well. Class as usual.
Network time protocol.
If you missed my my
Now this is what
my evening video, you can check it out.
We know that in our computer,
I had another video
if
that
you
I
were
did
to
last night as well.
type clock bring up the clock and you want to synchronize,
Should be in the live
there's
section
something
of my
there
playlist.
that shows you that you can synchronize your computer clock with a server. You can check
Oh,
that
this
box,
this particular live
and
stream
your
is
computer's
mainly
time
about
will
just
instantaneously
just
be
me being in
connected to the
class,
server's time. Therefore,
learning IT
servers has the options on the
and
network to go
cybersecurity.
two
So
ways.
this is class
The server
mainly
can
about
synchronize the clock
earning the
to the
certification
world
for
clock,
cybersecurity and information technology.
or
My
Michael
other
was talking about
lives
this. You'll have a device on your
incorporate a lot more
network that
different
synchronizes
things.
time for you for every client that connects to the server. So you'll use the server time. It's a little clock
Yeah,
that
so
you can
currently
buy.
throughout
It's
the
a network
daytime,
level time clock. It's about this big.
I'm in
You plug it
class,
up.
just
You
going through
configure it.
lectures and
I swear it's
interview
probably
for
not even this big as this.
certification that I'm
It's a
currently
little
trying to earn
component,
in
and it will keep
IT.
time for your whole network. All right,
Yeah,
just to ensure that synchronization is
I
happening.
love IT stuff too.
So what's the
And
purpose of
also with the
MTP?
given
Let's go.
fact that you really
Synchronize the
use it
system
every day.
time and coordinates universal, your UTC time. Now you can go to the internet and you shall see that
A
there
lot of the
is
time
the
I'm going through
UTC
class
time
and
clock
then
in which
most of
we're
the
talking
stuff that
about.
we're learning about, you start to realize that you use it on your computer every day. Gives you a little bit
Where's
more
my other
insight.
screen? Here we go. Here we go. Screen. Boom. There you go. All right. Here's my cursor. All right. So if we wanted to bring up the internet and you want to see
Oh, that is pretty cool.
network time
No, that
clocks,
is pretty cool. If if you understand it or you're currently in that field
that's what it looks
or
like
you
right there.
have
Looks like a pager, don't it?
you have the knowledge about it, why not teach
This
someone
little
else,
network
right?
time clock.
That is a good
It's
thing.
something you can buy and you can actually put this on your
If someone
network.
else had taught me, then I would
Okay.
have been able to
It even does
do a lot
GPS,
more
Siri,
on
or
my
network.
computer a
It's
long
called
time
the time
ago.
machine, and you could negotiate. You could set this up to put on your network, or you can synchronize.
Also, one of the other things that I've learned recently is that you can have a
Time.club or
software within a
UTC time
software
now.
or like a computer
There's different
system
clocks
running
around
within
the
a
world
computer
that you can
system.
synchronize your computer time with. Okay, in order to keep time for your network. So it's pretty cool. The operation of NTP operates over networks using the UPD protocol on port 123, organizes the
Oh
devices in a
yeah, that
hierarchical manner,
that is to be
indicating the
expected.
distance from the clock,
The average
sending
day
timestamp
individual
messages to
probably
our
won't
network
be as
peers.
much
So
interested as
when
you
your
want
data
them to.
moves, there is a timestamp
You could
on the
try
data,
and teach them, but
and algorithms use and they account
a
for the
lot of
network
people
delay
aren't
in
just
order
that
to
interested
inform
in
you
really
when he's in the time frame.
learning anything beyond the basic use.
You can also use
Not
network
unless it's a
time
career field or a job.
for the good if you are ensuring that people that are supposed to be on your network
But if you are doing
and
that and you can
verifying
show them the
packets and sending
benefits of
bits
it,
as they move around,
I'm
that
pretty
is
sure
fine.
that will help.
What is the name of the security protocol or the security feature you can use? It's not a protocol to ensure packets are delivered on time, but they use a ticket, time and tickets. And if your data is not moving in a certain amount of time with that tick, there you go, Kerberos. That's a network security feature. Kerberos, time and tickets, time and tickets. All right. Your NTP network time
that's pretty
protocol
good.
diagram. Here
Oftentimes
we
you're
have the
surfing the
atomic
internet
clock.
and
Here,
a lot of things you don't
GPS
recognize
on
it.
atomic
It's
clock.
called
All
IT
right.
or computer
This could be
computer
various
language.
ways. All right.
So
This is the first one. Your GPS. This could come from satellites. This could come from anything. That's your stratum 0. That's where it all starts. Then what happens, these network time protocol
Oh, you said you're trying to
servers
explain it in the simplest way,
connect
but
to
there's
these atomic clocks or stratum 0 to ensure
absolutely
now they
understand
can bring
that.
in the correct network time down to stratum 2, which
Most
is
people
the
are
other
distracted
layer
with their daily
of
lives.
NTP servers. And then it brings
It
it
really
down to
takes someone that
your
actually wants to learn about
local
something
network
else. They have to
application
be
and
really
servers.
interested
So you
themselves.
have 1, 2, 3
I think the most you
levels,
can do is to present the
okay,
information to them
where the time, they're
and
passing
to
the time to make sure it's the
show them a
world time
contrasting
clock and the
difference
networks are good to go when they're
or
talking.
how it will help them, and maybe they might,
If you see
maybe
this
they
on the
might.
exam, please know 0 is the hero for time. That's the very first level.
Yeah, just
0
it's
is the hero
majority of people
for time.
won't really be
Okay.
interested, even when it's
And
really
then after
beneficial to
that, they're
them.
just building up once the
So
time
there's only
starts getting
so much that you can
disseminated
do.
down to the network levels and
You
cloud
mainly have
levels.
to educate
And then from
yourself,
there,
and that's where you start. And you can present
now
you
you
can
may
present
have to
that
put
information,
something
but
in place where you need
it's
something that's a little bit more precise.
there's not really
Like
anything you can
people's
do
lives or
beyond
production
the
is
other individual wanting
you
to
have
learn
to
about
have
it themselves.
precise time. Who's ever pulled up an app and they said, "Hey, can we
It's
use your
much easier to just
GPS
look at Instagram, you
or
know.
location services?"
It's the same
One
way,
app
like
will pop up.
it's
Anybody use
easy
that
just to
before?
go
Seen
watch
that before?
TV or something
And then
instead
it
of
says,
reading a book
boop,
or
you say,
learning
yes, you can
something.
use my time.
Most
But then another one comes up and says,
you kind of
you
really have
really
to
want to
fight
have precise location with this app
that
because
short attention
it helps us
span, or
deliver what you
as
need. Have y'all seen that? It's like
the
another bubble.
laziness
And
that
then
come
if you want
upon
to
you
click
not
it,
wanting
or
to
you say,
learn or
no, I'm
do
good with
something that's
generic
beneficial for you,
area
you kind of
searches,
really have to
right?
fight it, because sometimes it's
This
something
is the
that you're
same
not
thing when
used
it comes
to.
down to NTP. So this is PTP, Precision Time Protocol. Who uses this? Industrial.
I would say so, yes.
Industrial processors use this. We're talking about where vehicles are
Yeah,
being
yeah,
made and
unfortunately.
robots they have to rely on precision time
And the
from the
thing
server
is,
in order for the
at some
instructions
point
to
in
be delivered
time,
to the robot
you know,
where
as
they
an
want that.
individual, that I think we
The
were all a part of
carriages
that
or the cars
majority
moving down the
until you
lines has
decide
to
that
be
you
very
want better or you
precise
want
with
to
the
learn
robot
something
working with
different. Then
putting the
it's a
vehicle together.
decision that
That's
you make,
precision
and
time.
eventually
All
you
right.
steer away
So
from
that's when
that.
you'll see that being
So
used. And then
I
5G
think if we
cellular
had to make the
towers, medical
decision to do
devices,
better
financial
or to
services,
learn more,
broadcasting,
then
believe it
it
or not,
happens just the same way for everyone.
multimedia servers that deliver
Sometimes it
your
just take a lot
music,
longer
that new
for other people.
program you're binge watching on Netflix, okay? AWS, all of that stuff uses
Yes, it
precision
is.
time.
It's
So you have the top
it's way
clocks.
easier.
You have the Grandmaster clock. That's the
It's
one
just
that's in
way
charge of
easier because
everything.
it doesn't take any computing or
All right.
learning, you know,
Boundary clock
or
and
brain
ordinary
power.
clock. Grandmaster clock,
But what
boundary
happened is that
clocks.
after you spend hours of scrolling through
Then
and
you
looking at
have
other
your
things,
normal clocks
it goes
that's
away
used.
and you don't remember anything. Not until you start watching
The
it again.
roles, time
But when you
transmitter,
actually
time
take the
receiver,
time to learn or
grandmaster, or
read
boundary.
something, that's what
Whatever's
become a
going on
part
here,
of
they will assume that
be,
position as you can see
become a
here.
part of what you've developed, or even your vocabulary or anything like
And I
that.
got two
It's
questions
something
for
that
you.
you practice.
If I can get the slide up. There you go. While working as a security analyst, you have been asked to monitor C, security information and event management.
Oh
You
yeah,
observe network traffic going from an
learning is
external IP
learning is really fun.
to
It's
an
just
internal host IP
from time to
within
time,
your organization
not everyone
over
wants to do that,
443.
and it's easier to be distracted.
Which of the following protocols would you expect to be in use?
Even sometimes I find it easy to
So
go watch a
basically, which one of
sitcom
those
or a comedy
protocols,
show, or and
Michael,
and
Martin,
sometimes
you're
it's really
correct. Mr. T,
good,
you're correct. 4.
but I also acknowledge that
Transport layer. We need
it
to make sure those
takes
segments. Remember,
it takes some kind of a
data moving on a bus
determination
on
to
a
wanting to learn
motherboard.
something new.
When data starts moving across the internet and being transmitted, TLS, SSL, same thing. So on a network, they need to use that. In an industrial environment control system, Maintaining extremely precise synchronization between the control systems is very important. Which one would you use to do this?
Yeah, especially if
Stringent
you're,
requirement.
especially if you had a long day, you've been working or you've been doing something, and then
PTP. Yeah,
you get the feeling like you don't
got
want
it
to
right.
sit down
That's
to
the
use
key.
any more brain power.
Missed one.
So
All right, let's
so
move on.
you just turn the TV on, something that doesn't
Let's talk
require
web,
any effort or
file,
brain power, and
print,
that's really
and key-based services.
that's really an automatic mood that
Now, when we're talking
majority of
about
people is
webos,
on. It takes a lot to use your
this one
brain
is the
power
secure
or to
version.
learn something. So
Ms. T
so
said, no with it.
so it's easier to be on
It's gotta have
Instagram
it
or
as it.
just
If
keep
you get
scrolling
tripped
or
up on the
keep
exam,
watching
like what are
something.
reports that are secure? Anything that has an S in it, it's pretty simple to look at that way. So HTTPS, but this one,
Yesterday in one of
hypertext
my other
transfer
video,
protocol fetching
I talked
resources.
about a lot
It's gonna bring it back
of
to you in HTML.
a lot of self-help and self-care,
HTML
and
documents,
what it really
images,
takes
videos from the web.
to evolve,
Foundation is the
especially when
basis
it
of
comes
any
to your
data
thought
exchange
patterns.
on the internet
If you
or
missed
the
out on
web.
that video, you could
And with HTTP,
go through
this
that
is
video
what
as
happens.
well.
You are layer
Or
8.
even in any of my upcoming videos, you
You're
will
sitting
see
down
me
here, and now the user, you
go
want to sit
through
down. You're putting
go through
in
different
information
understanding,
into the
like the
browser,
way we
the
operate
URL
on a
you
daily
enter.
basis,
Translate URL
or how
into
we eventually become better
HTTP
individuals.
request. It's sent off to the server. Web server interprets what you're requesting, retrieves the data, puts it back out on the wire, sends it back to you, renders data into a web page. So which layer of the OSI model is rendering and getting it ready for you to see it on your screen? 6, presentation layer. Correct. So it's getting it ready, and then it displays it at the application layer back to the user.
Yes, you're right. You are exactly right.
We know that HTTP unencrypted is no encryption. Port 80. HTTPS
You are exactly
443.
right.
Good to go. Use that. You'll also have file transfer protocol.
Sometimes
FTP.
you have to practice things in increments, like in small doses, to be able to get good at it.
Like Ludacris
And
says,
that
boom,
also takes effort.
just like that. When I move, you move, just like that. Hey, IT, bring that back. Y'all are crazy. Listen, FTP.
So it's something you notice after you actually start working at it. Then you start to observe things actively,
Just
such
like
as
if I wanted to connect to a computer,
learning
start
for a majority
chatting
of people
on the
is not an easy
computer,
thing to do.
there is a port in a protocol that is plain text.
But it comes
and
with
sees
practice,
everything
especially
that I'm
to be
doing.
able to
Which one is
start
that?
observing the little things that don't really seem like it's a little or even a big thing.
I remote into another computer and I can chat over it. And
So there was a point
put
in time
commands in
when
there.
each time I want to read or learn
It's very
something,
simple to use.
as soon as I
It's
open a
like-
book
it's like
or
the
I
chat we're
start
using now.
to try to learn or read,
We're
I
looking
would get
at- it's
sleepy
outside of your
because
computer
my
and it's
attention
connected to
span
another
was so
computer.
short.
And you're typing commands across the net.
So there was a point in time when I wasn't like that, but then I somehow developed
You're
that by
administering the computer.
just watching
There you
TV or just not wanting to learn as much
23.
as I think I should.
You're almost there.
And so I have to break myself away from that
Now I could take FTP
through small increments
Telnet
of trying to
and
practice.
put these both in a secure protocol to be used. Which one is that one?
I'm sure a lot of people go through the same thing.
I can do both in this one protocol and it's secure.
Sometimes you really want to
right.
learn, but you
When
just
you
don't
came
have the
back,
attention
boom,
span for it.
SSH. Port
So,
22.
so you really
do the
have
job
to
of
practice,
20,
and sometimes it's
23.
excruciating.
All right, so remember that one.
It just takes a little bit more
So
brain
with
power.
file transfer protocol, you can allow
And one of the
some
practices that I
access.
have,
That's the one thing about FTP.
one of the practices that I have
Some languages,
developed
they do
is
not have
writing
to
things
reveal
down
who
now,
they are
so I remind
in order to
myself
connect on
like
that
tasks
port.
and goals or things that I
With
have
these
to do.
channels, you have the command channel for
And I
instruction
practice it
response
in small
and the data channel
increments,
for
and so
transferring
eventually
files.
it
Now, the
becomes
command
consistent,
channel
and then
is
it
20.
grows.
That's the client connected, right? The next channel that the server brings it back to you or verifies is 21. So the client primarily talks on 20, servers talk on 21. If you ever see two ports on a protocol, usually the very first
Oh yes,
port,
I
the client
absolutely
uses it.
agree. I
The
agree
second
with
port,
you
the
on
server
that.
uses it, or whatever the resource is, uses the second port.
I
That's how you
myself
can
from
tell them apart. Okay.
because I take
And
from
if you want to do
myself with
port
that too.
security, you would use those
I can
one or two
compare that
ports
to me at a point in
to lock a
time
network
when
down and
I
make sure
didn't want to
that's
use
the
my
port they're
brain
only
power. I
using.
was being lazy
All right.
because it's easier to just go watch
For
something or
transfer
listen to
mode, you have
something.
two
So
ways. Active, the server connects
yeah,
back to the client to
you're
transfer the
absolutely
data. Or
right.
passive, client initiates command
Yeah,
data
it's
connections
there was a
to
point in time
avoid
I
firewall
become lazy,
issues.
and I say that because I didn't want to use my brain
Okay.
power because it takes effort and brain power to really learn something.
Now you have secure. Here we go. Port 22 can do the job of 20 and 21.
Yeah,
Right?
so
Always use port
so I
22.
tell myself that I'm
Okay.
supposed to be studying for like 2 to 3
We
hours,
talk
and
about port 22 a lot.
as soon as I start, by the time
But let's
15
put
to
it
30
into
minutes
play.
come, I'm trying to find excuse
Okay.
or trying to distract
You ain't got
myself,
bars today.
and so
Let's put it into play
it oftentimes just
today.
take just a little bit more
Okay.
to break to break away from it.
What would I need to securely connect via SSH to
Yeah.
any other client?
Yeah,
Be it a switch, a Cisco switch, another computer, or server to administer it.
yeah, sometimes you
What
just
do
don't
I
want to do it,
need
right? So
in order to help me facilitate
sometimes
that? It's
you
not
really
just
don't want to do
port
it,
22.
and I
No,
think
you have to go through
it's just a
this
normal thing
to translate the
for every
commands.
individual.
I can download
But
it.
then it's something you
Windows
work
has one in
past.
it.
You kind of consistently
An SSH
practice and
client,
develop
yes.
some kind of a
An external client I
consistency
can
until
download
it
is called
becomes
PuTTY.
easier. So
And then y'all mentioned
you're
two
not
other
thinking about it so
SSH
much.
client
It becomes
programs the other
secondhand
day,
to you.
right? So you need some type of SSH client to authorize you to get in. When you get in, then they'll say, do you want to download the SSH encryption file and the keys
There's
to
nothing
the
wrong with that,
terminal
and it's
to
absolutely
make it a
possible.
secure connection?
It is
You can
absolutely
do that too.
possible.
You can download it to a file so you can make sure you save it.
You can be that one person in the class or even throughout the school that really understands because
All right, here's our next
you
protocol.
take the time
And this
to
is so important.
actually
We're going
learn
through all
and
the
practice
protocols that's on your
things.
list, by the way. Yep. So port
And the way you get
445
better at a
server
majority
message
of
block
things is through practice and
allows
repetition.
computers in the same network to share resources.
So through the practice and repetition, it
Windows
becomes
have it in.
second hand.
Now you'll see this in Windows. If you see this on the exam, it's the same one. S&B or what they call CIFS.
So
Computer information file sharing. That's a Windows proprietary, CIFS. That's Windows. So that's when you do that.
Yeah, so
when you walk up to a multifunctional device,
so at first,
to email.
I used to think about IT like that too, and then
scans the document, goes straight to his email or somebody else in the organization.
Because it's almost like a foreign language that you don't know. But I think with most things it's just the same
on a fax line or something like that.
until you
That's what's
actually
going on with
practice and gain an understanding
Okay.
of it.
Or if a file sharing system, share drives and stuff like that, SMP. Just as a reminder, if you see
Especially
Samba,
coding or building
Samba
and
is an application that's installed in
writing
order
codes
to
like
put a
HTML
Linux machine
or any one of
on
these
a
things,
Windows network.
it can seem that way for a lot
it
of
can
people.
share resources. Okay, Samba needs to be installed to put a Linux machine on a Windows network in order to share files and resources.
That is absolutely phenomenal,
Just in
by
case
the
you
way.
see that on the exam. And I believe there's one
You
question that
practicing,
popped up
learning,
about
and taking the
Samba.
time out to be able to do all these things, that is absolutely phenomenal.
What's happening? Client does the request over to the server. to access SMB and a share drive or wherever it
So
needs to, and then it grants permission
so
and
you
or denies,
heard of a lot
and
of
then it
people
automatically allows you to share the
are
resource.
simply one of the individuals that take the time to learn and to do stuff.
You can also have what they call network access storage, NAS, Illmatic.
Not everyone will see it
Yeah,
has
sorry.
become a norm, or they might see it difficult,
No,
but that's
it's
simply because
1999.
they haven't really taken the time
All right.
to practice it. So the more you
So with
practice and do
Illmatic,
things in
NAS
repetition, then you get better and better at it.
provides that remote file
So that
access
is phenomenal.
for current
That I
resources,
can
meaning you have
applaud.
multiple connections at the same time
The-
for multiple devices that can access the file share. And the components you have to have the processor, memory, and hard drives. Those need to be beefed up. Okay.
HTML and CSS, yes.
And that, so you can have a lot of users and devices hooking up to it. And then you have the bespoke OS to share this.
So
it's like a hub and spoke. Everybody coming in.
So all the
Linux
codings, all the
uses
different
Red Hat.
computer language that you have to learn, the
This is
inputs.
Red Hat.
It's
This is
basically
good for
learning
enterprise services.
the IT language.
And you
It's a
drop that on the
language
server,
within
so
itself.
that'll be the OS used, bespoke OS. When you see, well, that's a but. What topology is this? Network topology. Bus, you're correct. Get on the bus.
Yes, of course. I can, and
Next, you have
I can understand that kind of a
RDBMS,
mindset as well.
Relational Database Management System.
When everything seems foreign or difficult,
Structured
and that's
storage
mainly
of
because
tables that store the data. SQL. So basically, anyway, this is a lot of big words on the slide. Let's just break it down. SQL primarily, the first ones that came up with these databases using the SQL language. Structured query, get it? SQL, SQL, structured query language. Databases, query. It's structured because it has tables, and in the tables, they store data in the cells, just like looking at an Excel spreadsheet. So when things are inputted into it, you can run a query based on what you're looking for.
Oh, that is absolutely phenomenal.
And it brings back your results. If we use the term relational database, that means if I'm looking for something,
yeah, that is
my database is going
that
to be
is absolutely
to
phenomenal.
Mr. T's,
And
Aaliyah's,
one of the
Kevin's,
fun
Brian's,
things
and
about
Michael's.
it, you
All
actually
y'all
enjoy
know
doing it.
different aspects of what I need to run a report. But my computer has been hooked up to y'all databases in order to help me pull data from different cells from all of your databases to create a report to present to the CEO tomorrow morning.
A lot of this
Right.
IT stuff,
So all of y'all make sure that
no,
that part of the
that
database is always updated and good to go.
with
Your database
the
management
information,
I run a query,
and
I get what I
technological
need,
world
run a
that we
server
are
with
now
REST, I
in,
present
and
it, smash it, we all did our
advancing
job.
even more into it,
Okay?
it'll
That
never
is a
go away.
relational database.
So there's gonna
query.
always be, whether it's a job or a
The cell
position
that Michael
for you,
has
if
is
that's
talking
what you
about
want to advance
forecasting
into.
sales figures for 2027. Brian's is saying this is the sales figures from this year.
So even though it
Kevin
takes a
is
lot of
just like,
practice now,
this is where we were
and
at
it's even
3
better
years
if
ago.
it
And Aaliyah's
becomes an
like, this is where we're
enjoyment
at
for
now.
you.
And Mr. T is like, this is where our
So
sales
even
were at
making
last
simple
year.
projects,
You get what I'm saying? So all of y'all,
most students don't really
data
want to do it
I'm
because it
going
takes
to pull
work.
to put into my
But once
report
you get
to let the CEO
once you get
know
past
where
the
we're
part
standing
that
at financially.
you stop seeing it as difficult, and it becomes just a
Or
little bit easier, like a
I
second
can
hand
have
to
a
you. It's
non-relational
it's
database
very beneficial
where the one I have
and
does
better when you stop
everything
seeing it
for
has
me.
work and something
I
to
don't
learn or
have to
practice every
relate to
day.
you. I don't have to relate and have a conversation with your database to pull stuff. You know what I mean? I can do it on my own. I'm independent. Yeah, that's what I'm talking about. And then that's when you get the non-SQL or NoSQL database service. When you're looking at this, stores data in different formats. They call it a key value pair or Y columns, meaning when it's in that cell or sitting in
That's fine if
place,
it's
got metadata.
if it appears that it's mainly
in
just
this
you.
cell,
There's
this is
nothing
what's
wrong with
sitting in
that.
here. And here's the
you
value.
will
The value
eventually
can be anything. Okay.
see and
So it's just
understand
saying,
that
like,
other
this is
people
where you
are
can find it.
interested in the same thing
And this is what we're going to
that you're
produce when
interested
you
in.
look in that cell. This is what this cell is
It's
holding.
always
This is
just
the
a few
value of
people
what you're
that
looking at.
becomes the
You can access
that
through
becomes the good
application
thinkers or the
interfaces.
good
You
doers,
can access
and
these databases
sometimes
through
that just comes through
HTTPS.
practice.
They're scalable,
And
horizontal and vertical, and supports a
other people
wide range
have
of database
take the
models.
time to do the same thing that
Okay,
you're doing.
that's a non-SQL database. So basically,
And so there's a point in
a
time
SQL
when you
database
start to
uses
come
structured query language. A non-SQL
start to
database
interact
uses
and come
various
together with those
other
people, and you start to
APIs
find the fun in
to
it.
get you what you need. It's still a database,
So
but with
for
this, you can scale
yeah, it's fine.
up or wide.
It's absolutely fine.
With RDBMS, requires predefined schema
it's
because
absolutely
it's a
fine.
structured language. Over here, it's not a structured language. It's dynamic. It could change.
Yep, you are absolutely
Over
right
here,
about
I
it.
might have
You are
predefined
absolutely
cells
right.
to put information in. You stick to this, we're good. Over
Sometimes
here,
you might be the only one
it's
in
kind
that
of like
class,
cider. You can break the rules a little
but
bit.
then there's
Break
also
the way you
another
want to.
person
Go outside the box.
who has the same thought patterns,
Over here,
and
we can
they
scale
are in
vertically
another class or another place.
with non-SQL horizontally.
And what tends to happen is that
SQL
once
databases can
each
handle a lot
individual
of queries,
person
relational databases.
that
Over
carries the
here,
same
it's
thought
simple.
pattern as you
We do everything
starting
on
to
our
come
own
together,
here, buddy.
you start to
Don't need
see the
anybody.
purpose on the
Simple
enjoyment of
schemes,
it.
specific types and queries.
So there's not so much
Now, to set
confusion
the
anymore.
expectation for this,
So for now, it's
you might
fine
have one
because
question on the exam talking about
there
relational and non-relational databases.
there is so much benefits to it.
That's the one question that I had.
So you are doing
All
phenomenal.
right, or if it said, did you need to run a structured query? Oh, that's SQL. That's a SQL database.
Especially
Two quick
learning and
questions for
gaining
you.
some kind of a knowledge from now. When you do it from now,
During a business trip, Peter connects to the
you
hotel's
don't
wireless network.
you don't have to
send
do it again
emails
later.
to some of his clients.
At a later point
The
in
next
time,
day,
you can learn something else or
Peter
something new.
notices that additional emails have been sent out from his account without his consent. Which of the following protocols most likely was used to compromise the vulnerability? They used a network sniffer, but what was compromised? So now you got to know your protocols. HTTP, that's what I'm thinking too. What's the problem with HTTP? Security is not secure, you're correct. Heck yeah, let's compromise that all day.
So
Now you could grab SSL
so
and TLS
oftentimes,
certificates, put them there encrypted.
like a lot of the things that I spend time to learn
You know,
and
they said
eventually
that if you
get good
try to
at,
crack an AES encryption,
you
somebody
won't
look that up for me,
find
'cause
much other
there's so
people,
many days.
especially in your
How long does
vicinity,
it
like
take to crack
your close
WPA
proximity.
AES?
You won't often find other people that
You'd
are
be
into the
surprised.
same thing or at the same level. But
Question number 2: which file storage
once you
network
acknowledge
technology
that there are
utilizes
other
file
people,
level storage to
you can be fine with that, at least at the
function
current
properly?
time. So you don't
File level
overly think
storage.
about it
File level.
that there's no one else that's really into the same thing.
File level. We just had a class about it. We're in the class. 2.5 days, is that 2,000.5 days or 2.2 days?
Oh yeah, see, that's a good thing.
Okay, 2.5 days.
you
Okay,
become
gotcha.
the individual that's
So
now
it takes
helping
two and a half days to
others,
crack AES.
and that's through the hard work
So
and
this
time
one
that
you
you
want to have
put
the
in.
storage area network, because the storage area network does file level storage. It needs this. It needs to
And at some point in
storage
time, you'll
network
come to understand that there's other people that
utilizes
have put the time and work
file
too, and
That'll
they are
be a
just on the same
storage
level as
area
you.
network.
They might not be in the same proximity or the
Okay.
vicinity
Let
as
me tell you
you,
the difference of a
but there are other
storage area
people
network.
too.
If it sits on your land, like most of y'all, if you look in the back of your routers right now, you can stick a thumb drive in there.
Yeah, that happens a
You
lot.
can set up network area storage.
Sometimes
for
you
your
put the
house
work in to get to a better
on the
place
Soho
mentally
router,
or physically,
and
but
everybody
then
can store to that thumb drive.
sometimes you may extend a helping
Okay,
hand, and
or you
others
can
don't
set up a hard
reciprocate
drive
that. That happens a
directly
lot.
connected to your
But
computer. Right click on the hard drive,
one good thing is
share
that when
it,
you're doing or
and
you're
drop
helping
everybody in
others,
there
uh,
who is able to
you just have to do
share
it
that
from a
hard
good
drive.
place, not trying to look back for something.
Network area storage,
Or even though it
which
would be
is
good for others to
NAS
help you,
equipment.
most of the time you have to
It is
rely
NAS.
on
I
yourself,
apologize.
which is one of the
It's backwards. I got it
which is
backwards.
one of the
Still
foundation
waking up.
you always want to have. You want to be
Your
able
first answer
to
was correct.
teach or
So it
learn
was like, wait, Nas,
anything
it
with
went.
the
Nas
ability to
is it.
rely on
So
yourself.
it's backwards. So
And
Nas
so
uses
whenever
file
you do
level storage
anything,
in
do it from a
SAN.
good
So a
place, so
storage
you're not
area
disappointed
network area storage
in
is
not
on
getting
your
that in
network at home, like
return.
a Soho. A storage area network is when you have to actually
Yeah, you want to do it
segment
from a
a
good place,
LAN
so
and
you're
put
not
servers in
disappointed
it.
or you're not hurt in getting it in
Okay?
return.
Meaning
That will
you have
co-
to get your
that will
servers, you have
come
to get your
from those
IP
that
addresses, you
from
have to
those that
drop it
have
on the
done the same
subnet,
work as you.
segment it
So
out,
those who
and
are on the
then you
same
only
thought
give permissions
pattern
for
that
people that access
understand, and they
that
will be able to
LAN, that
reciprocate that
network
same thing
specifically.
as that you're given
With
as
the
well.
NAS, you can drop it with the thumb drive, like in the back
And
of the
so
router, like I was explaining before,
it becomes
and then you would go to files and
a place
permissions and
of
drop
pure
those folks in
authenticity,
there
and then you can
that
just
are able to
enjoy the
get that.
entire
Now, can you do the same thing with any
the entirety
file
of
on
it.
your network or folder?
But so when you
If I
learn
have a
something and
folder
you're
right
helping,
now that I
you
wanted to share
help with what
with
you can
Michael,
help with, but you don't have to
can
overly
I
extend
right click
yourself
on that file or
to the point
folder
where
and allow you
you
to
can do
access
too
it?
much.
Yes, Michael's right. He's right. So he's on my network. I'm allowing file share. So that corresponds to NAS, network access storage, because now he's trying to just access the file system on the network. Okay?
So I'll compare it
SAN,
to
consider
if you
that
grew up
storage
in like one
area
place or
network.
one town or one country,
Isolated
you
LAN,
won't really see that there
nobody's
are
on
other
it
people or the
but
places
those
like what
servers
you've
that you're
known
storing
until
directly
you've
to for security.
travel to other places or you're starting to
And only
think
certain
differently.
people should be able to
So
access
you
the
always got to be
SAN
open-minded, and when you do
storage
things, you have
area
to do it
network.
from a good place.
And they have the only
When you're
right using,
learning, you
that's the
actually
network
have to
administrator. Somebody
put
who's
the effort
administering
in
those
to be able to
servers
pull from
that to do that.
to pull
So sorry for the confusion in the
rely
front.
on yourself.
I need a sip of coffee this morning. All right.
For the most part, you can always be able to depend and have faith within yourself
Any questions so far?
and in your abilities.
All right. So, which one, just to recap for the two storage, because I kind of messed you up. Which one, if I put a thumb drive in the back of my router and I wanted everybody in my house to store that, is that a SAN or a NAS? Correct. Which one is the isolated network? There you go. Y'all got it. I fixed it. I'm sitting up there telling Mr. T, no, that ain't the right answer. And I'm like, wait a minute. It is the right answer. I got
So,
that.
so I think if you can do and understand IT,
Okay. We're at 9:48 this morning. Woo-hoo. How y'all
I
feeling?
appreciate you. Thank you for subscribing and liking my video. You can comment and
Have
come
y'all
join
noticed
me
that
at
the
any
curriculum
time.
is starting to...
But you're
I'm
also
mad, y'all,
amazing
because
too.
y'all do that. It feels fast to me.
If you can learn and do
Like, you see
IT,
it going like this?
you can
Because
learn
we're
and do
building
just
off
about anything
topologies
else.
we've had
It
before.
may take some time, but I
It's
think
kind
you
of
can
letting
do
up
it.
just a little bit. Because in 12:01 and 12:02, we'd be talking for what, 6 hours out of the day? Now it's kind of down to 3.5 to 4, right? So you're getting it. We're getting it. All right. Let's do this. Let's do a break and be back at the top of the hour. Word up. Hey. See you then.
Yeah, if you can So IT takes effort. It takes a lot of brain power. So especially to learn something new. So I think if you can do that as an individual, you can apply the same principles to anything and learn that as well. So, like for me, when it comes to learning something new or class, um, uh, I I take the time to really try to acknowledge what is it that's preventing me from either paying attention or try to find some kind of solution. If I need to do it in smaller increments to see where I can pick up from there, or what really excites or interests me to be able to gain some sort of a foundation with what I'm trying to learn. So the same thing doesn't apply to everyone, but if you can acknowledge or observe where you can find some foundation or some learning foundation, you may be able to really apply a learning strategy, especially when it comes to class or learning a subject or paying attention. If it seems boring, the way you think just might be operating at a faster speed or a different thought pattern, and that's you really just kind of take the time to acknowledge and observe where you can apply. Well, absolutely, my pleasure. I think if yeah, whenever it seems like there is some kind of a difficult situation or confusion that comes up, sometimes it might be the simplest thing. Math. So at a point in time, math it was hard for me because I I never take the time to really try to compute or try to solve or deduct things. But when I stop thinking that it's hard and actually start from the basics of computing or putting the effort in, once I get the basics, it becomes a little bit easier. I always go back to the basics. If you can start at the basics of what makes things difficult or what makes it not difficult, it also it always helps. I think of coding like that when I just started to look at it, to get into it. So coding is a little bit like stocks and crypto. When you look at the graph and the charts, it looks like so much confusion because you don't know what to do, you don't know what to read, you don't know what's going on. You're seeing numbers, or you're just seeing different things that you're not used to. But the only way you get used to it is by learning the fundamentals. So you have to learn what the numbers mean, what the charts mean. So the same way that I used to look at like crypto or stocks, and I used to look at the charts, it seems like gibberish or some kind of a confusion. And I look at it, I'm like, this stuff is really important, but I don't know what the heck is going on. So the only way to understand it is to learn the basic. Like, what does this mean, and why is it important? So it was the same thing in math for me. I used to look at algebra and all of difficult things in the same way until I go back to the basics and eventually build a foundation from there and build up. So now learning for me in anything becomes an excitement. But yeah, you can't you, you can see, even if you you dive into anything from the middle, you might get an understanding, but the basics and the foundation you'll still be lacking that as well. So in actually getting things from the ground up, like learning the basics, creating a foundation, and then you can build on that, that is always the best way. And sometimes it's really lack of patience, and that's something that I had to work on in myself too. Sometimes you just don't have the patience. You just you don't want to give yourself the time or take the time to do or to learn things, and then that's where a lot of the difficulties and the confusion come from. You know, some things you're more yeah, some things you're more excited about it, so then you give it more attention, you give it more time, and so it becomes easier. But then it's the same principle that applies to just about everything. The more everything becomes easier because you give more of your time and attention to it. And the things that you're not so much interested in, it just seems just a little bit difficult. But it's the same principle that applies. Man, I remember learning math. It was was just the same. Oh, and see, coding now for you is like the easiest thing, but for most people, coding is like a language that yeah, absolutely. A coding language that you never knew seems foreign or weird because you don't know it and you don't understand it. But once you learn and you are now able to actively do it, it's no longer unfamiliar to you and it becomes easier. And so when you're trying to learn something else that is new, it's going to always seem the same until you actually get an understanding of it. Then it won't seem that way anymore. If you apply the same thing to learning a new language, it's just going to seem the same way. But if you spend just a little bit of time, it's something that you can learn. Oh no, learning is like learning is forever. It's unending. So so when it comes to learning, you kind of have to prioritize on what is important to you and what is not important, because you can't randomly just keep learning. It's gonna be too much or too confusing after a while, and a lot of information you don't really need to learn it. It's just gonna take up space and brain power. So you have to be selective about the things that you learn as well, and what is it that you were finding interested in to learn. Oh, that's absolutely phenomenal. If you're already doing coding in gaming or apps, that is a really good thing. AI now makes it a lot easier, but if you can do it without the aid of AI initially, that's a really good thing. You can create a lot of good things from that. So now that you've mentioned AI as well, even with the help and AI being integrated into a lot of the things that we're doing, now it makes it a lot easier for you to understand as well. Because AI is not necessarily really a competition to us learning or wanting to learn and do things. It's more of a aid. So it helps you into learning and do things. So even in coding or even learning math, I'm glad that you bring up AI because AI is so much of a help right now. Because if at a point in time I have the access to AI that we have now, I would have learned math and all the subjects that seem difficult. I would have learned it. I would have learned it already. So now, especially with coding or anything in IT, if I'm having some kind of a difficulty in learning something, then I have the assistance or the aid of AI, which is which is which is really exciting to think about it. So, what one of the things that I'm now seeing you can do with AI is having deductive interaction and communication with. If you go inside of ChatGPT, you can now put on the voice command and get responses from AI. So if you're doing math and you want to have some kind of a feedback, you can now do that, which is amazing. Yeah, AI now it's a great learning tool. So learning it's so on one side, if you're using AI as a learning tool or as help or as a aid, while it helps you, you still really have to use your deductive or brain power to understand what it is helping you with. Because in a lot of ways, it will do the work for you, but then you won't learn as much as you should. So while it's there to help you, you still have to use a little bit of brain power, and you still have to put some effort in there. It will give you the answers to a lot of things that is difficult. Yeah, you are absolutely right. If if you pass everything off onto AI, you then become lazy once again. so, so when it helps you and it solves a lot of like math or science or IT or anything, uh, you can know hacks it to give you if it gives you a particular answer to a question, you can also hacks it to gives you all the detail as to why it arrived there, so you can learn from it that way as well, because it can gather information in seconds from millions and billions of research. So in that way, it's absolutely phenomenal. But then when it does that, you can all the information that it gathers, it brings it it brings it right to you, so you can easily use that. You still just study from it that way, and it makes it just way easier. So it's really up to us not to just leave everything up to the AI, but to use it as a head, like as a second hand, like a side to side buddy.
Okay, we are back. Had to peek in on the other classroom real quick. I'm on campus.
Yeah, yeah. AI can be your side buddy, right? If you're studying on your computer, just turn on the voice command. While you're studying or doing anything, you're having conversation with it, and it's responding intelligently.
So we'll do some self-studying now, so we can switch it up a little bit. We'll go from here to noon, and then at noon, we'll get in let's say another hour right before lunch. Yeah, switch it up a little bit.
Yeah, so not everyone knows how to use knows how to use AI, but it it takes some practice. You can't just hand off everything to AI. So I know you guys probably have seen you've seen the I know you've seen the comics, you've seen the movies, you've seen the cartoon with the integration and the incorporation of AI into your human existence, how it's able to help you and how it's able to dominate depending on how you use it. So it's an absolute help. You can think you can think of it as a good, for lack of better words, just think of AI as a side buddy. It has all the information that you need. It can gather it simultaneously. Instead of searching through tons of books, hundreds of books, thousands of books, AI will do the research for you and bring back all the information that you need. Oh yes. So AI is not perfect. All the information that it pulls from time to time, from time to time you have to fact check. So it's not always 100%. It saves you the time from having to do the research and all the calculation by yourself. But also, it's not always perfect. So that's the reason why you can't leave everything up to it. You can work side to side with it as a aid, but artificial intelligence, it's not entirely or 100% correct all the time. But for the most part, when it comes to basic binary calculation, it's really good at it. Oh yeah, AI is it calculates things in seconds, ones and zeros. It works in binary. So the reason why we don't work that fast is because we have so much thoughts. We have so much thoughts going on, and so we get distracted. So it's like when you're trying to focus on one thing, there's 100 more thoughts coming, and And so it really takes some brain power to focus on one thing. But your computer, it works in binary, so it really don't get distracted. If you type something in and ask it to search it, that's particularly what it's searching for. Now, for us, if we're thinking about something, even when we're really trying to focus on it, there is some other thought flowing around, and that becomes a distraction. So it takes a lot more time for you to research and find something because your thoughts are being bombarded by other things that you don't really want to think about, but it's there because it's in the atmosphere. So in that terms, it's going to be a lot more efficient than you, and so you have to use it in that regard, and it becomes an absolute help. Oh, yes, you're right. So at the current point in time where AI is, it's really dependent upon human interaction. In a lot of ways, you can input programming and coding for it to work automatically based on what you input in there. But for the most part, you have to work hand in hand with it. But you can also automate a lot of features that keeps it going. And in that regard, it is really good as well. For things that you need to be automated, you can automate that as long as the programs are the input that you put in there. These are the things that you want it to do. And so it's working according to how you want it to work. And that is a really good thing. So, one of the things that like IT professionals and experts are doing now, because uh, because they're always trying to improve things. Machine learning, the computer, based on the coding that you input in there, IT, like, like IT expert, after a while, it started to do a lot of this. It started to do a lot of the computing and the calculating by itself. But that really starts from what was input into the computer, that it started to do that all that calculation by itself. So so if AI was AI was talking to itself, the some and this is just pure imagination, right? If AI was like if two AI was talking to itself, I think it would I think it would be like, so what do you think about that Google search today? That human, they input, search to find what is an apple, and it would be it would be some generic conversation like that. It could be just about anything, and I think it would be most that So, what do you think about the way that human type within this keyboard today? some 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 comical thing. you know, if you think about it, it would have to be something like that. Or it can be just about anything. As a matter of fact, a lot of a lot of comical things and expression like that. I've seen it on cartoons too. Oh, I think I'll type that question Chat GPT and I think I'll type that question into Chat GPT and just to see the response of the computer having a conversation with another computer. That really is that's interesting. That's an interesting computer. So can the computer be aware of itself? Because that's what the question is. Are these two computing software aware that it's a computer, or what it's actively doing? I think if you ask it those questions, it'll respond probably yes, but then it'll give you so much information and then a limited amount of as well. So now when I ask like ChatGPT to find the answers to a question, it'll give you the answer along with detailed expression or information as to why. But then you can also ask it just to give you just the answers without any detailed explanation. Now, if I ask it to count to a certain amount, if it's gonna take a lot of time or a lot of computing power, it'll tell you that while it is possible for me to count to like 10 million or a billion, it would, however, takes a lot of time for me to do that, so then it won't go ahead and do it. But if you ask it for steps or a way to go about it, it'll give it to you. Or then it'll probably tell you that it'll take this amount of data or this amount of time for it to do that. Or if you have the like the unlimited version of like ChatGPT, where it's not limited by the data or what you can do on it, because most of the plus version that you have are the basic version. There's a limited amount of thing that you can do on it, but there's also the enterprise version that you can do so much more with. It gives you a lot more the ability to interact a lot longer. So if you write a code in AI, it's that's basically the language that it knows. So if you're typing in AI and you're typing in coding, it'll most likely understand that more than you giving it a random input, because it translate binary inputs, ones and zeros, into the actual language that you can communicate in. So if you're typing in the AI basic language, it'll understand it more quickly. Autocomplete. I use autocomplete on a just on a daily basis. It's it saves you time from having to type everything out. So the autocomplete is based on the predictive programming. So if you're typing in a word that it it already knows, it's gonna give you suggestions. So its suggestion is that it it may be guesses, but it's a way of saving you time. It's predictive programming based on efficiency. So once you start typing in a letter or a word, it's one of the coolest thing. It's one of the coolest feature. Once you start typing something in, it's programmed to make your life more easier and more efficient. So it's gonna give you suggestions, and then you can choose from there. If what it's suggesting is not what you're trying to type in, like a new word that hasn't been input or programmed into the system, then it'll stop suggesting after you've typed in a certain amount of wording or characters. Yeah, it's very good. So yeah, so that's one of the thing. When you become used to the AI assisting you and helping you so much, you become reliant on it. So in a way, you really have to be able to balance that, because it's an acknowledgement that it takes off so much work from. It saves you a lot of time from you having to do so much. So you have to create a balance where you're not relying so much. You need to be able to rely on your own deductive abilities and the ability to calculate for yourself. Because if there's no internet or something, you want to still be able to do all these things for yourself, to be able to think properly, to be able to focus if you need to. Yeah, the autocomplete is there to effectively make your life easier, but the main responsibility is on the individual that is using it. So you have to create the balance where you still can spell or read if that is something that you need to do. Yeah, AI makes a lot of things way more easier now. Yeah, you have to create a balance so it becomes more beneficial than not that beneficial to you, because it's there to assist and help you. That's pretty much what it's there for. Hey, internet. You can also use the internet that's on your phone to like using the cellular network to get the internet from that. Not that you should having regular internet is one of the best things. It's much faster having Wi-Fi, but if at any point you need to use some internet that you probably don't have the Wi-Fi at the moment or something, you can also use your cell phone, like the hotspot on there, to get the Wi-Fi. Oh yeah, Wi-Fi is way faster in a lot of ways. But if you're like not not at home or something, and you still need to use your computer or your laptop, if you're working from a laptop, you can use your cell phone to get internet temporarily to use it. But Wi-Fi for sure, absolutely. No, no, yeah, the internet, the water. In some places around the world, you can go places, and most of the things that you pay for on a daily basis are a lot cheaper. It's not so expensive. So you can still get Wi-Fi or internet free, but it probably won't be as efficient as what the companies are producing. Like when you go to some public stores or to some public places, there's like free Wi-Fi, but it's just not the same as you getting like a home Wi-Fi. But you can use free Wi-Fi, especially if you go to like libraries or places like that. They have free Wi-Fi. Hi, how are you doing? Yeah, so public Wi-Fi's are like Wi-Fi's like that. It is free, but at the same time, just about any and everyone can get on the Wi-Fi. So it's not as secure as like personalized Wi-Fi that you get from the company. Yeah, so that's yeah, that's just one of the things. You can still get Wi-Fi like libraries or hotels or public places, but it's not gonna be the same. Yeah, it's not gonna be the same. Football, I'm not into. So I'm not particularly invested interest into football. If what you're asking if who I like particularly in football, I don't have a particular or a specific individual that I like in football. I'll watch the game and I'll enjoy it, but I'm not that invested in it. So, and it's not just football, it's just about any sport. I don't really have that much invested time or interest to be able to to do that. For this channel, I don't have this I d- I don't have a Discord for this channel as yet, but uh but my other channel, my gaming channel, there is a Discord for that. Go on my gaming channel and you'll see the information in the description of any one of my videos. Yeah, so I don't have a Discord for this channel, but I have one for my gaming channel. Go on my homepage on this. So just click on the homepage for this channel. Scroll down and you'll see the gaming channel linked in there. Click on the gaming channel. Go to any one of the videos and go in the description, and you'll see the Discord in there. Yeah, but if you have homework, you want me to type the name of the channel in the chat? So so on this card it'll be the same name as the channel. So the Discord will be the same name as the gaming channel. Okay. Yeah, I'll type the name in the chat. All the Discord and everything that relates, you can be able to get it from the same name. Yeah, that's the name. If you type that name in Google, it'll come up. It'll bring up the gaming channel. Or just type it in YouTube. The gaming channel will come up. Once you go on that channel, you'll see all the links to it.
be an alert or an alarm if anyone makes any change to that configuration without prior approval. This is usually part of an overall management system that is integrated with the change control within your organization. So you may have software that's monitoring the configuration files and a larger process that is involved with changing and modifying those configurations.
Oh, it says the Discord link is expired.
The Xfinity 5-year price guarantee. You get 5 years of the most reliable Wi-Fi with our best equipment included for a price that stays exactly the same.
I'll take a look at it. I'll take a look at it to see if it's
Getting everyone in your home on the same page about energy use is hard, so we're making it easier. Excel Energy offers programs and services like a home energy assessment and smart thermostat rewards. Plus,
Most organizations will create a plan that they will follow if they happen to have an outage or a significant problem that could affect the overall goals of the organization. This is often referred to as the Disaster Recovery Plan, or the DRP, and it will cover every aspect and detail of how to handle these situations when they occur. And if you think of all of the different types of technologies involved in recovering from a disaster, it is many and varied. You have backups that you need to consider. There may be off-site data replication that might be involved in this disaster recovery. Perhaps you set up alternatives that are located in the cloud. So instead of having a server on site, we can create that same server in a cloud-based environment. Or maybe you've got a completely separate remote site and you move all of your operations to that fully operating remote location. There are also many third parties that can provide additional services for disaster recovery. For example, you can contract with a third party that will provide you with a location so that you can move your operations to this temporary facility. Or you may want to contract with recovery services that can come into your organization and manage the process of recovering from a disaster. There are many different metrics that can help us understand the scope and the breadth of an outage. One of these metrics is a recovery time objective, or an RTO. This is an amount of time, and we want this RTO to be as close to zero as possible. RTO is a measurement of how quickly we can get back up and running if an outage is to occur. So we need to define what a normal service level would be, and then we can calculate how long it will take to get to that particular service level. We refer to that gap in time as a recovery time objective. For example, we know that if our web server was to fail, that the normal recovery time objective for that web server becoming available again is approximately 1 hour. So 1 hour would be the RTO for that outage. Another useful measurement is an RPO. This is a recovery point objective. This is also measured as an amount of time. And again, we would like that RPO to be as close to zero as possible. RPO represents how much time we lost when that outage occurred. We have a certain amount of data that goes back in time that was not stored, it was not backed up, and when that outage occurs, we would lose all of that data. Generally, this is a value that you've already determined. You would make this determination based on what resources you have to recover this data and the types of backups that you may be doing throughout the day. And this RPO may be different depending on the type of business you're in. For example, if your organization handles banking transactions or you manage patient information, you want to be sure that you don't lose a lot of that data. So you may put methods in place to be sure that you are only losing a small amount of time when an outage occurs. This might be, for example, a very short time frame that would be less than an hour. But maybe your organization works with other types of data that don't require such a short RPO. For example, any updates to your website or updates to internal documents may only be backed up every hour or 2 hours. So there would be a longer RPO associated with that type of data. If we were to look at both of these values on a timeline, you can see that as time is going by, we have a certain data recovery point. Maybe this is where data is backed up, maybe we are replicating data to a different site, but we are making a copy of that data or storing that data in a way that we could recover later. Sometime after that point, we we would have an outage. And the time that we have between that outage and the back in time period to that data recovery point would be the recovery point objective, or the RPO. So now we're focused on resolving this outage. We need to resolve the issue with the servers, deploy new servers in a different location, move the data center to a backup site, or do whatever we need to do to recover from this disaster. And then finally, when our services are back online, we can measure that time frame between the outage and the online time frame as a recovery time objective, or an RTO. When these issues occur, it's useful to know how long it's going to be to resolve this problem. And it might also be good to be able to predict when problems might occur. We can provide estimates for both of those values by using MTTR and MTBF. MTTR is the mean time to repair. That is, on average, how long it will take to resolve the issue associated with that particular problem. Maybe it's a router that's failed, and we need to replace that router to get back up and running. The average time frame for replacing that router would be our mean time to repair. A better plan might be to use systems that are designed to stay up and running as long as possible. So we would need to put in equipment that would have a very long mean time between failures, or MTBF. The MTBF is generally based on a number of criteria, but it's presented as a single time frame. For example, if you purchase a firewall, that firewall's MTBF may be 20 years before you would expect that device to fail. So you can then make disaster recovery plans around that time frame. If you see that your firewall has an MTBF of 20 years, you might only need one additional backup unit instead of purchasing multiples, because you know that device is going to last, on average, a relatively long period of time. If we're dealing with a significant disaster, we may need to move out of our existing data center and into a temporary facility. But making that change is often not a simple process. There are a lot of different moving parts and things that have to happen to move your entire data center from one location to another. And then once you move to that other location, you then have to move everything back once you're up and running again. We refer to this moving of one location to another as site resiliency. One example of this site resiliency may be the process you go through to prepare that disaster recovery site. You need to make sure you have.
All right, everybody, let's hit up a break. 10 minutes. See you back at the top of the hour.
Prior to a disaster, you may want to have data that's transferred over. Once that disaster occurs, you'll have a process where you move from your primary location to this backup facility. You would then work from this backup facility until the problem is resolved at the main location. This might take an hour, it might take a day, or it could take months, depending on the problem that's occurred. Every disaster will be different, and we have to think about that time frame when we're preparing the alternate site. And of course, when we are ready to move back to the original data center, there is another process where we would take all of our assets and our data and move it back to the original location.
Now that I'm a mom, things are different. Verizon's different too. They let everyone in my family choose different plans. We get what we want and we save money. Love that for me.
Your workflow is important to us. Please wait indefinitely.
With Monday.com's intuitive work management platform, you have the power. Not IT, not admins. You're in charge. So you can tailor work exactly how you love to do it. Whether you're managing tickets, marketing, projects, or sales, Monday.com gives you a holistic solution for everything work-related. For example, you can add custom fields. Choose how you like to view your work. And easily add automation without needing help from IT. You're probably busy anyway.
Knock knock. Who's there? Not IT.
Once your workflow is up and running the way you love, stay on top of it. Make sure all your business initiatives are on track with Project Portfolio. And get a centralized, real-time dashboard by simply choosing your favorite boards and picking your preferred layout. Congrats! You now have a broad view of everything that's happening. Reporting to leadership and making informed decisions has never been more effortless. That's why over 225,000 customers love to use Monday.com. The first work platform they'll love to use. Monday.com.
If you're still alive, press 1. If not, press 2.
If you're going to be using a separate disaster recovery site, there are a number of different ways to set up this particular facility. One is with a cold site. This is effectively an empty building. None of our equipment is in this building, and none of our data currently resides at this location. We need to grab backup tapes or equipment that has our data and move it to this location to be able to perform disaster recovery. We also don't have any people at this location, so we may need to transport people from one location to another so that they can work at this physical site. This obviously means we have a lot of work to do if we call it disaster, but it also means that this is a relatively inexpensive place to use as a backup location. If you needed to have a disaster site where you could very easily move in and be up and running, you may want to consider a hot site. A hot site is an exact replica of your data center, or as exact as you can make it for something that's a disaster recovery location. This means it has the same hardware that you are currently using in your existing data center. And it's very common that when you're purchasing new equipment for a data center, that you also purchase additional units for your hot site. And of course, not only do we need equipment at this hot site, we also need our applications and our data. It's very common to have replication systems or ongoing backups so that the data at your hot site is as close to the data that you're running at your primary location. And by putting all of this in place at the hot site, we can then move relatively quickly from our primary data center to this disaster recovery location. And since we don't have to install any hardware, install any applications, or recover data from backups, we can be up and running relatively quickly. A warm site would be somewhere in the middle between a cold site and a hot site. This is a site that might have some level of infrastructure, that might have power and racks, and in some cases might even have additional hardware that you can use. So all you would need to do is show up with your data, recover from your backup tapes, and you would be up and running. There's different levels of service that you can use for a warm site, so you can decide just how much hardware or how much data you would like to have staged at that location. It's always a good idea to practice and run through tests so you know exactly what to do should a disaster occur. But that process of going through a full-blown disaster recovery test can be relatively costly. This will take people out of their normal jobs and perhaps in some cases send them to a separate location to be able to perform the actual disaster recovery test. Instead of going through a full-scale test, it might be useful to have everyone sit around a conference table and go through the process that they would follow if a disaster was called. This would allow all of the different departments in IT and all of the management of the company to step through simulated problems and describe what they would do in those particular situations. This means we don't have to go through the physical process of going to get our backups and taking them to this remote location, but it does require that everyone step through the process and see if all the logistics are in place to get that data from one location to another. Since we're all sitting around a conference room table to be able to describe the process that we would follow, we refer to this as a tabletop exercise. This is a meeting that you can go through in about a day or two, and all the key players will be participating and stepping through the process that they will follow if a disaster is called. There are some organizations, though, that go through a full-blown disaster recovery site either once a year or multiple times a year. So it's always good to go through these validation tests. That way, if a disaster occurs, everyone in the organization will know exactly what to do. When you're running through these validation tests, you're obviously not actually moving from a production environment into your disaster environment, but you are going through exactly the same process. Usually these validation tests will follow a particular scenario. For example, let's say a fire was to destroy the building where your primary data center existed. There would be a series of processes and steps to be able to move everything to the disaster recovery site. Well, what if the scenario was different, where everyone in your geographic area around that data center had to be evacuated? In that situation, there might be a different set of steps to be able to get all of your applications and all of your data from your primary location to that backup site. Once everyone steps through this scenario and goes through the entire disaster recovery test, we can document what works and the things that need to be fixed for later. This allows us to make ongoing improvements so that we know exactly how to be more efficient when moving everyone to a disaster recovery site.
I would describe Underline as fast, affordable, and incredibly fast, very reliable, zero lag.
That's kind of fast.
Consistent, fast, simple. It's a no-brainer.
Contact local agent Tom Calvin for an auto quote today.
Maintaining uptime and availability on the network can be a challenge, and in this video, we'll look at different methods for providing that network redundancy. One of the most common forms of network redundancy is active-passive. This is where you would have two separate pieces of equipment, but only one of them is active or running at any particular time. These two devices are constantly communicating between each other, giving updates on their status. And if the primary device fails, the secondary device takes over as the primary device on the network. This means the configuration between these two devices needs to be identical, and if you make a change to the configuration on the primary device, it needs to copy that configuration to the secondary device. You also need to make sure that any real-time information is updated between both devices. So if there is a session table or a routing table, all of that information also needs to be copied and maintained on the secondary device. That way, if the secondary device does become active, it has exactly the same configuration as the primary device did. Visually, this is how it would look on a network map. You have an internet provider, say our network connection out to the rest of the world. There are two firewalls in this configuration, and behind the firewall is a router, a switch, and a web server. In this case, these two firewalls are running as an active-passive configuration. One of the firewalls is active, and the other firewall is in a standby or passive mode. When traffic is sent through the network, that traffic passes through the active firewall to the web server that's on the other side. But let's say that primary firewall had a problem. Perhaps the power supply failed, maybe the software crashed, but something within that device has caused it to go offline. This means that we now have no available firewalls on our network. But of course, our passive firewall has been in constant communication with that active firewall and recognizes that it's no longer on the network. So the passive firewall now makes itself into an active firewall, and it becomes the primary device on the network. So now any future communication on the network uses this new firewall to be able to complete that communications path. You might be looking at that network design and think, you've purchased two firewalls, both of them are plugged in and they're powered on at the same time. Why don't we use both of those firewalls simultaneously and take advantage of all of that extra computing power? Having both of those devices operating simultaneously is referred to as an active-active configuration. However, simply turning off both devices and running traffic through both of them is not always a simple task. There's usually a bit more engineering required to make sure that you can turn off both of the devices and use both of them simultaneously. For example, you might have data flowing through the network in different directions. Maybe one part of the conversation goes through one device and the return part of the conversation goes through a different device. You need to have some type of mechanism that keeps track of all of these different data flows and what device they're flowing through. This often requires a good bit of design work and understanding of exactly where the traffic flows are in the network, how the routing is configured, where the switches are located, and how you would expect traffic to flow on a normal basis. And as you would expect, with an active-active configuration where both firewalls are operating simultaneously, you can send traffic through the network, and one traffic flow may go through one of the existing active firewalls, and a secondary traffic flow may go through the alternate or secondary active firewall. If one of the firewalls was to fail, you don't have to worry about failing over to a secondary because both firewalls are already active. The other firewall that's remaining will continue to handle the load, and traffic will continue to flow normally through that network.
This is the new Dell AI PC with Intel inside. It helps save you time because it does all your busy work for you, so you can get busy doing what you want to do.
On our modern networks, we've become so accustomed to simply turning on our systems and we're able to communicate with other devices on our local network or browse the internet. But it wasn't always this easy. We used to manually configure all of our IPv4 configuration settings. The IP address, the subnet mask, the DNS settings, and everything else associated with TCP/IP was all configured manually on every device. In order to scale this process, we created a new protocol that would do all of this for us automatically. This was called the Bootstrap Protocol, or BootP. But BootP didn't configure everything automatically, and there were a number of enhancements that we would like to make to the protocol. For example, if someone left the network, it would be nice if this protocol recognized that that IP address was now available. So we created a newer version of BootP called DHCP, or the Dynamic Host Configuration Protocol. DHCP is the protocol we use today to provide these automatic address configurations for all of the devices on our network. The process for defining these IP addresses automatically follows 4 different steps that we're going to call DORA, D-O-R-A. The D stands for Discover, where there is a discovery process where you find the DHCP servers that are on your network. The next step is the offer phase, where we get an offer from a DHCP server. The third step is the request process, where we request one of the offered IP addresses. And then lastly, we have the acknowledgement phase, where we tell the DHCP server that we have received that configuration and are using that particular IP address. Let's step through all 4 of those phases from the perspective of this network diagram. On this diagram, we have Sam that has just connected her laptop to the network, and she needs to receive an IP address. On her local subnet, you can see there is a single DHCP server, and there are other devices on this network that we're simply not showing in this particular diagram. There's also a router, and this router is connected across a wide area network to another router, where there's a separate switch and another workstation that is owned by Jack. Let's focus on the process that Sam is going to use to obtain an IP address. This first step is the Discover step, and in this step, Sam's workstation is going to send a DHCP Discover packet. It's going to be sent from an IP address of 0.0.0.0, because Sam's workstation currently does not have an IP address. And this packet is going to be sent in an IP broadcast, which means it's going to be sent to 255.255.255.255. This is sent as a broadcast so that every device on the subnet will see this DHCP request, and if the device happens to be one or more DHCP servers, those devices will be able to respond back. You'll also notice that this request is sent using UDP port 68 on Sam's workstation, and the broadcast is sent to UDP port 67. This packet is sent from Sam's laptop, and because it's a broadcast, it's sent to all devices on this local subnet. The DHCP server will see that broadcast, and it will send a DHCP offer, which is step 2 of the DHCP process. This DHCP server has an IP address of 10.10.10.99, and it will send this with a source port number of UDP port 67. Notice that the DHCP server is going to send this as a broadcast. Send it to 255.255.255.255, and it's going to send this to a destination port number of UDP 68. This is obviously being sent as a broadcast because Sam's workstation currently does not have an IP address. The only way that Sam's device would see this packet is if it's sent to all devices on the subnet. This DHCP offer will be sent from the DHCP server and broadcast to all devices on the subnet. If there were multiple DHCP
Yeah, I dropped in the chat a link for a couple of PBQs that CompTIA had built for their series to introduce people to walk through PBQs. Some of them you may see on the exam, some you may not. But here's 6 of them where you can walk through the exam.
0.0.0.0, because Sam's workstation still does not have an IP address. It is sourced from
Walk through the PBQs.
and the destination is going to be 255.
And ironically, this one goes through all the troubleshooting steps.
Broadcast, and it's being sent to a destination.
Bookmark this.
Port 67. This traffic flow is very similar to that first Discover traffic flow, where all of the packets are broadcast to all devices on this local subnet. And the last step is step 4, or the acknowledgement. This is sent from the DHCP server back to this device, acknowledging that it has received that request. The acknowledgement is sent from the DHCP server, in this case 10.10.10.99, with a source port number of UDP port 67. And again, it is sent to a broadcast address, 255.255.255.255, with a destination port number of UDP port 68. And again, this will go to all devices on the subnet, but obviously the only person waiting for that acknowledgement would be Sam's device. Now that Sam's laptop has received the acknowledgement from the DHCP server, it can now configure all of the IP settings automatically for Sam's laptop. As you may have noticed from that network map and the different phases that we went through with DHCP, there is a significant limitation associated with the DHCP process, and that is the broadcast that is being sent by the different devices. Broadcasts, of course, are only transmitted to your local subnet, and none of those broadcast frames will traverse a router. This becomes a challenge for an enterprise network where you'd like to have redundant DHCP servers and ideally have those DHCP servers distributed across different parts of the network. Fortunately, there is a way to implement DHCP in this environment by using some additional features of your router. We also might want to centralize these DHCP servers instead of having separate individual DHCP servers that are scattered across every remote site that we might have. Fortunately, many routers support a way to enable DHCP across these different subnets, even though DHCP uses broadcasts to communicate. We refer to this router functionality as a DHCP helper or a DHCP relay. This will allow you
Here's
to
another
send
one for you.
DHCP traffic to another subnet, even though it's being sent originally as a broadcast. We would first configure a router with a DHCP relay configuration. And in that configuration of the router, we would specify that there is a DHCP server located at 10.10.10.99. That is our original DHCP server that we were working with earlier. In this scenario, Jack would like to receive a DHCP address, but as you can see, there is no DHCP server on Jack's local subnet. Jack's laptop doesn't know this, however, and it will simply send the normal DHCP discover message out to everyone on this local subnet. When that broadcast is received by the router configured with DHCP relay, it will look at its configuration and realize there is a DHCP server at 10.10.10.99, and it will relay that information to the DHCP server. It changes the source IP address to the IP address of the router, in this case 10.10.30.1, and it changes the destination address to the IP address of the DHCP server. It effectively takes what was a broadcast and turns it into a unicast communication. This packet can now be sent across the network to a DHCP server that's located on a different subnet. The offer process works exactly the same, but in reverse. The offer leaves the DHCP server and is directed with unicast to the router's IP address at 10.10.30.1. At this point, the relay modifies this back to a broadcast and is sent to the local subnet with an all-once broadcast. This process repeats for the last two phases of the DHCP process, and that allows Jack's workstation to receive an IP address even though the DHCP server may be on a completely different IP subnet.
People can get crazy trying to stop a cyber attack. Acronis take the headache out of IT security.
Talk about stepping up. What a start. It's time to level up your game. Introducing the all-new ESPN app. All of ESPN, all in one place. Your home for the most live sports and the best championship moments. Get even more than before with no annual contract required. It's the ultimate fan experience. Level up for more on the ESPN app or at stream.espn.com. Upgrade now.
In our previous video, we looked at the process of DHCP from the client's perspective. But obviously, there are a number of configurations that have to be made to the DHCP server itself. So in this video, we'll look at some of those DHCP configuration settings. When a device requests a DHCP address, the DHCP server refers to a list or pool of addresses that are defined within a DHCP scope. This scope commonly includes the IP address range that will be handed out to the different devices on the network, as well as any addresses that should be excluded from the DHCP pool. You also have your subnet mask as part of this scope. There are also lease durations, so you know exactly how long these IP addresses will be available on that device. And there's other options that you might include, such as the DNS servers that need to be configured, default gateways, and other additional optional settings, such as voice over IP server IP addresses. There are usually a pool of IP addresses created on a per subnet basis, and each scope usually is responsible for providing that particular subnet's IP addresses. Usually this is a contiguous pool, so you can tell the DHCP server to assign addresses 1 through 100 on this particular subnet. And then if you want to create exceptions to that, you can add them to the scope as well. Here's what this looks like on the Server Manager on Windows Server. This is part of the DHCP server settings, and this particular DHCP server handles the network sg1.sgc.local. You can see there is a single scope available on this network. Its scope is 165.245.44.0, and within that scope you have a pool of IP addresses that would be handed out, the address leases, any reservations in this IP address range. Reservations are for devices that will always receive the same IP address each time it is requested, and then scope options that you might include along with others on this scope. So if you need to make changes to the IP address pool or modify any of the DNS configurations or anything else associated with DHCP, you would do that all from this DHCP settings inside of this scope on the server. This process happens automatically for the end stations. They make a request to the DHCP server, and the server goes through the pool of addresses, picks one of those addresses, and hands it out to that device on the network. There's a lease period associated with this address, so that device is able to use that IP address for only a limited amount of time. And if that lease is not renewed, that address is then returned to the pool, and someone else visiting that network can potentially be assigned that IP address. An interesting feature of DHCP is that it will keep track of these MAC addresses and IP addresses that it's pairing together. So if you visit this network again, the DHCP server will recognize that you've been here before. And if the IP address you used previously is still available in this pool, you will be assigned the same IP address you had on your original visit. If you wanted to configure an IP address on a printer or a server, and you wanted to confirm that that IP address would never change, you could manually configure those settings on that device. But this does not scale very well, especially in large networks, and if you need to make a change to those settings, you would need to manually visit all of those devices to make that configuration update. Instead, you might want to lock in the IP addresses for those devices in the DHCP server using a feature known as address reservation. Inside the DHCP server, you would create a table that has the MAC addresses of these devices, such as your printers and your servers, and you would manually configure an IP address within the DHCP server that will always be assigned to that particular MAC address. If you look at your DHCP server, you might see this listed as static DHCP assignment, static DHCP, or an IP reservation. Here's the address registration process in one of my DHCP servers. This one has a couple of reservations that I've added. This one is 192.168.1.6. The device name is Prometheus, and you can see the MAC address of that device is listed in the reservation. I also have another IP address, 192.168.1.9. This is the device known as Odyssey, and it has, of course, a different MAC address. By adding these addresses into the DHCP server as a reservation, I can go to one central place to manage all of this information, yet still be assured that those devices will always receive the same IP address every time they're started. As we mentioned earlier, these DHCP addresses are not permanent. They are leased to these devices, and they're only available for a temporary amount of time. This lease time is one that is configured in the DHCP server itself. In some organizations, they might have a very long lease time. In other locations, it might be very short. You as the DHCP administrator get to determine what the lease time will be for your network. If you were to look at the IP address configuration of your device, you would see the lease timer associated with the IP configurations. If you were to restart that device or unplug from the network and plug back in again, you would be reinitializing that DHCP process and potentially restarting that lease. Another nice feature of DHCP is if you are turning off your system, it can release that IP address back into the pool so that other people would be able to use that IP address in the future.
With the Amex Gold Card, every meal is a reward, earning you 4 times membership rewards points at restaurants and U.S. supermarkets. That's an opportunity in every bite, sip, slice, and scoop. Whether you decide to stay in or go all out. Earn rewards on everyday meals with the Amex Gold Card.
Appreciate it.
Nature's Bounty supplements your hair, skin, and nails with 2 times the biotin. It's in your nature to glow.
It's a simple outfit. It's comfortable.
Before trying to renew the lease. Instead, there are different timers that DHCP will use to be able to provide that renewal. The first timer is a T1 timer. This is set by default as 50% of the lease time. So no communication is going to occur between your device and the DHCP server until half of that lease is complete, at which time your device will attempt to communicate to the DHCP server and renew the lease. But it could be that the original DHCP server is no longer operating properly or has been removed from the network. In that case, we go to a T2 timer. By default, the T2 timer is 87.5% of the lease time, or 7/8 of that lease time. With the T2 timer, your device will attempt to renew the lease with any available DHCP server that's on the network. Let's say on your network that your DHCP server is set with a lease time of 8 days. If we do the math, that means
That is true.
Of the lease time would be 4
It's really anything that you're comfortable wearing, something that you don't really have to think too much about. So if it's simple and it's comfortable and it's something that you don't really have to overthink, then it's
the DHCP server. But as soon as we hit that T1 timer, we're going to begin a period where we will begin renewing with the original DHCP server.
I haven't watched it. I haven't watched that. I'm not sure what kind of
4 days where we can continue to operate.
what kind of a series is that? I haven't watched it.
At this point, that DHCP server is taken out of the network and is no longer available. That means we will go all the way through the renewal period without ever renewing the lease. Once we hit the T2 timer, or the rebinding period, your device will reach out to any DHCP server to try to renew that lease. And on your corporate network, there's most certainly another DHCP server, and it will renew that lease, and the entire timing process starts over again. We often think of DHCP as that automated IP address.
I think I can type it in to get a brief understanding of what kind of a TV show is that, but I haven't watched it.
Those literally as DHCP options. This is a separate field in the DHCP process that allows us to configure other settings that are related to TCP/IP. These options are listed in the request for comments, or the RFC associated with DHCP. Back in the BootP days, we referred to these as vendor extensions. These DHCP options are associated with a number, and there are 254 usable options that could potentially be configured using DHCP. The common configurations for DHCP would be the things that we would normally think about: the IP address, the subnet mask, the default gateway, and the DNS servers. And there may be times when you would like to add additional DHCP options to be configured on that device, but you have to make sure that the DHCP server supports that specific option. Not all DHCP servers support the ability to configure DHCP options. So you'll want to check with your DHCP server.
Well, it looks like one of the news show that
supported by that server.
that has been recently added to Netflix.
And you might want to add that as part
Shows that it has been out since 2022, but Must have been recently added. I haven't watched it as yet.
HTTP proxy, you would use option 135. And there are many other DHCP options to choose from. We're looking again at the scope that's configured within Windows Server under the DHCP server options. And there is an option there for server options, and that refers back to those DHCP options. You can see a list of all of the numbered options within those server options. You can select any of those and define them within the DHCP server itself. Then when anybody can
It's in season.
will they receive
It shows that it only has two seasons.
and DNS settings.
So the main character is starred by Jenna Ortega. I think that's the main character.
The tournament is here. The new season of Twisted Metal is streaming now, only on Peacock. I'm hosting a tournament. We have to win. Cowabunga. I've been waiting minutes for this.
Can you please just hear me out? No, all work management platforms are the same. Monday.com is the one you'll actually love to use. Did you see the dashboards? They update in real time from your team's day to day, so you're always in control. No freaking way. I don't have to put the data in myself. Are you for real? Monday.com handles all the boring stuff, so you can focus on what really matters. You know what? I'm ready to fall in love again.
Oh yeah, the internet is really good for things like this.
You'll love to use.
You won't really know or be up to date and everything. So searching through and being able to look at things, it really helps too as well. So I enjoy looking up things.
Of course, there's
I haven't watched this particular show, but
DHCP servers use a very similar process to what we saw with IPv4.
if it's really good, when I have time, I'll look into it.
Redundant DHCP servers, so it's ready for the enterprise.
Most of the time when I go on Netflix or any one of the streaming channel, it's for maybe to watch something that I'm excited about, or something that's
IP address to itself.
that newly just comes out, or maybe randomly. But for the most part,
There's no DHCP server.
it would have to be something that I've seen already. But once I have the time, I'll look into it. If it's a really good show.
And with this stateless addressing, there's no lease time, so you never have to worry about giving up your IP address. An important protocol that's used for IPv6 stateless addressing and other purposes is the NDP protocol. This stands for Neighbor Discovery Protocol. In IP version 4, we use the Address Resolution Protocol, or ARP, to be able to find other devices on the network. But ARP requires broadcast to be able to operate. With NDP, we're using multicast, so the overall communication is much more efficient. The way that an IPv6 device is able to effectively assign itself an IPv6 address is using stateless address auto configuration, or SLAC. You don't need a DHCP server. The device running IPv6 creates its own IP address to use. One of the concerns we obviously have is that if a device is creating its own IP address, it could potentially conflict with an existing IP address on the network. But in IP version 6, we have duplicate address detection, or DAD, and it checks to be sure that there are no duplicate IP addresses on the network. Neighbor Discovery Protocol can do more than simply find other devices on your network, can also identify routers using the router solicitation and router advertisement features. If a device wants to find a router that's on its local subnet, it uses this Neighbor Discovery Protocol and uses the router solicitation feature and sends that to a multicast that says if there's any router out there, please respond back. And if a router sees that multicast, it will send a router advertisement directly back to that workstation. Routers can also send their own advertisements out without being queried. We refer to those as unsolicited RA messages. They're sent to a slightly different multicast location, and they are sent to all of the devices on the network that might be interested in knowing where routers exist. This router advertisement is useful because it can provide information about the local subnet. things such as prefix values, prefix lengths, DNS server configuration, and other IPv6 configuration parameters. So here's how SLAC, or the Stateless Address Auto Configuration, works with IP version 6. The first thing your device does is determine what local subnet am I on, and it does that by using the neighbor discovery protocol and asking a router through the router solicitation feature, what subnet is this? The router will respond back with a router advertisement containing that information. For example, we can query the router using this neighbor discovery protocol, and we'll receive back this 64-bit IPv6 subnet prefix. You can see an example of that is listed here. But of course, that's only half of the IPv6 address. We also need what's known as the last 64 bits, or the interface ID. Many devices will take a modified version of their MAC address, put the letters FFFE in the middle to create 64 bits that it can then use as the last part of the address. Other devices will simply randomize this value to create those last 64 bits. And just to make sure that this random value, or the value associated with the MAC address, doesn't somehow already match an IPv6 address on the network, the neighbor discovery protocol is used again. It uses a feature called duplicate address detection, or DAD, and checks the rest of the network to be sure that no one else is using that specific IPv6 address. Now that the stateless address auto configuration process is complete, your device now has a completely routable IPv6 address that is unique to that particular station.
Thank you for calling Capital One.
My team Gen AI tool helps you answer customer questions faster.
We use RAG with LLM and customize them with our data for better accuracy. That's all we have.
That's technology at Capital One.
If it feels like your phone hasn't changed in years, maybe it's time to change your phone.
One of the most common uses of DNS, or the domain name system, is to translate the names that we put into our browsers into IP addresses that can be used to connect with that particular server. For example, if you put into a browser www.professormesser.com, there's no IP address associated with that name. There needs to be some process to resolve the IP address based on that name, and we rely on DNS to provide us with that name resolution. This database of names is a hierarchy, and in this video we will look at the structure of a DNS database. We often describe this resolution process as one device that is receiving information from one DNS server. But in reality, there are many DNS servers. In fact, the root DNS servers consist of 13 separate server clusters that make up over 1,000 actual DNS servers. These DNS servers manage the top-level domains, or TLDs, of a number of different generic top levels, such as .com, .org, .net, and others. There are also country-level TLDs. Those are country codes such as .us for the United States, .ca for Canada, .uk for the United Kingdom, and so on. Here's an example of a DNS hierarchy. This starts at the very top of the tree, which is a single period or dot. Underneath that is the top-level domains, such as .com, .net, and others. And then you can have other names underneath those, such as Professor Messer. For example, you could have www.professormesser.com, all found by following this hierarchy. We refer to this as a fully qualified domain name, or an FQDN. You can structure the names used in your organization into this FQDN model. For example, you can start with professormesser.com, which incorporates everything within our domain. Underneath that name, you might have www.professormesser.com, which is the fully qualified domain name of our web server. You can continue to add onto this domain name. For example, in our organization, there is an east and a west for the domain names. And within the east, there might be servers and services with names associated with them. And in the west, there might be a separate group of services in that particular area of the domain. We use DNS to resolve the IP address of many different services. For example, a web server would be a very common resolution, but we also use this for things such as Active Directory and for application access. To be able to maintain uptime and availability of such an important service, we will often use redundant DNS servers.
How's everybody doing out there in video land?
DNS servers, and we can configure our
Y'all good?
systems to use those redundant
I see what Mike was doing.
so that if the first server is not available, you still have another server to
Eating
use.
the baby.
You'll notice if you look at the configuration of your computer, there are usually two DNS configurations.
He said his coffee just kicked in. I need more.
Primary DNS server. This is a DNS server that has all of the zone information for your particular DNS domain. Any changes you make to the configuration or updates to the config all happen in this primary DNS server. The
Yes.
secondary DNS server is not used for primary
Yes,
configuration
yes.
changes.
We do a breakout real
Receives
quick.
an update
Yeah, we
from
can do
the
that.
Primary DNS server. All of this zone information is pushed down to the secondary server in a read-only mode. And anything that we get from a secondary DNS server was first configured on the primary DNS server. From the end user's perspective, of course, it doesn't matter which DNS server is referenced, the same information exists in both of those, and regardless of which server was accessed, the end user has no idea if it came from a primary DNS server or a secondary DNS server. In some situations, you might not want to query a name server to provide that name resolution. Instead, you might want all of that resolution to occur on your local machine. We refer to that as a local name resolution. For example, if you have a test server, you might want to configure your system to access this test IP address for that server rather than accessing the production server itself. You might also use local name resolution if you feel that the DNS server has incorrect information and you want to have your own resolution that corrects that information on your local machine. To accomplish this, we need a file with all of this name resolution inside of it, and the file name is commonly called the hosts file because the name of the file itself is called hosts. This is an example of the host database. It's simply a text file that contains information about the IP addresses and the names of the devices that you would like to resolve. For example, I have a test server for www.professormesser.com. Its IP address is 10.1.10.170, and I can configure my host file to access that IP address every time I reference www.professormesser.com. This works for many applications, but there are certain apps that will not reference the host file. Instead, they will rely on the DNS server as the primary source of information. So you'll want to check the documentation for your application or your browser to see how it resolves this information. And that way you'll know whether the host file is something that can be used on your system or whether you'll need to configure all of those settings on the DNS server itself. Here's a bigger view of this host file inside of Windows. This file itself is located at windows/system32/drivers/etc/hosts. This is a file that is often stored as a read-only document. So if you want to make changes to this file, you'll have to first change the file so that you have read-write access. And once you do that, you can modify the text within this file to have the IP addresses and names that you would prefer rather than the ones that are located on a DNS server. One of the most common uses of a DNS server is to provide a forward lookup. This means that we provide the DNS server with a name and it returns with an IP address. For example, we can send the name.
People can go crazy trying to stop a cyber attack. Acronis, take the headache out of IT security.
You know, it's nice having someone I can be totally open with, even if it means we remain perfect strangers. You know our rules. No names, no photos, just cars. Sorry.
Look, I get it. I have no room to judge. The amount of men I've met, I didn't see their faces, I didn't know their names. They might as well have been in the witness protection program.
Is that your cyber boyfriend? So imagine you could see him, wow, with your eyes. Incredible. Reach out and touch him. Stop. What was going on? I know he loves classic cars and he hates his corporate job, but why are you laughing?
Because he sounds like an 80-year-old with a subscription to Popular Mechanics.
Seems our open location is directly across the street from O'Malley.
It's a one-off mom and pop shop. And I'm sure they have uncompetitive pricing. Closer? Little hand-to-hand combat.
You're my boy. I bet you thought you could just waltz in here and take over O'Malley's because a bunch of girls know the first thing about fixing cars. Am I right?
That's not fair.
With your big executive job, your money, in my professional opinion, if you were a car, totaled. He's wrong with men.
We won't be bullied by a heartless corporation.
Now let's bow our head for prayer. Please give this family wisdom so that we may undermine and destroy our competition.
It's not just me versus him. It's his entire corporate army.
I'm sorry you're dealing with all that. Should we break the rules for just one drink?
We are going to meet.
You're going on a date.
It's not a date. No, it's definitely a date. It's a date. Oh my god, it's a date.
Yeah.
I'm like nervous. I don't even know what this girl looks like. What are we looking for? A wrench. A wrench keychain. It should be right there on the table. Do you know what a wrench is? I googled it. I do know now.
www.professormesser.com to the DNS server, and the DNS server will respond back to us with the IP address associated with that fully qualified domain name. But we can also provide this entire process in reverse. We refer to this as a reverse DNS, where we provide the DNS server with an IP address, and the DNS server gives us information on what it believes the name is for that IP. This is something that will need to be configured in the DNS server to provide both a forward lookup and a reverse lookup. And you'll often find the name that you use for the forward lookup might be different than the name you receive for the reverse lookup. Here are the results of a forward lookup. I provided this lookup through a utility named dig. This dig utility allows me to query DNS servers. I use the dig utility with the parameters www.professormesser.com. It tells me that it's going to perform this query against the name server. It shows me information that I have requested here, such as professormesser.com, and you can see that the results in the answer section show me 3 separate IP addresses associated with www.professormesser.com. These 3 IP addresses are listed here in this order. And at the bottom of this output, we can see how long it took to perform the query and the DNS server that was referenced to provide these details. With this particular example, you can see that there are 3 separate IP addresses that could be used to access www.professormesser.com. But let's perform a reverse lookup to one of these IP addresses and see what the name is that we get back. To perform the reverse DNS lookup, I'm going to use the same dig utility, but I'm going to use the option of -x and include the IP address of 104.22.72.108. And if we look down further into the results that we get, we can see that that particular device is cruise.ns.cloudflare.com. This is because the front end to the www.professormesser.com web server is actually a front end located at cloudflare.com, and by performing the reverse DNS, we can see the actual name of that server appear. When you receive the results of a DNS query, those are often provided to you through a server that is caching that information. But occasionally you would like to get information from the primary DNS server for that domain. We refer to that primary device as the authoritative server.
Cybersecurity today is so messy and expensive. And why does it take so long? It really shouldn't be that. Get started with Soul, the studio where you can build any security app. Whether you're the security person or just the person tasked with security, tie together some loose ends or build up your security stack. You fit Sola to your needs. It's simple, quick, and free. Get security done with Sola.
Only Brawny has 3 plies, and it's stronger than Bell.
That means that that DNS server is the one that is the authority for that entire DNS zone. If you're accessing a DNS server or receiving a result from a DNS server that is not the authority, then it would be a non-authoritative server. So it may be a secondary server that's receiving a copy of the zone files from the authoritative server, but in many cases, it's usually a server that is caching this information to make that DNS query much faster. For example, I used the NSLOOKUP utility to perform a DNS query of www.professormesser.com, and you can see that the server that was used for that lookup was 9.9.9.9, which happens to be a DNS server that is hosted by Google. You'll notice that the results that I get back specify that these are non-authoritative answers. That means all of this information showing the IP addresses associated with www.professormesser.com are not coming from the primary or authoritative server, but instead being cached on the Google DNS servers. One of the challenges you have with information that's cached is that information could be outdated. If I make a change to the IP addresses in my authoritative server, there may be cached IP addresses on a non-authoritative server that are still providing incorrect information to end users. Fortunately, we can specify how long a non-authoritative server will keep that information cached. At the end of that time frame, the non-authoritative server will delete those details, and any subsequent queries for that domain name would need to go all the way to the authoritative server so that information could be cached again. We refer to the amount of time that a non-authoritative server will maintain that cache as a time to live, or a TTL. That time to live is added to the configuration file of the authoritative DNS, and it's listed as the number of seconds that that information is allowed to be cached. We can see this time to live when we perform a DNS query. For example, if you use dig to perform a query of www.professormesser.com, you can see that the results are showing 3 different IP addresses. But you'll also see that there are some numbers included on each line of those IP addresses, the number 300. This specifies that this information will only stay in a cache for 300 seconds, so you know that the IP addresses that you're resolving are going to be 5 minutes old or less. DNS commonly uses recursive DNS queries to populate those local DNS servers and cache that information so that we're able to obtain those resolutions as quickly as possible. This is part of the overall efficiencies associated with DNS, and allows us to have many different DNS queries taking place, but minimize the amount of overall network traffic. The DNS server itself is the one doing all of the hard work behind the scenes. The end user never sees any of these recursive queries. And then once the original recursive query is done, we have information that's now cached on our local DNS server, and any subsequent requests for that domain name will come from our local server in the cache. Let's look at how this recursive DNS query occurs. Let's first assume that no previous queries have been made for this domain name, so nothing is hidden or stored within any caches. We start with the device making the request. We refer to this device as the resolver. This resolver is going to make a request to your local DNS server. So in this case, we're looking for the name www.professormesser.com. If your local DNS server is one that is managed by your company, or it's one that may be at a third party such as Google, that name of www.professormesser.com is not going to exist in that particular DNS database because the DNS server used by our domain is located at a different provider. So how does our local name server know where to find that particular information? Fortunately, the local DNS server is with a root server IP address. So the local name server is going to make a request to the root server asking for www.professormesser.com. The root server doesn't contain that information, but it does know where the .com name server is, and it provides that information to your local name server. The local name server is then going to make a request to the .com name server. The .com name server does have a record that shows where the primary DNS is for the domain professormesser.com, and it provides the answer of that IP address back to the local name server. Now the local name server knows exactly where the primary DNS server is, and it makes a direct request to the professormesser.com name server, and of course that server will know exactly the IP address for www.professormesser.com, and it will provide that information back to your local name server. Now that that information is back at the local name server, you can provide the answer back to your workstation, and it will cache that information so that any subsequent request will simply query the local name server, and the local name server will be able to respond back immediately.
Welcome back to the strong section.
With most options, I've been waiting for something special. It's been buffering, but as our connection is strong, it's the back end. It's gonna last.
Local people with internet that loves you back.
DNS is a protocol that has been around for a very long time, and when it was first created, there was not a lot of work put into security of the protocol. Information for DNS is usually sent in the clear, and if someone was monitoring your DNS queries, they could at least have an idea of the services or the names of devices that you're trying to access. Another challenge is that the results that we're getting from DNS are not authentic, so we're never quite sure if we're receiving legitimate responses from a DNS server, or if the responses that we're receiving may be from a third-party or spoofed DNS server. One way to resolve this is to use DNSSEC. This is domain name security extensions, where the responses that we get from these DNS servers are digitally signed. This means that we can verify that the information that we're receiving really did come from a trusted source, and the information contained within that DNS response has not been modified by a third party somewhere along the transmission. DNSSEC does require additional changes and configurations on your DNS server, but it does provide a much more secure method of name resolution. Even though this information has now been digitally signed, we can confirm that we're receiving information from a trusted source. The information that's being sent is still in the clear, which means anybody capturing that traffic can see the host names that you're trying to access. One way to resolve this is to encrypt all of the traffic to and from the DNS server. One method of encrypting this data is through DNS over TLS, or DOT. This allows you to send the DNS traffic over a different TCP port than usual. By default, it's TCP 853, and it encrypts all of that information using very similar protocols to what we use when we are encrypting web server communication. Another form of encrypting this DNS information is to send DNS over HTTPS, or DOH. This is going to send all of that DNS information over a very standard HTTPS packet. This is the same process of communication that we use to send and receive encrypted data to a web server. And if you were to look at a packet capture, you would see traffic that looked exactly like encrypted web server traffic that's being communicated over TCP port 443. Some of the more modern browsers use DOH by default, and you may be already encrypting that DNS traffic whenever you're accessing web servers from your browser.
People can go crazy trying to stop a cyber attack. Acronis take the headache out of IT security.
Getting everyone in your home on the same page about energy use is hard, so we're making it easier. Excel Energy offers programs and services like a home energy assessment and smart thermostat rewards, plus rebates to help reduce the cost of energy upgrades in your home. We make energy decisions easier. Who gets to control the remote? That's up to you.
If you were to look at the configuration file of a DNS server, you would see a number of different lines, and those lines contain one or more different types of DNS records. We refer to these as resource records. And these resource records might provide information that allows us to resolve a name from an IP address. It might contain information about a certificate that we can use to validate DNS information. It may contain aliases of host names that are stored within the DNS database, or one of many other record types. On the screen is a DNS configuration file. You'll notice there are a lot of different types of information contained within the DNS file, and in this video we'll step through a number of these more popular DNS records. At the very top of the DNS configuration file is a start of authority record, or an SOA. This gives us an overview of what we will find inside of this DNS configuration. Information such as the DNS zone details, so we can see what domain this particular DNS configuration is a part of. You can see serial number information, and you can find details about retries, expirations, and how long information should be stored. One of the most common record types you will find in a DNS server is the A record or the quad A. This record defines the IP address of a host. This is the record containing the information we need when we send a query to a DNS server. Records marked with an A are for IP version 4 addresses. So you often see the IPv4 address in the name of the device associated with that IP address. Records marked with 4As or quad A records are for IP version 6. This provides the same functionality with both IP version 4 and IP version 6, but the type of record is different, where IPv4 has 1A and IPv6 has 4As. This is an A record from my DNS server. You can see the name on this record is www.professormesser.com. This is an internet record. It has an A, which is referring to this address record, and then the IP address of this device, 162.159.246.164. That is the information contained within my DNS server, and if somebody queries that server for www.professormesser.com, that DNS server will return the IP address associated with that A record. Sometimes you have a single IP address that is referenced by multiple names, and we can configure this alias of names inside of our DNS server. We refer to this record type as a CNAME record. It stands for a canonical name record. So for example, you might have one server such as mail.example.com, but that same server may be providing other services and may be referenced through other names. We would include those names inside of these CNAME records. For example, you can have a chat alias, and that chat alias is pointing to mail.example.com. You can also have an FTP alias. That FTP alias is also pointing to mail.example.com. And there's a third alias of www, which is also pointing to that same server. It's located at mail.example.com. This actually means that there will be multiple requests made if someone was to query www.example.com. The DNS server recognizes that you're looking for www, and it provides your client with the name mail.example.com. If you already know the IP address of mail.example.com, then the transaction is over. But if that information is not cached on your machine, a separate request will be made to the DNS server to resolve the IP address for mail.example.com. Another important record on our DNS servers is the MX record. This stands for Mail Exchanger Record, and obviously this is an important record for organizations that need to make sure that emails are being able to send and receive from that domain name. In this DNS server, you can see there is an MX record, and it specifies that the name of the mail server is mail.example.com. At this point, if you needed to send mail directly to that mail server, you would have to perform another name resolution to mail.example.com. So as long as there is an A record, you'll be able to resolve the IP address associated with that mail server. On some DNS servers, you don't have access to the text-based configuration file, and all of those configuration settings need to be made in a web-based front end. Here's an example of one of those web-based front ends where we are modifying the mail record. You can see that the name is mail. It specifies the specifics of where that target name is for the mail record, and you can see the time to live, in this case, is 15 minutes on this DNS server. Another useful record type on a DNS server is a text record or TXT record. This provides human-readable text information, and it's used for many different purposes. One of the more common uses of a text record is to configure the SPF information. This stands for Sender Policy Framework, and this is a way that we can tell our DNS server what email servers are authorized to send mail on our behalf. This is to prevent someone else from building their own mail server and sending mail with your name associated with it. The mail servers that receive these email messages will refer back to the SPF record that's contained within your DNS server in a text record, and they will verify if that mail really came from an authorized host. These text records can also be used for DKIM. This is the Domain Keys Identified Mail, where we are digitally signing the emails that we are sending to another location. And when those emails are received, that digital signature can be verified. But to be able to verify that digital signature, we need the public key that is associated with that signature itself. And the text record in our DNS server is where we're going to store that public key. Here is the SPF text record and the DKIM text record from my DNS server. The SPF record shows ProfessorMesser.com, and it shows a specific mail server that is allowed to send mail on my behalf. In this case, it's the mail server at mailgun.org. And of course, to verify the digital signatures, I also need a DKIM text record. You can see that this public key is quite long, but it is all text information, which makes it perfect to put inside a DNS text record.
This is the Dell AI PC, built for AI. It was designed to optimize your battery life, so it works longer without a charge, and in places without a charger.
The Xfinity 5-year price guarantee. You get 5 years of the most reliable Wi-Fi with our best equipment included, for a price that stays exactly the same.
Another important record is a record that specifies where the name servers are for your particular domain. These are obviously extremely important servers, especially if you need to perform name resolution. These are name server records, or NS records. You can find these NS records listed as individual lines that specify where those name servers happen to be located. For example, in this domain, you can see there are 2 name servers listed. One is ns1.example.com and the other is ns2.example.com. And the last record we'll look at is a pointer record, or PTR. Whenever we're performing a query to a domain server, we're usually asking it for the IP address associated with a fully qualified domain name. For example, we'll tell the name server that we'd like the IP address for www.professormesser.com. But you can also perform the reverse lookup, where you're asking the DNS server to provide you with the name by giving it an IP address. To be able to perform that reverse lookup, you need a separate record that provides that reverse information, and that record is the pointer record. For example, on this DNS server, we have a number of pointer records, 3 different ones listed for joe.example.com, www.example.com, and bill.example.com. You'll notice there's a number associated with each of those, and that refers back to the IP address associated with that particular subnet. In the DNS configuration, those IP addresses are shown in reverse. So this is for the IP address 192.168.23.2 is joe.example.com. 192.168.23.15 is www.example.com. And 192.168.23.17 is bill.example.com. If we then perform a reverse DNS query to this server, and we're requesting the IP address of 192.168.23.15, we will receive back the response of www.example.com.
Hi, it's me, your internet connection. We've been through a lot together. Back-to-back video calls, large file uploads, never-ending spreadsheets. But your provider, they've been holding me back with data caps and slowdowns. Like we don't have deadlines. I could be so much more if you gave me Team, reliable fiber internet. Because you and your internet have been through enough.
Hi, Melanie. Hi, Mrs. Winchester. Oh, please call me Nina. Come on in.
So what do you think, this job? I was really enjoying being housemaid.
For their families, of course.
You know this is a live-in position, right?
Ta-da! This is your room.
Big. It's perfect. Good.
So, would you like the grand tour?
See what you're getting yourself
stuff into?
The job is mostly cleaning, organizing, some light cooking.
Hello?
Millie's gonna be living with us.
You're gonna live with us.
Andrew, I told you that. She'd be part of the family. I want you to feel safe here. I do. To your door. You're a lifesaver. I don't know what I'd do without you. Millie. I need this job. I can't lose it. I do not want to go back.
All I'm asking, baby.
I have a really good feeling about this, Millie. Me too. Okay, I'll be in touch.
This video, we're going to talk about NTP, or the Network Time Protocol. This is the protocol that we use across all of the devices on our network to be able to synchronize their clocks. So if you're looking at the clock that's in your laptop or desktop computer, or you're examining log files that have timestamps that are from a
mechanics of an aligned field.
All right, everybody. I'm over here talking to Martin, so I wanted to pop back in and say, take a break. See you in 10 minutes.
All right. Much appreciation. I appreciate it. A lot of work. It's hard work, but it's worth it. You know. How are you doing? Oh, what kind of study? It's IT, information technology, particularly cybersecurity. Going through the certifications of A plus, Net plus, Sec plus, and CYSA. So, are you saying? Okay, so your English is not too good, but you're saying you're currently studying for IT. Okay. Uh, that is particularly what I'm studying too as well. My classes throughout the day are lectures and self study. So I am in the process of learning as well. So I'm going through the specific learning based on e-certification. So A plus, that is particular to cybersecurity. Also Net plus, these are specific certification that are required in cybersecurity. These are subnets that are under information technology IT. A plus, it's a certification. Net plus, Security plus, it's also a certification, and CYSA. These are all certifications of cybersecurity. So I am going through the lecture as well. I'm going through the classes of learning and earning these. So I am in the process as well. Yeah, good websites. Good websites are CompTIA. Oh, how to join the classes? So it's something that you have to sign up for, or you can do it, or you can do it individually. So you can go to the CompTIA website. You can go to the CompTIA website to see all the certifications to do all the practice tests or the practice examination, or also the practice classes. To get into a particular class, you can go through that website CompTIA and find an instructor or find a class from there, or they'll recommend a school. And you can also go on the Cisco website. There's a Cisco Network Academy website that has a lot of free courses and free classes that lets you practice or do a lot of the courses. And in many of the courses, you get free certifications as well. But for these in particular, you can go to CompTIA. I can type the name or the spelling in the chat for you. So if it's something that you'd like to look into. How are you doing?
right, everybody. Looks like y'all are hard at work. Look at y'all. But it's 1 o'clock. Michael says, clock out. You see, he put that? It means go to lunch. He took control of the class while I was gone and made a judgment call. Look at that. Go to lunch, y'all. See y'all when y'all get back.
All right. Now, I'll see you guys in a few minutes. Breaking for a little bit. Leave your comments if you have comments. Once I get back on, I'll respond to all your comments.
to the strongest connection.
With most options, I've been waiting for something special. It's been buffering, but our connection is strong and
In this video, we're going to talk about NTP, or the Network Time Protocol. This is the protocol that we use across all of the devices on our network to be able to synchronize their clocks. So if you're looking at the clock that's in your laptop or desktop computer, or you're examining log files that have timestamps that are from a switch or router or firewall, all of those clocks were probably synchronized using the Network Time Protocol. As you can imagine, having every device using exactly the same timestamp can be critical, especially when you're comparing log files and other information that may have been taken from multiple devices. This is also an automatic process so that every device can automatically get exactly the correct time of day configured. This is also something that we can configure. So we might have some devices that update their clocks every day and other devices that might update every hour. And in many cases, these time updates are very accurate. In most cases, you might find that the devices on your network may only be different by a matter of milliseconds. For NTP to work properly, we need a time server. This NTP server listens on UDP port 123, and it's responsible for responding to any time requests from your NTP clients. The NTP server does not modify its own time, and if it needs to update its own time, then it needs to have a separate NTP client that then queries a different NTP server. The client is the software that's responsible for querying the server and obtaining the latest update of time information. And in some cases, we might have both an NTP client and an NTP server on the same device. The server is handing out timestamps to any of your NTP clients, and then if you need to update the time on that device, a separate NTP client on that device will perform the same query to a different NTP server. Some organizations will query an external NTP server to provide that time information. But if NTP is important for your organization, you may choose to have your own NTP server. You would then configure all of the NTP clients on your network to query your own internal NTP servers. By default, NTP sends information in the clear. After all, the time of day is not something that's generally private, so it's common to send this in a non-encrypted form across the network. But time can be an important security concern. For example, Kerberos is often used to authenticate devices on a Microsoft Windows network, but Kerberos won't work if the client and the server's timestamps are off by more than 5 minutes. So you could potentially cause a denial of service by providing the wrong time to all of the clients on this network. For that reason, we need some way that we can trust the response that we're getting from these NTP servers. One way to do this is by using Network Time Security, or NTS. This adds a level of authentication so that we know the response that we're getting back from these servers is one that can be trusted. To use Network Time Security, we need an additional device on the network known as the Network Time Security Key Exchange Server. This is a server that's responsible for authenticating the clients and making sure that they all have a cookie that can then be used to perform the NTP query. So this now turns into a two-step process where we first obtain the authentication details and then provide that cookie to the NTP server. Here's a better view of this. We first have a TLS handshake that occurs between the client and the NTS key exchange server, and then we can request a cookie from that server and then receive it in that response. From this point, we can perform the NTP request to an NTP server, but we include that cookie information to show that we have authenticated to the key exchange server. We can then receive the NTP response, and we now know that we have a valid timestamp from a trusted server. With a local NTP server, we can get accuracies down to around 10 milliseconds. But in some environments, we need very precise time synchronization, and we can do that by using Precision Time Protocol, or PTP. This is a hardware-based time synchronization that provides granularity down to the nanosecond. This is especially important for industrial uses where you need to make sure that the timestamps across all of these devices are very precise. PTP often requires a separate piece of hardware that is separated from our operating system and any of our applications. That means that it has its own operating system. It can run without any delays from any type of third-party process, and and it can provide the most accurate timestamps for all of your devices.
People can get crazy trying to stop a cyber attack. Acronis take the headache out of IT security.
Duh. Imagine if we could tell everyone here that Liberty Mutual customizes car insurance to save people hundreds. Oh, what's this? A fan has run out onto the field and he's not wearing pants. Burns need pants? I know. And the control room censored it. Oh, only paying for what you need. Liberty, 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 liberty.
A VPN is a virtual private network. That is a way of taking information that would normally be sent across a network clear and encrypting all of that data so that we're then able to send it over a public network such as the internet. If you're using a VPN from your workstation, then you're probably connecting to a VPN concentrator. This is a functionality that's usually built into our modern firewalls that allows us to encrypt and decrypt information on that concentrator. This means we can encrypt information, send it across that public network, and on the concentrator we can decrypt that information and send it on its way. This might be a piece of hardware that is specifically designed for this encryption and decryption process, or all of this may occur within software that we can install on an existing server. VPN clients can be installed on many different operating systems, and some operating systems may include VPN clients built into the operating system itself. If you're using a client-to-site VPN, then you would have software that's installed onto the client workstation, and that client workstation would be communicating back to a central site. For example, you could be using a laptop at a coffee shop, and you may want to enable this VPN functionality so that you can communicate securely to a concentrator that's located on your corporate network. Sometimes this is software that you can manually enable or disable depending on when you might want to use it. But some VPN software can be configured as an always-on connection. So when you turn on your laptop and log in, it has already created the VPN connection back to your corporate network. So you would either start your VPN software and enable it manually, or that software would be automatically loaded. And as soon as you begin sending information across the network, all of that communication will be encrypted. When that encrypted data is received by your VPN concentrator, it decrypts that data and then sends all of that into your internal network. Whenever you're sending information back to the laptop, it reverses this process where it takes the information from the corporate network, encrypts it, sends it across the internet, and it will decrypt down at your laptop. Another type of VPN connectivity is between different sites. This is a site-to-site VPN where all of the communication between one site and another is encrypted over this VPN tunnel. This is something that's commonly used as an always-on connection so that you can be assured that everything between those locations will always be encrypted. This is usually built into an existing firewall. So you would turn on the VPN concentrator function on each firewall at each location, and you would have all of the data sent between these locations traverse this encrypted tunnel. Of course, the concentrators will be decrypting this data on either side of the connection, so the users at the different remote sites have no idea that this data is being encrypted between the two locations. Instead of installing a separate piece of software just for this VPN connectivity, your organization may choose to use clientless VPNs that don't require any specific VPN client. This is something that usually runs inside of a browser using HTML5. This is the Hypertext Markup Language version 5. HTML5 allows us to use an application programming interface to be able to interact with the browser. And one of those APIs is a web cryptography API, which allows us to run a VPN client inside of our browser without using a separate client. This means we don't have to install any additional software. We just visit the appropriate web page, and the VPN software within that API takes over and provides that encrypted tunnel. All you have to do is make sure you're using an HTML5 compliant browser, and you'll be able to use this clientless functionality within the browser on your system. The administrator of your VPN system may configure the connectivity in a number of different ways. One of these methods may be through the use of a full tunnel. A full VPN tunnel means that all traffic that's being sent out of your machine is traversing that VPN tunnel and is encrypted on the other side where the concentrator is located. Your local machine doesn't make any special forwarding decisions where some traffic is sent through the tunnel and other traffic is not. Instead, everything is being sent over that VPN connection. In some cases, though, the administrator of your VPN may configure a split tunnel. A split tunnel means that some traffic will be sent over the encrypted VPN, but other types of traffic, perhaps something that is not related to your corporate environment, is sent outside of the VPN connection. So let's take this scenario where we're using a VPN. We are connected over this VPN connection to a VPN concentrator that's at our corporate office. But we might also want to communicate to a web server that's on the internet that's not part of our organization. So you might want to connect to my server at professormesser.com. This means that normally traffic that's destined for your corporate network would go from your remote user's workstation to the VPN concentrator. That would then be decrypted and sent to the inside of your corporate network. But if traffic needs to go to professormesser.com, that traffic still needs to traverse that VPN tunnel. It is decrypted at the concentrator, just like all of the other VPN traffic, but then is redirected to the internet and to the external web server. Any communication back to the client would then need to go back to the concentrator and then be sent back through that VPN tunnel. With a split tunnel, we can avoid that additional routing that occurs when you're talking to a third-party website. So now at the remote user's workstation, we effectively have two different paths. We have our VPN tunnel back to our corporate network, and then we would have a separate path that is used for other third-party traffic. If we want to communicate to our corporate network, we would send that traffic through the VPN as usual to our VPN concentrator, which then decrypts the traffic and sends it to our corporate network. But if we also, at the same time, would like to communicate to professormesser.com, we would then, at the remote user's workstation, simply send that traffic as normal. The VPN client would recognize that we're talking to a device that's not part of our corporate network and would directly send that traffic to the third-party website without traversing the VPN tunnel. And of course, traffic back to our device would also not use that VPN connection. This means we can continue to have an encrypted and secure connection to our corporate network, but use a more efficient process of communicating to third-party websites.
Tackling your security concerns starts with a prompt. With Sola AI, you get answers to the security questions you really care about instantly. Get started with Sola, the AI you need to get security done.
Thank you for calling Capital One.
My team's Gen AI tool helps you answer customer questions faster.
We use RAG with LLM and customize them with our data for better accuracy.
If you've done anything in networking relating to switches, routers, firewalls, or other devices, then you probably connected over the network to a terminal or console. To do this over an encrypted channel, you use a protocol known as SSH. This is Secure Shell. This allows you to use this terminal screen to a remote device, but all of the traffic sent over the network is encrypted. This means you can put in your username, your password, and all other information, and no one else will be able to capture that traffic and see any of that important data. Secure Shell operates using TCP port 22, and it's designed to replace a protocol known as Telnet, which uses TCP port 23. Telnet is very similar in operation to SSH. It provides this console-based view of a remote device, but it provides no encryption, and that's why the best practice is to always use SSH and to not use Telnet. Working at a command line is useful, especially on devices that support it, but occasionally you need to be able to provide remote access to a graphical front end. You can do that by using some type of remote sharing software so that you can be at a remote location, yet still see and operate the same desktop as someone who's sitting directly in front of that computer. If this is a Windows computer, then you're using RDP, which is the Microsoft Remote Desktop Protocol that allows you to connect to a Windows machine and be able to access and use the front end as as if you were in front of the actual monitor and keyboard. If this is a Windows computer that you're connecting to, you're probably using RDP, or Microsoft Remote Desktop Protocol. This allows you to remotely control a Windows machine, either from another Windows machine across the network, or by using Remote Desktop Protocol clients that are available for nearly any other operating system. Another option for remote control of a device would be to use VNC, or Virtual Network Computing. This uses a protocol known as RFB, or Remote Frame Buffer. This is very similar in function to Microsoft's RDP, but the VNC functionality can be run on many different operating systems. If you're part of a help desk or support team and you need a way to remotely connect and control any of these remote desktops, you're probably going to be using RDP or VNC. Sometimes you need to be able to make changes to hundreds or even thousands of different devices. You could automate this at the command line using scripts and batch files, but because this operates in the command line, you don't have a lot of control over the process if you happen to run into problems. For that reason, you might want to use a more automated method of controlling that device using an API, or Application Programming Interface. Using an API, you can connect and control a device using the language that that device would expect. This also allows us to automate the process and set up additional tasks if we need to do any type of error handling. If you happen to be in the same physical location as the device, you may be able to plug in a cable and directly connect to the device. With switches, routers, and other infrastructure devices, you might even have a separate port on the front labeled console. That console allows you to connect through a serial connection so that you can plug in your RJ45 serial and DB9 serial connection, or a more modern USB connection to be able to gain access to that system. The console is also a perfect solution if you lose network connectivity to the device. If you're not able to ping or SSH into the device, you can always connect your console cable and directly communicate with that system. These consoles are commonly text-based interfaces, so you need to know the command line interface for that particular device. These console connections are commonly serial connections, so we will need a laptop or desktop computer with a serial port, or we will need an adapter that can convert between USB to a serial connection. Instead of individually connecting to devices, some organizations will create a jump server that allows you to connect to one device. From there, you can jump to the other devices within that particular organization. This means from your external device, you would use some type of
Recording in progress.
SSH connection to initially connect to the jump server. Because this jump server is often an externally facing device where anyone on the internet could potentially connect to that system, this needs to be very hardened. We need to be sure that we're using authentication with multiple factors to be able to prevent anyone from brute forcing their way into that jump server. From our external client, we would use some type of third-party software, VPN, SSH, or some other secure mechanism to gain access to the jump server. Once we're on the jump server, we can then connect to all of the other devices within that organization without having to set up separate connections for each individual device. We obviously need to be sure that this jump server is always kept up to date with security patches and that we provide a high level of authentication to prevent any third parties from gaining access to the inside of this private network. The console connection on a switch, router, or other device allows us to directly connect, but very often we're located in a different network at a different facility, and we still need some way to gain access to those systems. Fortunately, most devices support in-band management, where you can assign an IP address to that device and then connect to it using SSH or web-based front end. Sometimes this in-band management is a separate interface on the device. Other times it's built into other interfaces that already exist on that device. When configuring that switch, router, or other device, you would provide it with a management IP address, subnet mask, and other important networking details. And from that point forward, you can connect to this device across the network. Usually this device has a web server running internally to the device, or it may be using an SSH server so that we can connect from our SSH client. Here's an example of a switch that not only has a serial console connection that you can directly connect to, but it also has a separate 10.100.1000 management interface. This is the interface that you would assign an IP address, and and then you would connect your network directly to that interface. From that point, you can simply reference the IP address and be able to connect to the device across the network. If mid-band management is using an IP address that we connect to through our existing network, then out-of-band management is using a serial interface that does not use our existing network. Commonly, this would be something like a separate management or console interface that we plug into using that serial connection. On more modern devices, you might find this to be a USB connection. This separate console or COM port on the device also allows us to connect a modem. So we might use a standard phone line, connect a modem to that phone line, and be able to dial into that device even when the network happens to be down. In some organizations, you can even install a COM server, so you can dial into one server, and from that server, you can jump
How are you doing?
through that COM server connection. You would need to look at your switch, router, or other device to see if there is a serial connection or console connection that you can either directly connect to or use a modem to dial into from a remote site.
At King Soopers, you never compromise. You get up high quality that's guaranteed fresh and down low prices on over 1,000 items.
In IT security, there are a number of different topics to consider, and in this video, we'll look at some of those security concepts. We'll start with the categorization of data. If data is transferred across the network, we refer to that as data in transit. You'll sometimes hear this referred to as data in motion. Anytime you have information that's being transferred over a wired or wireless network, you have data.
What's going on, everybody? Welcome back. Welcome back from lunch. How y'all doing?
Are designed to get information from one place to another and not necessarily to protect that data.
Good to see y'all. Hope y'all enjoyed your lunch.
A router or some other network device, its primary process is to forward that traffic to the next location. The requirements for security would come from other devices, such as firewalls or intrusion prevention systems. These are systems that are designed to monitor the traffic, decide if traffic should be forwarded or blocked, and then look inside.
All right, so this afternoon we're going to start getting back into one of our courses that we do have. Did anybody have any questions from this morning?
Data in motion through the use of encryption. Two very common encryption types.
Charles is thinking, look out.
Which is transport layer security, and IPsec, which is internet.
You may not have any. Okay, cool.
If you're saving information to
all right, so this is what we have. Give me 1 second.
Another type of storage device, we refer to that data as data at rest. One common way of encrypting data at rest is to encrypt the information as you write it to the storage drive. This means that if someone gains access to that storage drive, they would have the encrypted files, but they would have no idea.
All right, let's see here. Let's see what we have. Doing, 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 doing. Get my screen to share right here. Bam. We're just gonna pick up to where we left off at. So what we did before we went to lunch, me and Martin got together. He's on his way to take his exam. So wish him some luck in your own way. So hopefully when he gets back, he may not be, he's got to go through some traffic, but hopefully he'll be back today to get that to tell us what his results were. All right. So here we go. We're going to continue our conversation on disaster recovery. And one thing I like to do is actually just to get my screen where it's supposed to be.
Any network is maintaining the control and management of all of the different encryption keys and certificates.
All right, that might work. Bear with me for 1 second.
All of these different certificates as a public key infrastructure, or PKI. If you're creating digital certificates, encryption keys, or any other type of digital security, you'll want to rely on the policies.
There it is.
Part of your PKI.
It just took some maneuvering, but I got it done.
PKI is not a small part of your security infrastructure. There's usually quite a bit of work that goes into the creation of a PKI, and there's often changes and updates to that policy as time goes on. Many organizations will begin building out their public.
Can y'all see my screen, or is it not showing?
No, I can see it.
Or signing public.
I can't even see you guys.
Individual users or individual devices.
Look, it's
PKI
going
then
on my Zoom.
becomes a requirement.
Aaliyah says, yeah, it's there. All right, so we're just going to roll with it.
For the entire organization. organization.
Lean with it, rock with it, roll
The
with
challenge
it.
that many organizations have is applying a level of trust towards a user or a device.
All right.
The way that they can assign this trust is through the use of a digital certificate. Digital certificates
I have no clue what's going on with my stuff,
by
people.
a central
But we just gonna go with it.
and that's what adds the trust to these individual certificates that are then deployed to users or devices. Instead of having a centralized certificate authority,
Give me 1 second. I gotta work out these details.
a more distributed form of trust called a web of trust. With a web of trust, if A trusts B and B trusts C, then A can also trust C. This process of creating certificates, a certificate authority, and then providing digital signatures for those certificates is often built into central operating systems. For example, the certificate process is built into the Windows domain services. There are many third-party options that you can use for many different operating systems.
All right.
One of the more common ways to provide this trust in an organization is through the use of a certificate authority. This is a centralized authority that all certificates start from. This means that if anything is signed ultimately by this centralized authority, you can trust it anywhere in your organization.
People can go crazy trying to stop a cyber attack. Acronis take the headache out of IT security.
Some organizations
I think right now that's about as good as this is gonna get.
their organization, but other times they may use
Having an issue trying to share the screen. Okay.
whether the CA
So what we're gonna do, we're gonna dig deep down into.
the CA is responsible.
I appreciate your patience. Thank you very much.
that all of the certificates
We're gonna get into disaster recovery concepts. Disaster recovery. I believe like last week or yesterday, y'all went into disaster recovery in Skillsoft and Percipio. Couple of things we got to keep in mind when we're thinking about disaster recovery. Getting everything back or making sure that the company is whole, or you have a plan in place to ensure the company can get back to being whole. So backups for most part are key, as a piece of information to get you back where you need to be. The second thing is you need a plan. You just can't be outside aimlessly thinking, oh, if something happens, we'll just do this. So it's going to take a lot of tabletop exercises, a lot of conversations with a lot of different departments, going over a lot of scenarios to say, in the event this might happen, a power outage for more than 3 hours, what is the plan to put in place or walk through to ensure that we have our data? If the building collapses before we get to work tomorrow morning, is there a plan for the business to keep serving? Hey, sir, I've basically been comatose. Oh, hey, it's just something. Is there a plan to have a backup site, whether it be a hot site, cold site, warm site? Is there something put in place in another state that can make us whole again and keep it going? So with that, you have to have your guidelines and procedures that you're going to have, and you got to prep. Or you're going to you have to prevent. So it's either you're in preparation and prevention, both those two things. With tabletop exercises, these are nothing more than simulations that you'll go through as you sit around a table and look at each other and say, here's the steps, the basic steps that we can put in place in order to make sure the business is still functioning and to contact key people along the way to make sure we're good. Okay, that comes to constrictive learning. Meaning, if somebody says something, hey, I might be saying something in a language like, hey, I'm in the power plant division. You probably didn't think about that. But when you said if we have a power outage and it's forward, then you cut the cable and then transfer. We can't do that because the power system that we're on is an isolated power system that goes through. And I'll be like, oh, dang. Sorry, Elaine, I didn't think about that. Anybody have any ideas? How would we work around that? Because Elaine's on isolate. Well, we might want to give them a conditioned power unit out there in order to supply it. Or we have to install $120-something thousand generator just that he has, just in case his power trips at his building, that's one less thing that we have to worry about. So you have to sit down and think about all these different things that's going to go on. Then you got to do a functional test.
That would obviously be a significant.
Theoretically, this works, but let's test it anyway. Then you have scenario testing. What if, right? And then the full scale testing. You're actually going to plan an outage. Now, most time when we plan outages with big servers or stuff like that, they generally do it on their backup systems. Why? Not the main system. They'll pick some systems and put them on there. Why do you want to test it with your backup systems?
With role-based access control, the administrator of the network determines what type of role an individual
Yes, you don't want to lose data in operational time. If I have a good backup, which I should be backing up before I do this, but if I already have my primary system backing up off-site, and I've already loaded the system on my backup system, I think right now I can afford to lose crap on my backup system if it doesn't go right. So I tested on my backup system first. If everything comes back up after a hard power crash and things are still in place, well, we win. We know that the equipment that we have in place is pretty durable. You know what I'm saying? So we can say, oh man, that acted better than what we thought it did, right? So that's cool. Then with the business continuity plan, the BCP, your business continuity plan should have a team of folks, not in just one department. You should have a representative from each department in the building to have their input. Then you do a business impact analysis. You see this all the time. What's one of the things they said after any breach or power, what do you think happens? What's the first thing they say? The representative says, for the time that they've been down, how did it impact them? What did they say, generally say? AAR? Yep. What did we learn after action report? For the time that we've been down, and then they take all those features and they be like, yep, we got to address these. Another thing that they say is, we lost millions of dollars. We've lost millions, people. Per hour, we've lost millions. Right? We all know that's a theoretical number though, right? Training accident, yep. And then a crisis communication plan. By in no way should anybody from the inside of the company or IT be talking to the press. Zero. I don't care what happens, because you can make an issue a bigger issue just by saying something you think is okay, or you haven't verified what happened yet and you're telling them they just gonna run with it. The media is just gonna run with it. We talked to Mr. T today. Mr. T, how you doing? I'm doing great. Notice you had a breach here. Thing was down yesterday. Can we consider that a breach? Well, breach is such a strong word, but was it a breach? Well, theoretically, it was a breach. Thank you very much. We'll talk to you later. More at 6. Mr. T's like, but I didn't say that.
Some of the more modern cameras
No.
provide motion detection, so you know.
Now the company's liable. Now they're like, oh man, somebody go grab T from his seat. We need to talk to him real quick. I would refer to yes, that is the correct thing to do, Mr. T, and I know you would. To the public relations team, send them to them so they can do that. Thanks, Mr. T. He said it was a breach in so many words. I didn't. So this is where these sites come into play: cold site, warm site, hot site. This is a little 1201. This might be 1201. I think it's 1201, right? Which one costs the most money to get on its feet?
And it may include additional security through the use of a deadbolt.
Costs the most money. Like if we walked into it tomorrow, we had to put more time and effort into this one to bring it up. Cold, correct. Cold site. Yep, you got to start everything up. It's an empty space. Servers are probably still sitting on pallets somewhere in the back. No cabling's been ran, nothing.
And in some cases, we combine these together to create multiple factors
which one would you budget in the company's inventory to make sure once a month somebody made sure all the backups were ran and somebody's walking through the building to make sure everything's operational between warm and hot? So you got a team that visits this site to make sure everything's on and could switch over if need be.
You get 5 years of the most reliable Wi-Fi.
It's not fully manned.
For a price that's
Warm.
exactly the same.
You're paying somebody to breeze through the space once in a while, turn everything on, load a backup, and then they leave.
Dear first place.
Right?
Experts agree Toyota.
Which one is budgeted to be on all the time and fully staffed?
Long and strong.
That might be the hot site. You got people in there at least 12 hours a day, if not 24, and at a drop of a phone call, everything's switched over. Backups are ready to go. Like it's an autonomous system, just waiting to give out data, right? That's the hot site.
So let's dive into the process of
all of this comes down to fault tolerance and redundancy. We're gonna start hearing those two words a lot in the next 6 weeks.
We'll look at all three of the A's associated.
Fault tolerant and redundant.
But first, we start with a piece of information that everyone.
We hear this a lot in aviation.
The identification.
When that plane goes up, if there's a hydraulic system, they got HS1. They got this hydraulic system number 1. But if that fails, they have a hydraulic pump number 2 for hydraulic system number 2. If that fails, they have a backup pump for HS3, right? They got so many backup systems, redundancy, so the airplane just doesn't fall out of the sky usually. Something's gonna back up, so at least get it on the ground safely, right? So you have to have redundant systems to do the same thing in IT. Maintains operation despite component failure, operates at a reduced capacity instead of shutting down. It uses replication, error checking, and what they call failover. Failover is when we know primary server number 1 on the West Coast was operating as of 11. Load balancer noticed it was some traffic coming in, possible attack. Load balancer immediately, this is a failover, switched to region number 2, where there was an active backup system was ready to go. Load balancer automatically switched over as it shut down server number 1. And we're working on it right now. We don't know what happened, but things are still operational. Is it going to be reduced traffic? Possibly. Are we going to have some customers that can't buy the new pink flip-flops that are limited edition with Doja Cat's face on it? Yep.
Let's look at a very common scenario where we're logging in.
I love Doja Cat. Listen.
From somewhere out on the internet from our laptop.
So, yes, it failed over somewhere else. And then the redundancy duplicates, offers a backup of some kind, and prevents the collapse of a system. Those 3 things. That's what it's going to do for you. In everything you do, in every business that you're in, you have some key performance indicators. Key KPIs is what they call it. Anybody ever hear that term? What gets measured gets attended to. Who's heard that before?
And we were confirmed by this AAA server.
Nobody?
On many networks,
my granny used to say that all the time. Yep, metric.
One time during the day.
What gets measured gets attended to. Meaning whatever you pay attention to gets better. But as soon as you take your eye off something else to put attention on that, what happens to the other stuff? It lacks. So then you move your attention to that as a key KPI. As soon as you put more energy into that to bring that, something else lacks. So you got to have a roaming eye all around your network to always have people looking out for you and identifying. You got to touch everything to see what's going on. With KPIs, you have mean time before failure. It's called an MTBF. Mean time to failure, MTTF, and mean time to repair. You see this a lot in maintenance. anything maintenance, right? Even with the Apache helicopter, they have what they call a MESM or cards, right? Maintenance cards.
Yeah.
They should say, go ahead, Elaine. I know you're gonna say something. You gonna add something? So they'll say like, if an engine change, how long should it take to change an engine in Apache?
It is a protocol that can be used on our modern networks as well.
He's adding some extra knowledge on here. I can see him. He's getting ready to.
I was gonna type it, but it was just gonna take too long.
Yeah, sometimes it's just better to unmute.
But yeah, it's a performance check, and after any changes have been made, you have to document what is called an MOC, which is a maintenance operational check. So for everything that you change, you're doing an operational check as well.
Yep. So that translates over, like every branch has their own way of saying stuff, but basically he's saying if you got to follow a checklist to change it, right? So you have to use the tech guide. After you change it, you got to have somebody sign that off to make sure you did it right. Then QA comes over to sign it to say that you did it right. Then he probably has to take the Apache out and run it up, do an engine check on an isolated part of the runway, right? Bring it up to full power to make sure the thing don't on you. Then that gets signed off. They put half fuel. Well, they put half fuel in a fuel cell to take it out to do that. They don't want to fill it up because if they have to drain the fuel cell and there's a problem, then they got a whole load of gas they probably can't use. So they get it halfway. That check's good. Bring it back to the line. Then they fill it up with gas, and then they say we need a pilot. They're gonna take this out for a minute and go through the checks. Then they do that, check flight, bring it back. Then they sign it off and say, yep, you can return this to flight status. So all of that goes into play. There's nothing different. They are all KPIs. So mean time between failures. In the aviation inventory, when we get parts, right? We know with the mean time to failure, we know that if I put a nose landing gear strut on an F-18, that thing can land at least 2,000 times before it needs to be changed. That's the mean time to failure. Expected lifespan before a non-repairable system fails. Right? If I need to change that, then we go into mean time to repair. Average time to fix and restore the nose landing gear to bring that aircraft back to flight status. How long is that going to take? Well, we get the part from supply, and we have the people signed off on that crew. We could probably get that nose landing gear struck down, slapped in 2 hours. Oh wait, we gotta jack the jet. That's an 8 hour. That's an 8 hour turnaround. Right? We'll have it done by morning crew. Dang it. Then you have mean time between failures. That's the average time between the system failure. Now, this is pretty unique. Total operational time divided by the number of failures. Now, these are straight failures. This means outside of the lifespan and outside of it just being repaired, these are these nickel and dime situations where these particular nose landing gear struts that came out of Mexico just snap in half. Like, whoa. Yeah, we had 3 nose landing gear struts come in. We got a new manufacturer. These things are just snapping. What? That's the mean time before failure. Yeah. Right? So now we got to renegotiate our contract with Boeing or whoever so they can make them for us. But no shade against Mexico. I just pulled that out of my hat just to say a country. But that's what we're looking at. All right? So when it comes down to load balancers, they're divided between servers, things that are resources, which are servers that are gonna give you information. Purpose of them is to distribute network traffic across multiple servers, improves application performance, the functionality, access to traffic cop, routes to traffic, make sure not one server works more than the other. Benefit, reduces any downtime because it'll recognize things. Why is that banana making me hungry, Michael? I don't know. Jeez, now I want a tasteful banana. reduces downtime and increases the scalability and provides redundancy.
There's usually 3 different components.
Now you can have a software or hardware. Now, IaaS, infrastructure as a service, for those who don't realize this. Now,
when a user tries to access
don't get confused now.
on a server, they don't already
You see this? We're gonna make believe that this is a switch. I'm touching it. I went to the stove. I bought it. I'm putting it on my network right now. Chick, 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 chick. That switch was $5 grand.
through those processes we spoke of earlier.
Infrastructure as a service is this.
And then if that information
We've been in business for 10 years now at Big Sugar Records.
to the client. The client then proves that they've authenticated
Big Sugar has Big Sugar money.
resource server, and the server will
I know, Michael. This is like, this is crazy. Leo on the slide, she's laughing. And Mr. Teacher's straight looking at me laughing. B, I see you. I see you, B. So listen, Big Sugar got Big Sugar money. So this is what we're going to do. I want to revamp the whole company with brand new equipment. How much is that going to cost? Then Kevin comes up. As your IT specialist, I've concluded, Big Sugar, it's going to cost us $2.5 million. Whoa, let's scale back on that. Big Sugar don't want to spend all this money on, you know. Kevin says, may I make a suggestion, sir? Go ahead, Kevin. That's why I got you here. You're the expert. Can we get virtual switches and sign up for cloud environment? We'll pay a subscription. How much money would that save us? Well, we physically won't have the item, but I can log in and control that item through the cloud. That's infrastructure as a service. All we have to do is pay for the bandwidth, and what we use, I calculate up to 1.5 million divided by outfitting the whole company. Check this out. Our subscription for this per year would only come up to 100,000. So sign us up. So that's what he's gonna do. Kevin says, "Is that what I'm going to sound like posting it?" Yes, you will, sir. You will be nerding out, and be proud of it, sir. So Kevin said, "We're moving our infrastructure to the cloud. I can manage it through a network." Yeah, there you go, Charles. Voice actor potential. And then with a subscription service to use virtual appliances, we win. Okay? Now where we lose is we create virtual machines that are always online, that are just spending money like a water faucet. Because remember, you get paid. We have to pay the company 1 cent per minute for every machine that's running. But if I have somebody do the math. If I have 500 machines running in a day, 8-hour period, 500 machines running in a day, and there's nobody sitting at the machine, and I'm paying 1 cent per minute for each machine. How much money did I just spend? 500 machines on all the time for 8 hours a day. I'm spending 1 cent per minute, $2,400 a day. That's why you have to control the cost. And now your IT individual has to monitor if machines are on and nobody's at work. You got to go in there and log them off or turn that machine off. You understand? So now you're watching you got to turn the faucet off so the company's not wasting money. So, all right. Here's the load balances zerogram diagram. We've seen this before. A client tries to connect to the virtual server. This is infrastructure as a service. Virtual server. This is in the cloud. Then the cloud turn. Then it goes to the virtual load balancer. It says, okay, we have the initial server, kicks it to the load balancer. Here's our web servers. Parses out the traffic. 1, 2, 3. And then if anything's going on, you have the firewall set up too. So the firewall's in there to make sure it's guarding all of these too. key thing is to have high availability. We want high availability, Big Sugar. We got downloads happening like this. We got 4 billion downloads. We make money. So we have to make sure that the network's up. Systems that ensure continuous operation and minimizes the downtime via redundant components and fail over. It fails over into an operating system. Don't have to worry, it's been configured to do it already. They ensure continuous service, minimal downtime, automatically manage failovers, monitor systems health, and is good for uptime. They have what they call the 6 nines. I say 1 9.
Attackers, though, are very good at determining what might be real and what might.
Somebody look this up for me. How many seconds a year is that? To have 99.999 uptime.
Watch what they're doing during these attacks.
For a system.
To make this attractive to the attacker, we need more than simply.
That means I'm paying a ridiculous amount of money to make sure my system never goes down every year. How many seconds per year is my system like officially down where nobody can get to it?
We now have a much larger deception framework.
Is that 31,352 seconds or 3.13 seconds?
They would move to a HoneyNet server, and then we might see if we can move them over to the HoneyNet NAS. These are commonly
quick question, huh?
Any number of these to be able to
seconds.
Attackers. If you want to read more about honeypots and HoneyNets, there is a wealth of information on the internet, and a good place to start would be projecthoneypot.org. In the world of IT security, a lot of the decisions that we make are based on risk. Risk is the exposure that we have to something that might be harmful or something that might be dangerous. If we need to describe how
service level agreement 99 point. Can y'all see that?
Then we would be describing risk.
Or no?
Risk is a
dang, 31 million seconds. That's crazy. Let's look at this one.
The more risk they tend to take on. We would always want to consider how risky a situation might be during the process of expanding.
Service level agreement, right? So uptime and availability. Daily, it's only 0.86 seconds. Weekly, 6 seconds. Monthly, 26 seconds. Quarterly, 1 minute. A year, 5 minutes. For the whole year. That system's only been down for 5 minutes. Ain't that crazy? But if I want more availability, that's just 5 nines.
If you've been reading through your monthly Microsoft patch notes,
But it's the 6 nines. Let's go up to the 6.
Vulnerabilities that have been identified.
Let's add another 0.
These vulnerabilities are listing a set of weaknesses that are associated with the current version of the operating
Just by adding one more 9, that means the system for the whole year has only been down for 32 seconds.
systems or our data. And just
The whole freaking year.
discovered doesn't mean the vulnerability.
Ain't that crazy?
Researchers
Oh
are
my
identifying
God.
vulnerabilities all the time that may have existed.
If you ever want to use this website, somebody asks you a question,
And of course, there are
here you go.
different types of vulnerabilities. There might be a vulnerability
Put that in your Rolodex.
data that can be injected into a
Uptime
data source.
seconds.
Okay?
The authentication process
It's good information to have.
for the operating system has a vulnerability or
But with the 9s, for every 9 you add, you're probably
data that's exposed or
adding millions of dollars
all of
a year to have that extra 9 for reliability. So companies like AWS and Google, right, and Edge and Microsoft, they're making sure that they have this up.
breach itself is
Okay.
described as an exploit. This is when
Now you can cluster everything together. That means you want to cluster the servers together. In the event one goes down, the other one kicks in. They're clustering. They're basically saying like, Michael has his laptop at home right now. Or let's give him a desktop. He made a server for this whole class, right? But in the event his computer goes down, he's copied everything over to a second desktop, and he took that NIC card. He put 2 NIC cards in each one. In the event any NIC card goes down in each one of these, it automatically fails over to the other desktop, and they reassume the primary position of providing you information. So Michael, he clustered 2 servers together by making sure they were redundant. If this NIC card goes down, well, the other NIC card kicks in desktop A. Now, if that NIC card went down, automatically it's going over to server B. They got two good NIC cards in there. They're mirroring all the time. So that's how he makes sure he's up to the 99999, right? If he wanted to make sure he kicks in an extra 9, he's going to add a server number right here. He's adding server number 3. NIC card teaming, 2 cards in there. Now, number 2 goes down, boom, they kick over to number 3. Now, if you look at that at a larger scale, these are huge servers that you're paying for. And you got to remember, a lot of this money for redundancy and clustering will never get used during the year. Like those actual servers will never fail over. And if they ever did, it's usually for a test and check, or it happened so fast and it switched back because it noticed a glitch. But by the time you notice it, they didn't switch back to the primary position before. Could that money come back as a bonus to the? It can come back as a bonus to the company. It can come back to the bonus to the company. But they spend so much in energy costs. You know what happens when us? I'm gonna show y'all a video because this is what we're talking about. So after the next break, we're gonna go into a video. I think y'all gonna find it. Do you know when they build a new server farm in your backyard, they give them so many tax breaks and energy breaks. They add a portion of that energy that they're using in that server farm on your electric bill. So when notices come out like, oh, we're having our energy in the area is going up, we're going to charge you an extra $1.30 or extra $2 a month. That's to offset the cost of the server farm because they drain so much energy off the grid. The electric company has to do something to provide them sufficient energy. See, so, hey, listen. Server farms are good for data redundancy, but they're not good for the community for jobs. Why? They're good for redundancy. People think they bring a lot of jobs to the community. They really don't. Why? Think about it.
Get more done with one.
Charles just said it. You do not need that many people to maintain it. Let's just say I have a server farm as big as Walmart. Either I'm contracting a repair company to come in and fix it whenever it goes down or replace something, or a roofing company, right? Vetted companies to come fix stuff around the place. But how many actual employees do I need to make sure the servers are up? I might have a security team, less than 20, exactly. And I might have a full-time security team, 24. That's probably where all my money's going. To the guards that have to roam around and secure everything. I got more than them than I do the actual folks that are working on the inside. So you got to think about this stuff. This means that any data that is collected by that country. And then they have this thing called first hop redundancy, where anytime that something is happening, it'll notice, the load balancer will notice that, hey, it's taking more than one hop to get somewhere, so it will adjust itself to make sure that they'll always have first hop. Quick information, quick way to get into the server. And we learned about this, first hop from router to router. Another type of compliance regulation, you need to make sure that you understand where the data is supposed to be located. All right, 2 more slides. Let's get through this. Let's talk about SNMP, Simple Network Management Protocol. I like to call this the network snitch. This is a regulation that's associated with the protection of privacy of data associated with SNMP, Simple Network Management Protocol can be set up. That's why I give you these nicknames to these, so it kind of coincides if you go into the exam room. You're like, dang, he said this was a snitch. Yeah, it tells on you. It operates at the application layer, uses these 2 ports. Must be stored in the European. Yep, they're going snitch. Yep, SNMP. Wody. SNMP will monitor your network devices. If they notice anything, snitch, they're gonna send you a message. And you can use this to configure remote devices. Let me tell you what it does. So SNMP Manager is a centralized system for network and monitoring. All right, so in this monitoring station, you can see a lot of things that are going on in your network without getting up and walking around. It all comes to you. There's a software module on the devices for the routers and switches. Notice I didn't say clients. I said anything you need to manage. Switches, routers, layer 3, all in ones, right? You can, as long there's software that you can put on them, and they will report back to an application interface where you can look at stuff like, ooh, what is this router doing today? Ooh, why is this one red? Why is this one having problems, right? Then you'll use the MIB, just the MIB. These are the men in black. Yeah. So the agent, the MIB agent is. So let's walk this back. I'm using a monitor. It's application layer. The agent is the router in the switch. Ooh, they're snitching on people. Traffic does not look good in zone 5. Right? The MIB is just the MIB. That is the collection of resources that comes from the system. Its interfaces, IP addresses. It uses the information inside of the device to snitch on you. So, if I notice Aaliyah's at work and I see she's not being productive and I look at her traffic and it's been configured to tell if someone's going out looking for Michael Kors purses. Leah, got her. Traffic doesn't match. Trap agent initiated. Message comes to cell phone. Leah's on michaelkors.com. Immediate shutdown. No. So basically, it's going to let you know, hey, this information is not matching the telemetry and the bandwidth that we set up to ensure our network is streamlined. I don't like it, so I'm sending out a message. It's basically saying, if you're not conforming, I'm telling on you. If you're acting a different way than what I set up in my agents, right, for net flow, I don't want short packets. I don't want giants. I want MTUs to be conditioned to go out at 1,500 bytes, right? Smooth. I need a load balancer to make sure it goes back and forth, right? If it matches this, I got a good system. But if I got a whole bunch of runs coming through, whoa, doesn't match the profile. Got a snitch on you. I get a trap message. Then I gotta go look at it. So this is what you'll get. They call them the SNMP trap messages. So there's a GET request, retrieves data from the agent, the switch or the router. Then the response is confirms successful value setting. So I can get the request and I can set the response and say, okay, this is what we need to do. Next thing I can set up the messages, get next request, gets the value of a variable used in table for table entries. This comes from scripts, y'all. Setting the value and the variable to give a response. If traffic meets this requirement on this variable, I need you to send me a message. It's going through a script. And then set request, set the value of the object or the instance, the packet size, the data packet size. Inform me and send me a request with an acknowledgement. So basically, I'm setting up SNMP to be a snitch on the network. See if something's not acting right. Now with security, we always want to use SNMP version 3 because it offers encryption. Where if you use SNMP version 2, it's plain text. People can read the traffic. You don't want that. You want to use version 3. Use certificates and keys. As DJ Khaled would say in Jay-Z, I got the keys, the keys, the keys.
These networks are operating. We'll ensure that we have things like oil and gas.
Like airplane comms, yep.
Make sure that the medical devices in our hospital are able to
So that's what we're looking at.
the other medical devices. When it comes to our critical infrastructure,
SNMP agents.
lives are on the line. We need to make sure.
So we learned about Men in Black, DJ Khaled and Jay-Z. I got the keys. That's the whole lesson, right, B? But to be serious, no, we learned about SNMP traps, where you can actually set up traffic configurations. You usually hear it called net flow or IP flow, where you like your traffic to be conditioned going through the network that's optimum. Mr. T may set up traffic where I only want each client to send out 10 megabytes per second and to receive, right? Asynchronous traffic. I'm limiting, but if I see somebody pushing more than that, SNMP is going to notice, why is this one computer or this one switch sending out more than what I wanted it to? Well, so I could have gotten in there and hacked in there and changed the configuration for the port. SNMP will snitch on you, send me a message, and then I log in. It's like, I've been compromised. Remember, Mr. T said it was a breach. He told the news that. So now I gotta, yeah. So we gotta fix it. We gotta fix the configuration, make sure everything goes back.
The traffic lights may not work properly, or they may not work at all.
Kevin says he be wrecked it. Elaine says, is it for, yes, you are correct, Elaine. It's for system efficiency. It is a constant diagnostic that's being ran on the system. See, we always got different ways of looking at it. It is a constant diagnostic that you set up on the system to say you want it to operate in this parameter. If it goes out of that parameter, something odd is happening. You need to take a look at it because something could have changed without you knowing about it. Or you could have an appliance starting to fail on you. Right? Sometimes it's not always bad, like a hack. It could be the equipment starting to fail.
Yeah.
Or you could have a bad cable, right? Somebody did some work and put the wrong cable back on, which is causing the alerts. So yes, that's why. Good way of thinking at it. Good way of thinking at it. All right. Any questions on that, though?
You may see this also referenced as bring your own technology. This is when you own a mobile device.
Yes, you can. They call them false positives and false negatives.
Of course, this device still needs to meet the requirements of the organization so that you have.
Yep, it's just a lot. Just like when you troubleshoot maintenance on a jet, right? Sometimes you get a lot of false positives. I was the logbook technician, so I'm the one that logged everything and made sure everything got signed off before I made an entry into the aircraft logbooks, right? Make sure it was safe for flight before I handed it over to maintenance control for the pilot to take it. Sometimes they'll have something that will come back after a check ride or a check flight and they say, hey, this keeps going off. What do you mean it keeps going off? Well, every time I pull the thrusters or push the thrusters, this is happening. I get an alarm over here. Could be a false positive. Something's not just adjusted right. So they go in and take a look at it. Right.
By customizing your car insurance with Liberty Mutual.
All right. Well, tell you what, let's take a break. When we come back, I will have a video ready to play for you, and it's going to talk about servers being put up in residential neighborhoods. It's about 10 minutes, but it's very interesting. So I'll show that to you. See you when you get back.
Often this is an overloading of the system where others are not able to access because no resources are available on that particular system. For example, if someone was to overwhelm the capabilities of the server, that would certainly cause the server to become unavailable and therefore cause a denial of service. Sometimes an attacker will find some type of vulnerability in an operating system or an application that causes that service to become unavailable. In those cases, they can pinpoint that particular weakness and cause the entire system to fail relatively easily. This is one of the reasons that we often say you should keep your system up to date with the latest security patches so you don't find yourself being taken advantage of by one of these vulnerabilities. When the denial of service is underway, that system is no longer available, which would be perfect for your competitors. And there have been times when the competition has been identified as the organization causing the denial of service to begin with. Sometimes this denial of service is a distraction. In reality, the attackers are going after a different part of the network, but by bringing down this one particular server, all of your troubleshooting resources are now spending their time on this server rather than the other parts of the network that could be under attack. And of course, a denial of service does not have to be complicated. Someone could walk into the side of your building, pull the main power for your entire facility, and then you would have an enormous denial of service. Many times a denial of service is caused by a third party, but it's very easy to accidentally create a denial of service situation yourself. For example, if you were to connect multiple switches together with multiple connections and you were not using spanning tree protocol, you would be creating a loop on the network. This loop would cause more and more traffic to traverse the network, and very quickly you would find that the capacity of those switches would be completely overwhelmed. If your internet connection has limited bandwidth, then simply downloading a single Linux distribution could effectively cause a denial of service for anyone that needed to use that internet connection. You also have to think about the physical environment where your data center resides. Something as simple as a water leak or a leak from the roof could cause an entire section of the data center to become unavailable. Unfortunately, a large percentage of denial of service situations are caused by multiple devices all acting in unison to cause this denial of service situation. We refer to this as a distributed denial of service, or a DDoS. For example, a single botnet may be able to take over millions of personal computers and have all of those devices direct all of their traffic towards one single server on the internet. This type of coordinated attack from multiple devices that may be located anywhere in the world is a very common form of a distributed denial of service attack. And in that particular case, devices with very limited access to the internet could still manage to bring down systems with many more resources available. We refer to this as an asymmetric threat because the attacker has so few resources, yet they're able to disrupt and bring down systems with many, many more resources. The attackers have also found ways to make their process so much easier when they're attacking someone with a denial of service. They refer to this as a DDoS reflection and amplification. With this attack, the attacker sends a little bit of information into the internet, and the internet is able to multiply that particular attack and send a much larger amount of traffic to the victim's device. Since this doesn't require many resources for the attacker, it's become a very popular way to overwhelm the capabilities of a particular remote host. The attackers have effectively taken the systems and protocols that we use every day and turned all of those against us. Protocols such as the network time protocol, domain name system, or the internet control message protocol can all be used to amplify the messages that are sent to the victim's computer. Let's take a look at what this amplification looks like before the attack actually occurs. A DNS query is one where a device is commonly requesting an IP address from a server. It's a relatively low bandwidth communication, and very little information is normally transferred. But there is information stored on a DNS server that can return much more information than simply an IP address. Here's an example of what this looks like. We're running the DIG command with the any parameter to the name isc.org. And instead of simply receiving an IP address in return, we're getting information such as DNS key information that is embedded within that DNS server. These keys returned as part of this DNS query are normally used to verify a digital signature that's being sent out in an email. But in this case, the attackers are using this large amount of information to amplify the message that's being sent to the victim's machine. Here's how a distributed denial of service would look when you're using DNS amplification. This starts with a botnet command and control. This is the device that is managing the process of the distributed denial of service. That single device needs to include other machines that can add to this total amount of traffic. And the command and control machine is using a botnet to provide those additional hosts. This botnet is connected to the internet, where there are also DNS resolvers that are open and available for anyone to query. Also on the internet connection is the web server that will be the victim of this distributed denial of service. The command and control device sends a message to the botnet telling them to send that DNS query to one of these open DNS resolvers. The botnet sends this relatively small query to the DNS resolvers, and as we've already seen, the response to that query is a much larger amount of information. The botnet devices are spoofing the source of these requests, so the responses are going to go to the web server. And since so much information has now been amplified, it overwhelms all of the resources available on that web server, and the system has now become a victim of a distributed denial of service. This amplification process has effectively taken a query that was 28 bytes in length and extended it out to 1,300 bytes as a response. This makes it very easy for these attackers to quickly overwhelm these remote devices on the internet.
Aveeno Skin Relief with soothing triple odor complex. Clinically proven for 72-hour hydration.
On the switches that we use at home and in our offices, we will often configure separate virtual local area networks, or VLANs. These VLANs are designed to keep different parts of the network separated from other parts. For example, you might have a VLAN that separates everyone at an organizational level. So there might be a marketing VLAN, an accounting VLAN, and a shipping and receiving VLAN. At home, you might have different VLANs for your normal network traffic, your Internet of Things devices, and the cameras that you use for security. One of the advantages of these VLANs is that it separates these different devices into their own separate network. And each network is not able to communicate with the other unless there happens to be a router between them. But in some configurations, it may be possible to communicate to a different VLAN even though there's no router between those two VLANs. We commonly see this done in two different methods. One of them is switch spoofing, and the other one is double tagging. Switch spoofing takes advantage of a configuration on your switch that auto-configures an interface to be either an interface for a device or an interface for another switch. When you connect a device to a switch, the switch will automatically determine what's on the other side. And if the switch determines that it's connected to another switch, it could configure a trunked connection between those two interfaces. This is the real key to hopping from one VLAN to another, is pretending that you are a switch and being able to move to whatever VLAN you would like through that trunk. Since switches can send information from one switch to the other over the same VLAN, we can perform that exact same configuration by pretending or spoofing ourselves to be a switch. Once we connect to a switch and convince that switch that we also are a switch, we now have the ability to send information to any VLAN that may be configured on that particular port. This is why it's probably a good idea to disable this trunk negotiation process between different switches. Although this does make the configuration and management process of the switch a little bit easier for the network administrator, it opens up problems like this that can create security issues on your network. Ideally, the network administrator should manually configure trunk interfaces and not allow auto-negotiation. They should also configure individual VLANs that should be allowed to pass from one switch to the other. By disabling this auto-negotiation process, you've now removed switch spoofing from this ability to hop between VLANs. Another form of VLAN hopping is called double tagging. Obviously, VLAN tags are used in trunking between switches, and if we add additional tags to an interface, it's possible that we can communicate to a different VLAN. This type of configuration takes advantage of what we call the native VLAN configuration for a switch. All switches have a native VLAN, and by taking advantage of that configuration, we should be able to communicate to a different VLAN on that switch. We rely on these VLAN tags during the trunking process, and the VLAN tag is what tells the destination switch which VLAN this traffic is destined for. With double tagging, we've crafted a special frame that normally would not be seen on the network. This frame doesn't have a single tag on it, it has two separate VLAN tags. This means in certain configurations, we can have one switch remove the first tag and place that data onto the appropriate VLAN, and then have a separate switch remove the second tag and place that frame into a completely different VLAN. At that point, the contents of that packet are forwarded to the target, and we've now been able to hop from one VLAN to another. Because we're adding this extra tag to the frame that normally wouldn't be there, there's no way to receive a response from the information that we're sending. So everything that we're sending out is a one-way communication from one device to another. Although this is not practical for normal network communication, it does allow us to put data onto a VLAN that normally we would not have access to. If an attacker is trying to perform...
All right, here we go. So I have a video for y'all.
...to accomplish that.
This is CNBC. It's talking about servers being placed in your neighborhood and what effect it is going to have on you. It's pretty cool. So here we go.
Make it some other value, and then we would force tagging of the native VLAN for all traffic across that switch. Here's how this would work. We have a network.
The U.S. is home to the majority of the world's data centers. There are over 2,800 in the United States, and the next closest is the United Kingdom with less than 400. Now, data centers are becoming a real estate play for investors.
Simple economics. The demand exploded in the last couple of years.
Data centers are the physical backbone of digital infrastructure, housing servers and the equipment to run everything from AI and basic internet functions. But not everyone wants to live near these hubs of electricity.
75 people signed on to speak, and most do not want data centers built near homes or schools. A campus of more than a dozen buildings would be built near neighborhoods and 3 elementary schools.
The need for land to build the data centers on has become a sore spot in states where hundreds of data centers already exist, like Virginia.
There has been a backlash against data centers, and that's why I'm sitting in the seat that I am. People were frustrated. Residents felt like their voices were not being heard. They felt like some of the more contentious data center projects should have never been approved, and they want someone to listen to them.
How data centers became billion-dollar real estate investments. The world's top tech companies are pouring billions into building new data centers in the U.S. Amazon Web Services is investing an additional $35 billion to establish multiple data center campuses in new locations across Virginia by 2040. And top AI competitor Microsoft is reportedly planning to build a $100 billion data center facility.
What's driving that is AI. The big technology companies are telling us that they're going to spend $1 trillion on their digital infrastructure over the next 5 years. A lot of that's going to go into data centers.
Vacancies decreased in the first quarter of 2024 compared to a year prior. Some experts say new infrastructure is still not enough to keep up with the exponential demand for computing power.
I can safely say that in the next 3 to 4 years, we're not going to solve this demand problem. I think the demand for land is directly tied to the demand for power, and the value of the land goes up significantly if it's in close proximity to utility power that has immediately available capacity.
For example, Cyrus One Data Centers bought land in Virginia for more than $89 million, with plans to build. The seller had acquired the land for nearly $9 million a couple years before. The data center's proximity to a power center and power grid is more important than where the data center is built in the country.
So when you think about markets like Columbus, Ohio, Reno, Nevada, those are examples of markets that have emerged over the last couple of years as an alternative to places like Northern Virginia or Silicon Valley.
It's interesting, when we look at our global business today, not just within real estate, but across the entire firm, we see data centers as the most exciting asset class.
You know, when you think about the end users of the data center space, the biggest users, you know, it's a Fortune 20 list, Fortune 50 at best, all of them with a very strong balance sheet, all of them with a significant demand for incremental data center space globally. So my view is that we absolutely need more capital
to grow this industry and to keep up with the demand that we're seeing.
That capital is coming through private equity partnerships with data center providers.
I am Jordan Sadler, the Senior Vice President of Public and Private Investor Relations at Digital Realty. Our customers came to us and they said, how much capacity do you have available in this market or that market or all markets, depending on the customer? And this was an unusual request, and we had multiple requests of this sort. In order to execute on all of that demand, essentially to build all that capacity, we said, hey, let's tap some additional capital.
The total value of commercial real estate property for data centers rose more than 60% last year in places like Loudoun County, Virginia, the data center capital of the world. Local landowners are seeing the value of their property soar.
We do see that land gets more value when it is on the appropriate power line for a data center's need. My experience in working with data centers is they do value that, and they do, come to the table aggressively in order to obtain that land.
That means county tax revenues are considerably higher. Both the taxes for the property and the equipment within the data centers. In some ways, local landowners benefit.
Had that revenue not come in from a data center or any company or any industry in general, they would have had to probably raise taxes if they wanted to improve their water system, or if they had roads they wanted to improve. They might have to put that on the residents to pay the taxes for it. But when you have a large user that has a significant taxable valuation or tax assessment, and that money does go back to the community, and there is a levy for the schools too. So it's kind of like giving the community a raise.
But utility rates can come in and impact them in other negative ways. Dominion Energy has proposed rate hikes in several different states in 2024. They've dealt with unprecedented demand as of late thanks to data center business.
You're not going to believe what happened. Tell me everything. I'll show you on Monday.com. So I started the biggest initiative.
Residents have growing concerns about the outward appearance of data centers.
There are varying degrees of pushback, and being an American, you can relate to certain states where they push back quite a bit around all development, in certain locations where there might be more pushback around all development, and then there are places that are generally more pro-development.
Because one of my concerns is, where are we putting them? Are we putting them in areas that are residential areas? Are we putting them in land that's industrial? Another consideration is, how high can they go? There are some hyperscale data centers. We're looking at 110 feet.
Residents of Virginia's Prince William County have made their concerns known.
There's kind of a spectrum, and there's a benefit to operating in the places where it's tougher to build, because that typically means there's less competition or less supply.
One planned data center in Virginia's Devlin Park garnered enough pushback that a Twitter account and a GoFundMe account were created to raise awareness about a potential project residents didn't want built.
We have a lot of people on the board who are inclined to really limit where we put data centers. We cannot put them any and everywhere. And we also have a very strong, very vocal group of data center opponents. Don't want us to build any other data centers in the county because they feel like we have more than our fair share.
Prince William County supervisors say they consider each data center application that comes.
We cannot ban one industry from the county. We have to work with every applicant and look at every application that we receive. I do have a great deal of concerns about where they're sited. I have concerns about energy, and I have concerns about environment. And again, I'm very concerned about diversifying our commercial tax base within the county.
Some experts have also expressed concerns around the obsolescence of these data centers not long after they're built.
If someone came in and said, I'm going to build a data center and I'm just going to lease it to whoever needs a data center, that kind of raises a red flag to me about sustainability.
But Sadler feels like these buildings are not on a quick path to become obsolete, thanks to the digital transformations happening across industries.
While you do see the leading edge customers, the largest technology companies in the world, pushing the envelope on the infrastructure they need to support the latest and greatest NVIDIA GPUs, most customers, by number, are not the same as those customers. They're not evolving their technology needs quite as quickly.
This massive strain on localities' power systems is causing one company to consider renewable energy capabilities to meet this demand.
Over time, as we catch up with supply and demand, I think you will see some of that older space get refurbished, repurposed, find alternative uses, maybe EV charging facilities, fleet charging. We've done a couple of conversions in the Northeast of older telecom data centers into vertical farming. So some really fascinating alternative uses.
As for longevity of these buildings, experts paint a mixed picture.
Don't envy the utility companies right now. They've got demand that's, in some cases, 5x what they've seen over the last 30 years. And they're seeing that over the next 5. Massive amounts of demand, regulated in most cases. And so I do believe that all adds up to some off-grid solutions that may combine the utility source with the data center source in a single structured environment. And it won't be just in the US. I think you'll see that globally.
What is this industry going to become in 20, 30 years? Is this something that is still going to remain in the county? Are we going to have the same demand? I get nervous about the potential of empty big box buildings. And people are assuring me that, that's not going to happen. This is different. But that is still a concern.
They're not GPUs, or it's not a laptop or an iPhone where there's a next generation of this technology that changes every year or every 2 years. The general technology that supports the delivery of power to these servers is generally very similar.
But one thing seems to be all but certain. Near-term demand will be steady.
Technology is not going to go away. You look at, your NVIDIA, Intel, all of the different conversations around chips and what's going to happen and what's going to happen with training-based AI versus inference-based AI. All of that's going to create more demand.
Pretty cool, huh? Just having to look at how the demand of server farms come in, property goes up, all this different stuff. So it's a good way to look at it. Another way to look at it. Just wanted to show that to you. All right, cool. Any questions for me? All right. Well, turn 2 and do your assignments. Wait for Mr. Martin to get back and see what's going on with him. And let me know. All right, everybody, do not forget to take a break. 10 minutes till. Just make sure you get one in.
Yeah. How are you doing? Good. Currently doing class, but doing good. How are you doing? You're saying you've came to America or you're coming to America? Okay, you currently live in Saudi Arabia. Okay. Oh, that's awesome. Oh, it's really different for everyone based on the country that you live in. For Saudi Arabia, I would suppose you'd have to get some sort of a visa to be able to come here. So I think that's what might be the process. So I can type it here in the internet to see the process of coming here. So there's a few different kind of visa that you can get. There's a B1 and a B2. So you can get a tourist visa, which will give you just the ability to spend a certain amount of time, a few months per year, which would allow you to go back and forth. And you can get a student visa or you can get a business visa. Any one of those will allow you to travel back and forth. And you would most likely have to go through the process of doing the application. It's a process. If you get a student visa, you can go to school and you can stay for a very long time. Or if you have some kind of a business, or that will also give you the opportunity for a very long stay as well. But a good way to start is you can simply just apply for one, just apply for a tourist visa, just to get the process started.
Michael, don't forget to clock in. All right, welcome back, everybody. Everybody, welcome back, everybody. Y'all don't hear me sing. Shooby dooby doo. Oh, do what you gotta do, Mr. T. You gotta check on the baby. We love babies around here. Between you, Leah, and Martin, getting our baby food. Our baby teacup runneth over. No problem. All right. There's one thing I want to show you guys. Let me see here. I want to get into some type of activity. How y'all doing with your, well, everybody's doing pretty good. James, I might be having some intermittent Wi-Fi. There's a massive storm. Yeah. If you go off, just try to come back in. That's it. And if you can't get back on the Wi-Fi, try your cell. Can't get in on the cell, well, we'll just see what happens. First thing is your safety, right? Okay, I'll text you at least. Yeah, just let me know. Yeah, you can log on your cell if you have if you can't get in on regular internet. At that time, I let people get in on their cell if it's a storm. Yeah, that's an exception to the rule. Yeah. No problem. Let me just log on your account that you have a storm coming through. That's all. Doo-doo-doo-doo. Has anybody tried any of the one-on-one labs? Like for DHCP server or setting up DHCP? Anybody tried that yet?
The labs. No. No, haven't. No, haven't.
You started it? Which one did you start, Leah? Oh yeah, the DHCP. It's pretty smooth. I like it. Who has taken advantage of Cisco NetCAD Academy? Those Cisco lessons really help. So I'm sharing my screen right now. Doink. And this one is network devices and initial configuration. Okay. So with these, Elaine says, no, I haven't. Was trying some stuff on Cisco, which is cool. They both kind of lead back to the same. They're both packet tracer. You know what I mean, Elaine? So they both come out of packet tracer. So you're not losing it either way. It's just a matter of where you're at. You know what I'm saying?
Yeah.
So this one is the class networking devices and initial configuration. I like it because it says here, check this out. Let me introduce you to my friend Bob. Bob works in an IT field in the Vancouver, Canada office and has some networking experience. He is consulting with his friends, Marcy and Vincent, who have purchased a furniture store. This is why I like Cisco NetCAD, because they put you in a situation where it's like a fictitious kind of role, you know what I mean? And they're walking you through what's going on. He explains he must consider fault tolerance, scalability, quality of service, and security. Also, their network is currently flat, nothing hierarchical, meaning they're not scaling like a tree topology, right? And this is going to walk them through. Then what happens here, as a reminder, so if you go through here, here's all the resources. You can download all of these labs and put them in your Cisco NetCAD or Packet Tracer folder and always revisit them. They don't have to sit in here. Oh, really?
Yeah.
Oh, really? Oh, see? That's why I said you don't. There you go. You're already there, right? You just took a different route.
Yeah.
So here they start getting you into reliable networks and architecture. So when you go through, it shows you fault tolerance, scalability, quality of service, and security. And it walks you through the example. So here, let me see here. Okay, is my sound on? Yes, it is on. Yeah. So this is what you'll see for this example.
In this scenario, we have two parts to our network, each one with its own path to our ISP and the internet. Packets originating from PC1 are eventually forwarded to router A and on to the ISP, while packets originating from PC2 are eventually forwarded to router B and then on to the same ISP. But what happens when there is a problem with router A or with a link used along the path to router A? Packets requiring router A to forward them onto the internet will get dropped and can no longer reach their final destination.
Mike, log in for me.
A fault-tolerant network is one that can continue operations without interruption when one or more components of the network fail. We have now installed additional links in our network, giving us multiple paths to reach our ISP and the internet. Having multiple paths to a destination is known as redundancy, one of the ways to help make the network fault-tolerant. If one path fails, the packets are automatically forwarded using a different link.
The more redundancy in a network, the more fault tolerant the network becomes.
Okay, so in this scenario, we were talking about fault. It says it fault tolerance, something to fall back on, fail over. If your interface fails, they have several ways to route your traffic. This is the kind of nonsense you'll see on the exam when they show you all these dang routers and diagrams, and you're gonna get lost in it.
Yeah.
And Charles is gonna feel so overwhelmed. He's gonna be in a room like. But walking through this now paints a picture. So when you see the whole network, you're like, oh, I get it. I see what's going on here. Right? Kind of reinforces. It helps you to isolate. Is that a good word to say it? Is that a good way to say it? It helps you to isolate what you need to do. So you're not all over the place. So when you go through here, oh, look, it says fault tolerance. It tells you here, redundant connections allow alternative paths. It goes through to talking about scalability. Quality of service. This is a question on the Net Plus exam. What do I need to do to make sure voice over IP and or video or teleconferencing, SIP, remember SIP, session initiated protocol, where they're using chat, video, and audio in heavy use. Port 5060, 5061. Those two ports, okay? 5060, the client uses.
Yeah.
5061, the server talks to you on that port. Talks about network security, then it it checks your understanding, of course. We'll get back to that. But then there comes where you do the labs. Gives you the scenario and tells you to hook up PC number 1. The lab requires you to determine availability status of the network cards on a PC to provide. Windows provides a number of ways to view this. You hook a PC to a router, and you're working with NIC cards. And you can change the adapter options. And it just keeps walking you through. This is pretty cool, actually. And it simplifies it. You don't have stuff all over the place. Okay, so I highly advise, like Leah put in the chat earlier, this kind of helps round her out sometime or understand maybe a hole somewhere.
Yeah.
Because it's so straightforward. But I just wanted to show you that. Know what I mean? Hey. Oh man, y'all let me just act crazy. Appreciate it. But any questions for me? I just wanted to come back to this to try to get y'all another way to look at things that's more simplified. Yeah. Word up, hey. All right, but if you need me, you know where I'm at. I know Jesus. Word up, hey. All right. I'll be right back.
All right.
I'm gonna go peek around the corner to the other classroom, so I'll be back in less than 15 minutes.
Yeah.
You know, it's funny, Kevin, you asked that question. How to trace an address to a physical, track an IP address to a physical address? Sometimes if you know how to read packets, you can see where it's coming from. Or another way people used to find out people's personal addresses at the house, like to find your IP to your house, is they can track you through email headers. Because your email bounces from IP to IP to IP to IP. Yeah. It eventually hits your public address, converted to your private address, and boom, there. So you gotta be careful. Now everything usually dead ends to your ISB, like interchange, your IPX. Put that page in your Rolodex. He said carrier pigeon. Hey y'all, Martin just texted me. He passed! Woo! Let's go! So when he gets back in class, if he comes back today, he's still logged in, but he should be on his way back from the testing center. He might make it. But when you see him next, just tell him a big E-raw. All right, everybody, let's take our last break of today. Yay, yay. See you in 10 minutes. there's any airmen in the room, happy birthday. Air Force birthday. Oh,
Yeah.
ain't that cute?
The Xfinity 5-year price guarantee. You get 5 years of the most reliable Wi-Fi with our best equipment included for a price that stays exactly the same.
One constant challenge we have, both at home and in our offices, is the threat of malware. Malware is a broad term that describes many different types of malicious software that can cause problems, steal data, and effectively disrupt your entire computer. Sometimes these are capturing information that you're typing in or capturing images from your webcam. There might be multiple computers infected with malware, and they're all working together as one botnet. Perhaps this malware is really designed just to show you advertising, so it's making money for the attacker or the author of the malware. And there may be viruses and worms that are able to replicate themselves either with your help or without your help and infect other devices that may be on your network. A generic term for malware that uses humans to replicate and spread is called a virus. This is a very broad term that is used to describe many different types of malware, but one common trait with viruses is that it requires human intervention to be able to replicate itself from one machine to another. This is different than malware that's delivered as a worm. A worm is malware that's able to replicate itself from one computer to another, but it's able to do it without any type of human intervention. For that reason, worms are considered to be much more dangerous than a virus is. With a virus, we can simply choose not to click on a particular link. With a worm, that malware can replicate itself without any type of human intervention. Ransomware is a category of malware that gets on a system and begins encrypting all of your personal data. The ransom part of ransomware is that they will give you the decryption key, but you'll have to pay for it. Very often you're sending cryptocurrency or some other type of currency to the attacker, and they're providing you with a key that you can then use to unlock your system. You're effectively having to pay the ransom to get your data back. A Trojan horse is malware that gets on your system by pretending that it's something else. You can be presented with an executable that says it's a game. When you click that executable, it is installing software that does appear to be a game, but behind the scenes, there is malware that's infecting your system. A rootkit is malware that's able to hide within your operating system itself. This means it's very difficult to detect because it's part of your operating system itself. It's also very difficult to eradicate. When keyloggers infect a system, they're going to record every key that you press. This is especially important during the login process, where this keylogger will record your username and your password. will then send that information to the attacker, and now they have access to the same systems that you do. Adware and spyware is especially good at presenting you with advertisements on your screen, and that advertisement is making money for the malware author. Although bloatware is not directly malicious, it is software that does cause problems on your system. Bloatware is software that's usually preloaded on a system, and often it's software that you'll never use. This bloatware takes up space on your storage drive, and often it has processes that are actively running in the memory of your system. If you were to remove this bloatware, you would free up those resources for legitimate applications. And logic bombs are especially good at waiting for a particular event to occur, and then they execute. Often this is a time of day or a day of the week, and when that particular time or date is reached, the malware begins to execute on your system. Very often, multiple types of malware are working together to infect your system. Here's a very common scenario where a worm might take advantage of a vulnerability that's on your system because you did not update to the latest series of security patches. Once that worm finds its way onto your system, it then embeds some malware in the form of a remote access backdoor, which then allows anything to gain access to your system from that particular malware author. And often they will install a bot on your system where they are now able to view and control your computer remotely. For any of this to work, there has to be some executable that runs on your system. With a worm, that executable can run automatically, but very often that executable needs you as a human to be able to click on something. That's why we often say as a best practice, you should never click a link that's embedded within an email on your system. You might also see pop-ups appear from a website that entice you into clicking those. Those might also run an executable. And you also have drive-by downloads that may download an executable onto your system without you having to click anything on a particular web page. And as we've already mentioned, worms can move from machine to machine without you clicking anything. Fortunately, worms are relatively rare, and it's very unusual to find one that can move from system to system. This is why you constantly hear the best practice of keeping your system up to date with the latest security patches. If your system has closed those holes and there are no vulnerabilities in your operating system, you can prevent this malware from embedding itself into your system. And of course, the same thing applies to the applications that are running on your system. Make sure that not only the operating system is updated, but all of your applications as well. Ultimately, the malware authors want to somehow make money from your system, and occasionally they will make that money by taking your data. Ransomware is a good example of this, because with ransomware, your personal data is very valuable to you, and if someone was to encrypt all of this information, you could be enticed to provide them with the ransom to be able to get your data back. If ransomware hits a system at work, the stakes are a little different. There may be planning documents for the company, there could be employee details and personally identifiable information, or PII, or there might be private information and financial details that the company does not want to make public to others. There is usually a number associated with the value of this information. It's not unusual for organizations and individuals to work with the malware authors to provide them with the ransom they're looking for in exchange for your data.
I would describe Underline as fast, affordable, and incredibly fast, very reliable, zero lag.
That's kind of fast.
Consistent fast.
There are a number of different ways to help protect our computing devices, and in this video we'll look at device security. As we've already seen in this course, port numbers are used extensively to be able to transfer information across the network. But these port numbers can also be a way into your system. Each network-based service running on your system has an open port number that can be seen by others on the network. That port number is effectively an entry point into that service that's running on your system. If that service is actively in use, then we need to keep that port open. But if that service is one that you're no longer using, then you should close the service and make sure that port number is not accessible from the outside. One way to control access to this open port would be to use a firewall. A firewall can give you control over what devices are able to connect to your computer. So you can decide whether you would like individuals on the inside of your network to have access to this port number, or if you'd like to open it up to a wider audience. Sometimes port numbers are open on our computer and we have no idea why that port number is open. Often this is because there's a service that's running on your system that you were simply not aware of, and that service opens a port number to the outside. There is a large range of port numbers that could be opened on your computer, specifically port numbers 0 through 65,535. Any service running on your system can use any of those numbers to enable access from others across the network. If you're wondering just what services or port numbers may be open on your computer, you can use a third-party tool such as InMap to scan your system and see what port numbers are advertised to the world. From there, you can decide whether that's a port number that needs to stay open so that service is available to others, or you can choose to shut down that service and remove that port number from your system. If you've ever installed a switch, a router, a firewall, or any other networking device, then you know there is commonly a set of standard credentials to be able to log into that device. Many devices will require you to change those credentials the first time you log in, but a large number of devices simply have those default credentials available for anyone to use at any time. Obviously, keeping those default credentials on a system mean that anyone who happens to know that default username and password could potentially gain access to that system. And in many cases, these default credentials provide administrative access to the entire system. Leaving these available would effectively allow anyone to have complete control over that system. If you're wondering what the default credentials might be for a particular device, there's a database of those that you can find on routerpasswords.com. This website provides a database of all of the default usernames and passwords for these devices that you may already have installed on your network. One of the challenges with securing a switch network is that you can't physically be watching every single interface on every single switch all the time. But there are features within the switch that can provide you with additional security, specifically port security. Port security is a feature built into a number of switches that prevents someone from unplugging an existing system and plugging in their own system into that same interface. The switch will recognize that a new system has now plugged in, and it will prevent that system from communicating on the network. This is based on the MAC address, or Media Access Control address, of this device. That MAC address describes the physical interface on that network interface card. And by configuring your switch to look for those MAC addresses, you can prevent someone from effectively changing the MAC address in the middle of the day. The configuration for port security usually starts by telling the switch how many MAC addresses should be associated with a particular interface. You can decide if one particular MAC address should be associated with one single interface, or if there should be multiples associated with that interface. You can also specify the exact MAC address that is allowed to communicate over that physical switch interface. The switch will then monitor every device that connects to that particular interface, and it will record the MAC address of all of those devices. If you then connect a device that the switch is not expecting to see, you will see that port security will activate on that switch. The default on many switches is to immediately disable the interface and send a message to the network administrator. Another good security best practice for protecting your devices is to disable any unused interfaces on those switches. If you've ever walked into a conference room or break room, you may have seen Ethernet interfaces on the wall, and those interfaces may or may not be enabled. The best practice, of course, is to disable those interfaces until someone needs to use that particular port. This requires a bit more administration because you have to keep track of what interfaces are enabled, what interfaces have been disabled, and occasionally you'll be asked to enable an interface that is currently not operational. Although this takes additional time and effort to be able to maintain, it also makes your network much more secure. Some organizations take this to the next level by having each interface require authentication before you can communicate on the network. This is referred to as Network Access Control, or NAC. You'll often see it implemented as 802.1x. When you connect any device to the network, or you connect to a wireless network, it will first prompt you for authentication. You have to provide your username and password, and only then are you allowed to communicate on the network. Some administrators will even use MAC address filtering to keep out devices that they would not like to have on their network. As you recall, the media access control address is the hardware address of a device. So you can effectively limit access to the network based on the physical device that may be communicating across that network. This is very useful for keeping out devices that are not authorized to be on the network. But when new devices appear or you have someone visit, you may need to enable their MAC address in the filter so that they can communicate on the network. One of the challenges with a media access control filter is that the MAC address on a device can be administratively changed. You can change the software
All right,
configuration.
you know what we about to do. It's like 20 minutes till, so we're gonna do
This might allow
Quizlet with some terms. We're gonna see if y'all know y'all acronyms or not. Gotta know those acronyms, baby. They threw them at, I know, Kevin. They threw them at you on the exam. You're like, what's that again? ACL. I hadn't torn my ACL since college. No. It's crazy.
Yeah.
Access control, right? Okay, listen. That didn't land very well. Dad joke. Listen. We're not talking sports with ACL. We're talking networking. So we're just gonna see where your mind's at. Okay, you know how we do. For each term, let's see. It didn't land where neither did the D. I'm telling you, the D carried it. Thanks for supporting me, Kevin. Because the ACL didn't give us any support, did it? Dad joke. We're full of them today. Don't get us started. Oh my gosh, I should have known. Yep, you know, Mr. T, should have known. Okay, so when I show the term, first term is on the board. Type what you think it's related to. Well, what is it? Here we go.
You can use the SSL feature of the key management software to be able to list all of the keys, know when they expire, and be able to renew them all from this
A
console.
record.
You might
So
also
what is the A
use
record?
SSH keys, which can be used to log in
see?
some other SSH compatible service. All of
Y'all
these
thought
keys
y'all was
are
gonna get past with that little superficial answer.
and you can see
A record. I know it's an A record. What's this attached to?
devices they're on.
Mr. T's laughing. At least like, here's the. Okay. Y'all think it's applications? It's an A record. But what's it attached to?
Oh.
Lane. Be Weezy.
A
Just
record.
sitting back.
Which makes the process of managing
Address.
keys much
Change.
You're right. It is to an address. Which address? Okay, IP address.
IP address.
Y'all are inching along, I tell you what.
You get answers to the security questions.
That's the address.
Oh, by the way, I will be sending out your DoorDash stuff
To get security
one
done.
day. Okay, here we go. When you see A record on the exam, those that have picked, yes, it belongs to an address. But which address? IPv4 or 6? You are correct, Kevin. 4. Mr. T, you got it. 4. Good job, though. Next. I gave you that answer. I mean, come on.
common way to limit the type of traffic that can traverse the network is by using an ACL, or an access control list. This is a generic term that describes a list of traffic.
Just like the firewall. Yep. That's the nickname.
It's often grouped with
Bam.
categories so that you
All right.
can create very
They get harder.
combinations. For example, you might want to use source IP
We've
address,
had this one since
destination
1201.
IP,
Yep.
a port number,
Here we go.
a time of day, or an application. You combine all of those together to create a rule where traffic may
Try to think of it. Try to think of it. Oh, hell.
of these criteria. For example, you can have
That was a good acronym. That was a
some
good
of
one.
those
All
IP
right.
addresses would be allowed access to the system.
Try to do it off your dome. Maybe you could. It'll help reinforce it when you see the right answer. So try to just go off the cuff. Because sometimes that helps reinforce, like, oh man. Ooh, Mr. T. You got half of it.
The security policies we often see in the firewall are a very complex form of an access control list. This access control list
Authentication header.
includes the name of the rule,
Almost. You got half.
A source and destination address.
I like the all hell answer. That was pretty funny. All right, here we go. The next one.
Very specific and very fine-grained security controls using the
Oh.
security policy list. Most firewall rules are interpreted by starting with the
Leah
first
says
number
access
and working down through the list.
Kevin says all pale.
This top to
Charles
bottom
says Adrian
approach is
Peterson.
very common on most firewalls that you'll run into. This can be a very specific set of rules, or they may be
That's actually good.
generalized.
Oh, access point.
Elaine says authentication protocol.
Access point. Access point. Access point.
And
All right.
most firewalls,
Let's
you
flip
get
it.
all the way through the rule base, and none of those rules.
You're correct.
Access point. Yeah, access point.
Automatically denied.
Next one, all right, here we go.
As an implicit deny. Although there is not a specific
Oh.
rule denying that traffic, the lack of any other rule matching that traffic means that we implicitly deny that traffic. In this rule set, there is an implicit deny at the bottom. You can imagine a rule 8 at the
Access
bottom of
point.
this
Something to do with
Interface.
infrastructure. You know what? It does have something to do with maybe infrastructure, maybe.
Maybe an interface.
Oh, Elaine says access point interface.
Allows any IP address from any port
Yeah,
number
you're thinking of
to
P.
connect to port number 22 on this particular device over
What's the
protocol
automatic
TCP.
thing?
You can see the allow action is the disposition at the end.
Yeah, that's the first one. That's the first word,
Port
application.
22 is commonly associated
Application?
with SSH, so this would allow anyone to connect to this device over that SSH.
Then Elaine has the last part.
Port 2 is a
Mike's got the first part. Elaine had the last part.
remote IP
Oh, application programming interface.
Look in the chat.
over local port number 80. running
Application programming interface.
Oh.
Boom.
Yeah.
and all of that traffic would
There you go.
Well, if we're allowing port 80,
Here we go.
on West
Next.
River, then we're probably also going to allow port 443 and the next
Come on.
rule
Right, people.
set is port 443
But what's the full name of it,
allows this service. Port
Dark ACP. I don't know, but I know what it does.
I don't.
Okay,
It's,
I'm gonna take this answer. Oh, there it is. Leah's got it. Automatic IP address and automatic private IP. Mr. T, all y'all got it. Kevin, yo.
automatic private. Oh, private protocol. Okay.
Automatic private
Yeah.
internet protocol addressing. We'll know this if we see these 3 digits in the first octet.
Yeah.
What are they?
Yeah.
And very similarly, we have rule 6, where we can connect to any remote
169.
169.
23
127 is the loopback.
Yeah.
local port.
172 is a class B address.
Port 123, of course, would be
Yep. You got it. Okay, here we go.
port NTP. And then lastly, our network
Ooh,
administrator.
this one stumps y'all all the time. I don't know why. Y'all never seem to get this one.
Or use any other aspect of the internet control.
Okay, y'all got it today. Address risk.
Address resolution protocol.
Rule 7, it says that any
Yeah, address resolution protocol.
Matches
Yeah.
the MAC address to the IP.
address or port number is important, but it's only part of the
X.
security posture that we might want to present. There are
AUP.
other ways to filter traffic. One of these is through URL filtering. This allows you to
Trust and believe these will be on the exam. So we gotta look at them and kind of look at them and see what's going on.
a category of URL.
Authorized user protocol, authorized user policy, or acceptable use policy, excuse me. Authorized use policy,
Allow list or block list for an organization.
acceptable user policy.
URLs that people
User
to visit, but we might have to put
policy.
hundreds or even thousands of
Acceptable user
URLs in the database to
policy.
make that
You
happen.
got it.
It's much easier if we can.
Acceptable user policy.
use policy. Charles got it
And
too.
that's what most URL filtering devices.
Way to go.
They might allow you to allow or disallow.
All right, here we go.
access to
Ready for the
browsing
next one.
sites, hacking sites,
Bam.
travel sites, recreation sites, and many other
BGP.
When your granddog's in town, you
Bet you won't get this one. It doesn't mean burgers with pickles. Does not mean burger with pickles.
Giant.
You're right. Mr. T got it. Charles got it. BGP. Border Gateway Protocol. Yep. The ISP. That's how they move your stuff around on the World Wide Web. Dub.
ways to access websites without having to go through
All
the
right,
filter.
here we go.
For that reason, we often combine URL.
Brian just so chill back there.
Starting from
Prevent any type of circumvention
I mean,
of our security rules.
oh, let me just
I
take
ain't
a look
seen
at
Brian
it to
sitting in
refresh.
there responding. Come on, Brian, get in, man. Maybe he had. Maybe I ain't been paying attention. We just waiting for this ad.
The second line from the top after
Break it.
the
See, look at that. B and C.
where it said, oh, the second
He's
paragraph.
enjoying the calls of Alaska, giving him peace. Yep.
But other types of data may be used for content filtering as well.
You're
Okay,
right,
hold
Leo.
on. Let me
It's
pull up
banned
the
at
let me pull up
something.
the original just so I could give you a good input on
Connection
it.
is unstable. No problem, Mr. T. Yeah, Charles. Bayonet Neo Consulman. That's the name of the connector.
Traffic from traversing the network. Some
Yeah.
organizations will use content filtering.
I just had to jot it down. That would have been an all-day issue right there.
Content being shown on
But yes, it is a bayonet connector.
for your parental controls. And one of the most common types of content filtering are built into our antivirus and anti-malware software. We're looking for malicious software being transferred across the network, and this software will filter any of that bad content. One of the challenges we have is making services.
That's what gets people going in and wrong. Like, what? What makes the green grass grow? You're right. The other one is it is service set identifier. What's the
This allows us to
dang
create
it?
a separate area of the
Dropped it from
network that
me.
is
Dropped it from me.
specifically designed for visitors to
Yep.
our network. This allows
Now,
us to access services.
You need to know the difference between
web servers,
SSID. That's what the wireless access point broadcasts. The ESSID is what the
Hold on
wireless
1 minute.
access
I'm
point
pulling it up right now.
broadcasts to other wireless access points in infrastructure.
On the firewall console.
So it's the broadcast address of the router.
Okay, so on the second one,
So you know the
it's just
difference, in case on anything.
so it's just it's specifying that if relating to like your platoon sergeant that this is gonna be if you want to tell them that you're gonna be reporting to Goody or to anyone, you could put that in there. It's just to like you don't necessarily have to put that you're gonna be reporting to each day, but that's just to let them know that if you want to put that you're supposed to report on a regular day to your platoon sergeant just to let them know. So what mine was specifying is that I would be reporting at a certain time every day to give the platoon sergeant an update based on accountability. But you don't necessarily have to do that on a daily basis because they already know where you are and what you're going to be doing.
Or perhaps you'd like to prevent anyone from an untrusted part of the network from being
Yeah, because that's the reason why I really blacked those out. The other specification was that was just extra things that that was put in there. But as long as they know what you're doing, the dates, and when you're doing it, and that your commander, your platoon sergeant is tracking, then that's about it. And I obviously block out the commander's information too.
We can make a security zone where the internet is first connected to our firewall, and then everything else on the network can be another security zone. We can then name these zones. One of them might be the untrusted zone.
Oh, are you the one gonna write it, or is it the commander?
Which is the inside of our network.
Oh yeah, you don't need anything else extra. What I block out was in the first one was my dates, and on the second one that was only just specifications that when you're gonna be reporting and yeah, and go ahead, go. Oh yeah, that's good because even the part at the bottom on the second paragraph where the bottom that I blocked out, that was just extra information saying that if your platoon sergeant would have didn't like hear from you within a certain time, let's say 2 or 3 weeks or so, then they would check on you. You don't have to necessarily put that in there.
Sometimes you just need a moment.
Yeah, that's the reason why I black out. That was unnecessary information.
Self-care has never been this easy.
Oh yeah, they don't really need anything else, not unless they specifically ask you.
Nuggets from Nature Made, the #1
Yeah, absolutely.
vitamin supplement brand.
So what Netflix will do is say for the West Coast, we'll put a C.
Yeah, are you doing the same CSP?
This video will look at how to troubleshoot different aspects.
Oh, either way, that is good too. And so what's the VA is gonna also pay you as well while you're attending it.
You know what? That's a good way to say it.
So that's pretty good. All right, nice. Anything else you need, just let me know.
We can then establish a plan of
All right, yeah, you're welcome.
verify full system functionality.
All right, good night.
Here we go. When we are identifying what the problem really is, it might be very obvious. You might walk up and
I must admit, I forgot this. I didn't know this.
That's
We both will find out.
where the problem happens to be. But often the issue is not quite so
I'm gonna get some guesses and then I'm
and you
gonna
might
flip the
want
card.
to see if you
Because I can't remember in my mind what CDP is. Is that song one?
One of the best places to go
Content
for
data
information
protocol.
is the users themselves.
No,
What are they experiencing?
All right, let's
What are
see what it is.
associated with this problem? Those experiences can be combined
Cisco
with statistics,
Discovery
metrics,
Pro. See, I forgot that.
routers, switches.
That is used in routing.
Cisco Data
The Cisco
Protocol.
Discovery Protocol is used in neighboring,
Single symptom that we need to solve.
sharing tables and data with neighboring routers and switches. Remember that? Yeah, it does do that.
One of the questions we should often ask ourselves is, what has
Next.
changed from this
The sugar,
configuration
the
today
sugar
to what we were
factory.
using yesterday? Is someone in the wiring closet
CIA.
cables around?
Oh,
Powered off? Did we make changes to a
CIA triad.
Cisco
So what's it mean?
Cisco interface. Cisco interface.
Central Intelligence. Central Intelligence Agency. Kevin
Authentication.
beat me too. And it's funny. Cisco interface of things. Now you make stuff up. Cisco authentication interface. Oh man, it sounded good though. It sounded good. Confidential integrity. Charles. What are you doing over there? Cool is awesome. That's so funny. Here we go. Let's flip it. Availability. Yes, availability, authenticate, confidentiality, integrity,
Oh.
and availability. CIA. It's the T for the win. This is a fun way to learn this stuff. I wish I would have learned this stuff like this. All right, here we go. Next. Michael better know this one.
Cider.
This
Wow.
is a forward in his side.
And if you can eliminate different aspects of the environment,
Cider, we sipping. Yes, we are. We sipping on cider. What is it? What's the full name of it?
obviously is not directly associated with
Michael, what's the full name of it?
the probable cause might
So, James, I'm gonna get you.
Let's put together a series of steps where we can
Kevin says, a really cool and confusing system that confused me, but is used to break all of the rules of the internet. You're correct. It's used to break all of the IP assignment rules of the internet.
change that configuration.
Michael says, I need to go back on this lesson and reinforce my knowledge on it. As we all do. You're correct. It is classless routing, classless interdomain routing, and Charles came through with Michael. Yep, y'all coming through. Yep. What lesson was this one specifically, if you know? Which one is this one? This is CIDR, classless interdomain routing. This is when we made slashes. We looked at a slash on a bit position, and we figured out how many hosts you can have on there,
Yeah.
how many LANs you can create, and what is the subnet mask.
many times, the production network
That's the
cannot
one.
be touched during the day, and you have to
Next.
change control to make any significant changes. And of
CLA.
course, if we're going to be making any changes to our
Oh.
production environment, we need to be prepared for anything.
I watched that TV show, CLI Miami. Don't y'all watch that?
And if we run into
CMD.
Command line interface. There y'all go.
if that runs into problems, we might even need a plan C.
All right, here we go.
Nice.
If you're following the normal changes.
Be Weezy, I see you back there using Google.
Also,
All right, here we go.
just in case you
Yeah, C name.
before you even start.
Ice Cube, O'Shea Jackson.
Identify what we believe
Canonical name.
Canonical name. Yeah.
It is DNS related.
Something.
www something dot. You're correct, because you can point it to another from another website,
Yeah.
another name to an
Yeah.
IP address. Yeah,
Yeah.
you got it. It's the nickname.
Yeah,
Yeah.
nickname. Yeah.
Y'all all got it.
Some companies, the folks that implement the change, are
Right.
different than the folks that
Next.
determine what change needs to be made. So you might have a troubleshooting team.
Now, if y'all don't know this one, we about to fight.
That's handed off
We're gonna have a virtual fight.
Central processing.
Central processing unit.
Yeah.
All
Central.
right.
made the appropriate changes.
Yeah.
Now, if
Processing.
they come up with another name, I'm gonna look silly.
Yeah.
The CPU.
Yeah. Central processing.
All right, here we go.
The problem they saw before is really now resolved.
CRC. Central
Uh-oh,
routing.
I think I got y'all here.
Involves the end user or the folks that identify the problems.
Central routing.
This might also be
This
sit down with those users.
Aaliyah just drops the first word, cyclic.
Cycle. Central routing cycle.
Golly.
They might have ideas of things
Don't I
that
look crazy?
might work better.
Central
You
routing
might have
cycle.
ideas of how you could prevent this from
Cyclic.
And of course, nothing is finished until it's documented. We need to
Redundancy.
Central redundancy cycle.
but we need
Check.
to identify what change we made that
Bam.
resolved this issue.
Oh, central
This way we
redundancy
have to
check.
run
Yeah.
into the
Okay.
issue
If
again.
seen
Now,
on, because there's one question on the
See exactly what we did
009 that
to
talks
solve
about this.
In many cases,
Talks about an
there's
IT
a
administrator.
database or
They
knowledge
do
base
what?
where we can
Michael gave a great story when he was checking satellites and doing this.
we'll be able
What
to
is it?
easily find and
When do
reference
you
this
use it?
information that we worked so hard
Central
on today.
redundancy.
So that's the trouble.
It's somewhere in the connection, right? So when are you running this?
Gathering information, symptoms, talking to users.
Check the system.
Determining if anything.
It's checking the connection. It's running through to see how many drop packets you have, right? Because inside the packet is verifying it's being received, passing the data check. Correct.
Our theory is correct is to put it to
Yep.
the test. So we might
Oh yeah, not traffic sniffer, but it's passing, it's checking to see that the data is actually making it and being returned.
Oh.
Round trip to make sure it's getting back to you. Drop too many packets, yeah, your cyclic redundancy check is bad.
identify the fix in the lab, we now need to put
I like to associate when you use it. All right, Dak, and not Dak Prescott from America's team.
window, implement this into our production network.
Them Cowboys. What about them Cowboys?
To see if it really resolves the problem. And of course, we
That
can
access
document this
control.
entire
Hey, somebody got a
process
question.
so that
Kevin says I got a question about the internal clock. Go ahead, since we're here. What's the internal? What's
All right. Yeah, I'm just gonna talk it out. So we were talking about the clocks and you sync them up to the network clocks.
Mm-hmm.
I know with like the phones, we can, because the wavelengths are so short, we can do 3 per cycle kind of.
Mm-hmm.
When we do the synchronization of the clocks, can we offset them to where it's like one way? Or do they have to be synced up perfectly? And if they are synced up perfectly, it takes a few milliseconds to send the message to each system. Does it account for those milliseconds?
Yeah, it
in
counts.
the process.
Yeah, it
Oh,
counts.
so if it's like 1 second and we're gonna pass it on to this and you hit 53 seconds latency or 53 milliseconds latency, when it gets there, it's gonna say 1 plus the 53 milliseconds.
The
When it gets
protocol,
there.
yeah, when they created that protocol and then for it to be used, when that frame is tagged to be used with that protocol, it takes into account during your session, your initiated session, for that information to go back and forth, it will account for that.
So it knows exactly how much latency and it just throws that right into the calculations. As
Yeah,
it's doing
everything
it.
has a tolerance level, right? If you get too much latency, the worst thing is you're gonna get kicked off the lines. You can't hold a stable connection, no matter what it is. Right? That's what the cyclic redundancy check helps to do.
Okay.
Yeah, it ensures that packets that are coming in, that traffic can be sustained at a reasonable
When we're on that time system, we got two-way traffic. It accounts for both directions and all the latency that's involved in every transfer of any packet.
Yep.
The entire time.
Yeah, so say like you have your NIC card, gigabit NIC card, you're using the proper gigabit cat cord or cat cable. Everything's up to standard at every connection and it's still dropping, then there's something else going. There's a major problem somewhere else.
Okay.
You know, so somewhere between the origination and the destination, something isn't being worked on, or it's not right, or not configured right.
So you're telling me that the computer has to do math to even accept anything before it even does the math to decrypt it and do anything with it?
Through the processor, it's doing all your mathematical calculations.
Man, I want to be as smart as a computer.
Me too.
Like Rain Man.
Yeah, but that's why y'all got me. I failed trigonometry. All right, but good question. Good question. There's a lot of mathematical algorithms involved in all of this stuff that I have no clue on how to do.
Do we need to know any of that math, or do we just need to know that that math exists and the computer does it
Yeah,
for
like
us?
the basics.
You just need to know it exists and it's done for you. I have never ever in the history of doing IT had to sit down and figure out a mathematical algorithm for anything.
Okay, so we just need to know where to find answers and make the computer do the work for us.
Yep.
That's kind of what it sounds like.
Yep.
Oh, this isn't so bad.
Yeah. That's the life changer statement from Kevin today. Well, hell, this ain't that bad after all. Yeah, man. You won't have to pull out a calculator at work. Maybe for IP addresses. But anyway, if you get past 1,000 something. But other than that, no.
Yeah, that's pretty good.
Calculate stuff like that. Michael says, I was told to take the college class and taste this by clip, telling me to help me with some degree, and he tells me, fail 6 times, yet yeah, walk away. Like, yeah, IT ain't that bad. I told y'all, I look smart in the first 5 weeks. When y'all figure out the system, I don't look that smart. Because y'all start understanding it. You get what I'm saying? It starts making sense. I look like a brain in the beginning, but then you figure me out. Like, this dude's been hustling us. To teach this, you understand. Yeah, well, thanks. Yeah, I do understand. That's the big thing. That's because we become geeks. Yeah, y'all start geeks. All right, let's go to the next one. Ooh, let's get to one. Darn it, we gotta add. So how's the weather? No problem, Michael. I understand if you gotta go. If you gotta go, I'll clock you out. It's raining and cold. Leah said, okay, it's raining here too. All right, y'all, let's do this one. Let's see what this one is. Y'all remember this one? I skipped past the other ones because we have no need to learn after the exam.
Oh, DDoS.
Kevin says I don't have to water my yard today, so that's nice. Delayed. Okay. Distributed denial service, Kevin. Distributed several attacks at the same time or separate instances.
All right.
Way to go.
What was that? DHCP.
Oh yeah, y'all should come on now. Y'all should know this.
Data host.
Jesus. What you got? What you got, Jesus? Dynamic host configuration protocol. Yes. Yep, config protocol. Yep, for IP addresses, baby. Yeah. DLP.
That's how we get the term unshielded twisted pair. There's also a type of
Dua Lupa? I wish. Dua Lupa, man. Shoot,
That's
those
a
are
lost.
concert anytime. That girl can sing.
That's a lost protocol.
Shield and twisted pair has a shield either
I like
around
playing her when I do my DJ sets.
or around
All right.
individual pairs inside of the
Data prevention.
Data
What's
loss.
the
You
L?
also see that shielded twisted pair has a grounding
Yep.
wire, so you can ground
Data
your
loss.
Data loss prevention.
Data loss.
Here's a shielded
Okay.
twisted pair cable
Next
that not
to-
only has a braid around the entire
DNS,
set of cables, but each
the,
individual pair of the cables is shielded. You would need to pull those back
Domain name service. Yes.
45 connector
You got
or
it.
punch
Yep.
it down to a punch
Or
down
si-
block.
I say service all the time.
Wires inside of
It's
the
actually
cables
system.
are
Domain name
Either
system.
way,
Okay.
everybody in IT knows exactly what the heck you're talking about.
Yeah.
You don't need to get that granular.
Yeah.
Okay, we know what it is. All right.
on another pair of wires.
Next.
We refer to that interference as crosstalk.
Kevin says you played me like
This
a.
crosstalk value describes how much of that signal.
This is the one I told you where if you don't want a private investigator finding you by looking at, there you go.
Over from one wire to another. One of these crosstalk
Security
mechanisms is known
extensions.
as
Yep. Domain system security.
near-end
Yep.
crosstalk. This means that we are measuring.
Don't
how
put your
much of the
address and
signal
personal information on that domain.
other
We gonna
wires
find you.
At the closest end next to the testing device.
Don't worry about, okay,
This
this
is the
one.
strongest part of the signal, and often that is the first crosstalk value we'd like to see. But we might also want to see crosstalk values at the far end of the cable.
Of course, y'all do
Refer to
that.
that as far end crosstalk. These two measures.
I don't want DOT. I don't want DR. This one you need to know.
Happens to be shared between
Yeah.
those wires as it's going from one end of the cable to the other. You
I
might
know.
also find that there's crosstalk.
Be Weezy,
that
you know what it is?
transmitted from another
Brian's
cable.
like,
We refer
heck
to this
no.
as alien
Here's the
crosstalk,
access.
because that's
Hey,
how we
Zeus?
describe interference that's
Leah?
from other cables.
Okay, let me give you the first one.
Crosstalk ratio, or ACR. This allows us to compare
Encryption, authentication,
is attenuation, or it's our signal
protocol,
plug into a connection. The other value is near-end crosstalk.
Okay.
over
Compare
land.
versus
Boy, was that a combined effort.
different wires. We can often see this as a
All of y'all were getting
Okay.
like dropping each letter.
Yeah.
Between all of y'all fit that together. Good job. There you go, the dream team. Y'all did it.
good signal is getting through the
Woo!
wire versus how much is noise that
It was just dropping like hotcakes. Y'all had it.
obviously like
All right, here we
the
go.
ratio to be very large. If we had a 10-to-1 signal to noise ratio, our signal would be 10 times stronger than the noise. But if the
Bet y'all ain't
ratio
gonna get
is
this.
1-to-1, your signal and your noise would be exactly the same
And
strength.
That's not a real word. It's not.
If you're seeing a lot of
Dang it.
it's
Aaliyah,
related
she blew it
to the
up.
touchdown or the connectors that you're putting on
Enhanced interior gateway routing
Might be worth
protocol.
reconnecting that particular cable. You also want to be sure to
Is it
maintain as many
distance
twists as
vector?
you can in this cable. You obviously need to untwist a
So
little
what's
bit.
how's it measured?
Either put it into a punch down block or into
Enhanced
a
interior gateway routing protocol.
But you
Is it
want to
hops?
maintain as much of
Is it
that
distance
twist as
vector?
possible. Category 6A
I see.
has
There you go.
increased
I
cable
added
size,
something on the
and
end.
many category
So
6A
it's
cables
Distance.
distance. Yeah. Yeah.
That's very important to
Yeah.
know for the exam. You have to drop it in a category. You might have a PBQ where they say slide link state, distance vector. Link state, distance vector. Right? So you gotta look at it. Proprietary to Cisco. There you go. And one more for the win. We're gonna do one more. Here we go. No, you don't have to. Well, you'll clock out as soon as this last one.
It's always useful to
You know,
minimize the amount of EMI or electromagnetic interference that we would have.
You got it.
Both
Yeah.
on an unshielded and a shielded cable.
Thanks for playing these reindeer games with
Protect
me.
the wire that is inside
They get fun at the end of the day. I get a laugh.
shielded cable and maintain
Yeah, I like it. I like doing these.
that particular cable run. If there is
Kind of
a
like
break
today's
in
school
that
session
shield,
isn't.
the possibility
It's
that
the sin of life. It is.
interference will get
Does
into
anybody
the
have any
wire.
questions
There's
for
also
me?
a minimum bend radius that you can use, and you'll want to check when
All right.
the document-
Tomorrow is favorite shirt Friday.
See just how much of a bend you can make to that cable without causing.
If you want to wear a Hawaiian shirt, do it. If you want to wear a jersey, do it. I don't care what. Well, at least I was gonna say I don't care what. No, I need you to have a shirt on. I don't need you to sit in the class with naked. Put a shirt on. Put your favorite shirt on. Is that cool?
It's also useful if you avoid any of these
All right.
extra sources.
If you don't have any questions, I'll stick around till everybody clocks out. But if you don't have any questions, skibby hip,
And any fire prevention
and
components.
see you in the morning.
All of these can put out electromagnetic interference. That interference can find its way into your network cables. And if you're wondering if your cable is coming close to one of those sources of interference, you can always run a cable test and see what your signal to noise ratio might be over that link. Attenuation describes a loss of signal as it is sent over a particular distance. Attenuation is something you'll find both in copper cables and in fiber optic connections.